Right. So I think we will start. So good morning, everyone. Welcome to this 162nd edition of the Zak World of Façades conference series. My name is Ahmed. I'm part of the organizing team here at Zak. We are back to Vancouver again. We had a great first edition last year in May. And we have all new program this year with new speakers, new topics being presented. I'll quickly introduce the event to those who are attending it for the first time, and then we'll get straight into the proceedings. So we've been organizing the Zak World of Façades conference series since 2012. As I mentioned, we finished around 160 editions. This is edition 161. Finished this conference in 42 countries around the globe. Should touch 44 countries by end of this year. This is our event lineup for 2025. We've got conferences all across the globe, from New Zealand up until Canada. All conferences are different because facades are designed, engineered, installed differently in different regions. Certain regions, it's all about embodied carbon, low carbon. Certain regions, it's about complex geometry or value engineering. So no two events are the same. They're all curated for the respective local regions. And this is our lineup for 2025. A lot of events, a lot happening in the Americas region. We go back to Toronto and Montreal, which we had great first few editions like Vancouver last year. So Canada is one of the few places in the world where construction is really booming. So it's great to come back here. These events are all courtesy our event partners. I'd like to acknowledge all of them. So I'll take a couple of minutes. I'll introduce what each one of them do. To the best of my ability. All of them have a tabletop outside. Please do visit them in the networking breaks and the lunch break. Our presenting partner is Rainers. So Rainers is a Belgian company. They are into aluminum door, window, curtain wall systems. They've been active in the Canadian market from the last 6-7 years. They're growing. European systems are known for their high performance features. Rainers is right up over there. Then our associate partners, AFC is American Fiber Cement Cladding. So as the name rightly says, they're into fiber cement solutions. They're also partners of Swiss Pearl, which is again a European fiber cement cladding company. Alucoil is from Spain. So they've got non-combustible composite, aluminum composite panel solutions, honeycomb and other products for the cladding segment. Apex Extrusions is from here, one of the leading aluminum extruders out of this region. Cosentino is from Spain. They are the world leaders in a sintered stone product called Decton, which was earlier a kitchen top, which has now been engineered to be used as an external cladding material. Engineered Assemblies here from Canada, again a distributor of a lot of European products for terracotta, for ceramics, for fiber cement and breather membranes and a lot of other products. Equitone from Europe is another fiber cement cladding company. So fiber cement is picking up a lot of momentum. It's a naturally non-combustible material and it's picking up traction in projects across the globe. Euromax also from Europe. They've got coil coating solutions for cladding and building envelopes. Greenlight is from here. They are partners of Vetrotech, which is the fire-rated glass of Saint-Gobain. Sage Glass, which is the electrochromic dynamic glass solution from Saint-Gobain, and a couple of other fire-rated products. Guardian Glass, again, needs no introduction, one of the leading value-added glass processors out of North America. Hydro Extrusions, one of the biggest global aluminum extruders, known for their low-carbon aluminum solutions. Longboard from the US, again, they've got some aluminum cladding solutions with various wood grain finishes and other finishes. NBK Terracotta from Germany, it's now part of the Hunter Douglas Group, again, specialist in terracotta cladding solutions. Northern Façades here from Canada, part of the Flynn Group. They've got some rain screen cladding systems and other value-added products for rain screen facades. QDP is from Vietnam, so they are one of the leading Vietnamese facade contractors exporting unitized panels across the globe. Rockwool, again from Denmark, again pacifier protection solutions, thermal insulation and other fire saving products for the building envelope. Rotoblas from Italy. So Rotoblas are known in the mass timber segment. They've got a lot of products for the mass timber segment, but now they have increased their portfolio into membranes and other pacifier protection products to extend to the conventional building envelope also. Aesthetics from Toronto and MSI from the US. So Aesthetics does the rain screen cladding system and MSI has the ceramic cladding tile. Together they are partnering as one solution. Sound Solutions, again from Toronto, distributor of a lot of value-added products from Europe, from breather membranes to terracotta to fiber cement to GRC, you name it. They've got all the value-added cladding, non-combustible cladding materials. U-Kon from Germany, they've got rain screen cladding systems and some solid cladding aluminum panels. Eckelt is a Vanda Glass company from Europe. They are a value-added high-end glass processor with some jumbo-sized glass and curved glass capabilities. Vitrum Glass Group here from this region, one of the leading value-added glass processors from this part. And of course, our next few events are, our next one's actually next week in New York, so we finish this and we go to New York. So New York's our second biggest event in the series, with close to 700 delegates attending. That's a 3-track event, so we've got the hall split into 3 tracks. We've got lots happening there. New York is one of the bigger hubs for facade engineering in the world, and the biggest is London, hands down. I think London's leading the way in low carbon design and engineering globally. There's no other city second to London which has done so much of advancements in embodied carbon and low carbon engineering. London's our largest event. Close to 1,000 delegates attend over the day. We also have the Gala Awards dinner, which we organize along with the Society of Facade Engineering post the event. So that's a big party there in London. And we have a lot of people from mainland Europe who also attend that event and from across the globe. So that's our big one. And of course, another one we are doing with Rainers end of the year is in Morocco, Casablanca, one of the faster growing countries in Africa. And our calendar of events for the Americas region for 2025. Of course, we're returning back to Mexico City. Sao Paulo's new, we're going to Brazil there. We go back to Seattle, Boston's new for us. We go back to Miami, Montreal's. We go back again, Chicago, we go back. Atlanta's new for us. Toronto, we go back again. And New York City. So these are our events for 2025 in the Americas region. And yeah, so this is what we've been doing with these events all across the globe. As I said, they're very different in different parts of the world. No 2 events are the same. In the Middle East, they go berserk with the kind of projects they're doing over there. It's just phenomenal. So you're talking of complex facade engineering, whereas it's the complete opposite in Europe. Very few new build projects are being spoken of. Everything is adaptive reuse. Everything is what you can do with an existing building and how you can reclad the facade and things like that. So for us, it's very interesting. Asia is completely different. Asia is all cost, value engineering. So events are very different in different regions. So all these events are specially curated. Even today's program, we've got some new topics which we didn't cover last time around. So they are going to be covered today. So I hope you'll enjoy today's event. We are recording today's event. So those speakers who have allowed us to share the video recording with you, you'll get a YouTube link and you'll find the recording of today's event a week from now. And that's it from me. I'd like to call upon today's event host and convener, Sophie Mercier. She's a co-founder of Evoke Building, so she's going to be hosting today's event and she'll be taking you through until the end of the day. I hope you enjoy today. And sorry, not to forget, we have a post-event reception after the event, so if you can stay back for that, would be much appreciated. Our vendors would love to network with you over a drink. Thank you so much.
Well, good morning, everybody. Thank you for showing up in such great numbers this early. We have what promises to be an excellent day of presentation. And for those who are entering at the back, don't hesitate. There's some front row seat here that you can come in and use. I don't mind if you walk in. So before we start the day, there's a few things I would like to mention. First and foremost, I want to acknowledge that today's event are happening on the unceded territory of the Musqueam, Squamish, and Tsleil-Waututh nations, and we are very grateful for this opportunity. I also want to say that for those of you who are seeking AIBC or AIA credits, the registration sheet is at the sheet for signing up is at the registration desk at the front, so you can go and sign up at the end of the event. And finally, the venue would like me to remind you that they prefer for you not to bring food into the room, but you can bring coffee and stay awake all day to listen to the great presentations. So with that being said, we have a very full program today. So we'll try to keep on track with time, and I will try to stay out of the way as much as possible. The first presentation is about development, very impressive development in Vancouver. The Oak Ridge Park development, a new hub, really. I don't know how many of you have had the chance to drive through the city and see how impressive that site is. It is impressive not only by its scale, but also by its form. And today, we're going to have a team of 3 colleagues at Henriquez Partners that are going to talk about it, designing and building an architectural envelope inspired by natural forms. So I'd like to welcome Nunes, Brad McCoy, and Chris Boldt for their presentation. Thank you, gentlemen.
There we go. Thank you very much for the introduction, and thank you all for coming here today. My name is Nunes. I'm Principal Henriquez Architects, and joining me today is Chris Boldt and Brad McCoy, both associates with the firm, and they both led the design of the design development for the parts of the building that we're going to be talking about today. Oak Ridge is a very large project, if you've seen it, but today's presentation we're going to focus just on a small but quite important part of the building envelope. I'll start by talking about the concept that informed the design, and then Chris will come up and he'll talk about the development of the curtain wall system, and then finally Brad will come up and he'll talk about the development of the street wall and the canopy. So the current phase is about 3.3 million square feet, and it involved hundreds of consultants that contributed to the building design. The owners of this project are Quadrille and Westbank, and our role, Henriquez, we were the design architects. And so we took the project from rezoning through to the development permits, and then but we continue to assist the architects of record, and the architects of record are Adams and Associates for the non-residential and Diamond Schmidt for the residential portion, just to ensure the design intent is carried through the working drawings as well as the construction. And then the 4 other consultants I have here on the slide are the ones that contributed the most to the building envelope that we're going to be discussing today. And so that would be Glotman Simpson Structural, Introba, BVDA, and RDH. So we've been working on the project for about 13 years now. And as you can see, whoops. So we've been working on the project for 13 years, and we're excited to see it. Excited and a little bit relieved to finally see the project getting close to completion. The general contractor is Ellis Dawn for most of the site, except for the social. Can't see this. There we go. Except for the social housing and the civic center there in the corner of the site. So now I'll talk a little bit about the architectural concept. So this is a photo, an aerial photo from around 1950. And in green, you can see where the current Oak Ridge site is. And we were struck when we saw this photo about the fact that the site was part of one of the last undeveloped, fully forested large plots of land. It was owned by CP Rail, and just a few years after this photo, they sold the property and for redevelopment. And then that's when the Oak Ridge Mall was built. Now, the mall design, the original Oak Ridge Mall, it's basically a prototypical suburban modernist statement. They clear-cut the forest, obviously. They ignored the city grid by rotating it at 45 degrees. They surrounded it with surface parking. And then in the 80s, when they renovated it, they put even more parking on top of the roof. So you could say that they literally paved paradise and put this up. Then in 2010, when the Canada line was built along Cambie Street and a station was placed on the site, the opportunity to densify and redevelop the site came up. And so we were invited to work on the rezoning. And kind of two of our key principles were to try and find a way to repair the urban fabric, create a street wall along Cambie and 41st, but also to reintegrate the landscape to the site in a significant and meaningful way. So we did that first by redistributing the program on the site. We expanded the program, the retail, to the site edges to create street walls. And then we reintegrated the landscape by treating it like a blanket that we draped over top of that program. And the blanket actually also drapes down to grade in a few spots. And then some of the towers, as we looked at densifying it, we pulled up in such a way that it looked like the towers were emerging organically from the landscape park, so that the architecture kind of reflected that idea of regreening the site. And then we also placed some point towers around the site, marking entries into the project as well as mall entries. And the net result is, at the end of the rezoning, was a 9-acre publicly owned park, rooftop park, covering 1.2 million square feet of retail and surrounded by office, market and rental residential, as well as social housing and a civic center. And so today's presentation, we're going to focus only on a building that's located over on West 41st. So when we were looking at these terraced buildings, we were trying to thinking about ways that we could clad this that was consistent with the ideas that we had generated to date. And so we were inspired by this idea of the landscape being a blanket. So we developed an architectural tectonic where this idea of a veil of glass that we would stretch over the building. So we pull that veil of glass up over the facade, over top of the roof, down over onto the street side, and then covering and encompassing the podium as well at the street. But we also wanted to introduce a pedestrian scale, especially on the street side. And so we took the metaphor further and actually lifted that veil in order to reveal all the retail at the base. And then the last step was to actually pull that veil out so that it created a canopy and weather protection around the entire perimeter of the building. So this was kind of our conceptual diagram. You can see that the glass retail defines the retail, and the canopy rises in order to frame, in this case, a 2-story anchor tenant, and as well as lowering where we have minor entries and lobbies. And essentially, our presentation is about the translation of this sketch into reality. So now I'm going to call on Chris to come up and talk about the development of the curtain wall system.
So Rui has shown how we created complex forms from natural gestures. Very complex, Rui. And in order to do that, we had to answer a couple of questions. The first is, how do we rationalize those forms into forms that are informed by building tectonics and make them more beautiful? The next was how do we communicate those forms and those geometries to our partner architects and onto the contractor and manufacturer? How do we manage change? Because who are we kidding? There's always change, especially in this city. And then how was this built with human hands in the real world? We break it down into its components, from skin and bones to curtain wall and window wall. I'm going to be talking mostly about the curtain wall, and Brad's going to talk about the urban street wall down below. So the swoop of the towers is what we're starting to see on site. It's starting to become a skyline in the city. It's created by a set of control curves in Rhino and 3D, and working back and forth between 3D and a set of plans in Vectorworks, kind of like a set of keyframes in an animation going up the building. And so each of these points is a point in plan, a work point in plan. And then those same curves became the edges, the flyby edges of the curtain wall, extending all the way from the top of the building down to, I think I'm just going to gesture wildly instead, all the way from the top of the building down to where it actually touches the sidewalk in some places. So this slide flips around to West 41st, and you can see how we have the veil starting to pull up at the major tenants, lobbies, and then swoop down at the parkade entrances here and here. And it also cants out in the lowest 6 stories, creating another geometry that, combined with the faceted curves, produces a surface that needs to be triangulated. So knowing that we were going to have a triangulated curtain wall, we went out into the world and found some precedents as a proof of concept, and looked at ways that buildings curving in both plan and section were resolved. This diagram shows kind of breaking it down into component geometries. So there's a kind of profile at the top and at the bottom. This is just looking at the podium portion, where the profiles are composed of faceted arcs, which are nice and simple, and then complex NURBS curves in red, and then a few straight lines thrown in just for fun. And then the surface that's created by spanning from between those surfaces is made up of rectangular panels, some trapezoidal panels, such as at the corners, and then triangulated panels in pink, where it becomes more complex. So not only did we use Rhino and the Grasshopper plugin for coding to create these the smooth curves of the tower and to project a rational grid onto a complex surface, but we also used it to go back and analyze the form that we had with relative to input from BVDA, the curtain wall consultant. So this particular stretch of coding is looking at the vertical angle of change at the stack joints. We wanted to keep that within 10 degrees. So we're going from kind of 10 to 20 to 30, keeping that in range so that the detail works. One of the most important things that came out of Grasshopper and Dynamo for Revit was a set of work points for the whole skin from the tower to the podium, where the 4 points for a rectangular panel or the 3 points from a triangulated panel can be defined in XYZ coordinates, and then exported from Rhino into Revit, used to create geometry, and then re-exported, fine-tuned, and passed on from one partner to the next. So this is a panel in Revit using those work points to create a rectangular panel. And then here's that same rectangular panel in the model in Revit, which is faithful to the Rhino geometry, but it's still able to be fine-tuned. There's kind of intersections where it's unbuildable. We can clean that up. We can adjust the faceting down to the high heel, which is where this whole geometry comes down and touches the ground. You can walk behind it. You can kind of touch that that faceted curtain wall. So it needs to be good in the end because you're right up next to it. So these are some of my favorite slides. They're showing our conceptual detail developed with BVDA against the shop drawing that was produced by Seiko, the curtain wall manufacturer. This is a plan detail of a mullion at an inward curving faceted facade. The key really is the adjustability that allows that mullion to open and close, not in specific increments, but in a whole range of increments. And to reduce the number of dies, we came to understand that after every 7 degrees, you need a new die. So we kind of established 12 degrees as something that we were not going to want to go beyond. In the end, Seiko was working on a 5-degree increment, so kind of the right ballpark. This next slide shows the opposite direction, an outward faceting curve. You can see that this is pulled right together. And also in Seiko's final detail, they've done something different where the two sides are actually symmetrical, and that reduces the number of dies that they have to deal with. And this component in the middle is able to deal with that adjustment. This detail is at the stack joint, where we have two angles coming together vertically. And it also has a degree of adjustment right here. So that can deal with a whole range of angles. It was one of the details that evolved quite a bit through the PMU process, where the chicken head was binding at the stack joint where when we were moving it, and had to be extended to help resolve those issues. This is a picture from the PMU in Singapore. You can see the larger structure and the triangulated curtain wall on the left, the rectangular curtain wall on the right. This was an important testing ground for us. We used it as a visual mock-up. Our partner architects and RDH were heavily involved in multiple iterations. I spent a lot of time in Singapore. You can see that the spandrel doesn't have an exterior mullion, just an interior mullion, so that that whole panel can be triangulated. And then in the rectangular panels, there's the horizontal vent slot integrated. And now they're actually installing these panels on site. This is a view right down 41st. You can see 2 stack joints here and here, and that changing angle. You can also see the curve coming in and out of the plane of the curtain wall. And this is a view of the field of a triangulated curtain wall. You can see how the triangulated glass reflects the sky in a way that emphasizes the geometry of this surface. You can also see the vent slot up here in the rectangular panels. And I'll move on to the next slide, which zooms out. And you can see how the bottom of the curtain wall ripples along and finally comes down, touches the ground at the high heel, which is a good transition to the urban street wall portion of the presentation, which Brad is going to present. So I will hand it off to him. That's there.
Hear me? Here we go. Great. So the next part of the presentation is going to be about the urban street wall, which is the portion of the facade below the curtain wall that Chris had described. So by lifting up the curtain wall, what we did is we were able to create this undulating, curving surface that became the soffit of the building. And we really felt that that could become a defining architectural feature of the building, which I'll describe in more detail in a minute. And then beneath the soffit, to differentiate the facade from the curtain wall above, we used a structural glass system for the retail and the portion of the facade to which the pedestrians were interacting with. So as the soffit rises and falls along the face of the building, a series of different conditions are created amongst the various major facade elements. For example, the soffit will increase in its depth, and then it also rises up, for example, and the concrete slabs will have to react to that change by either pulling back or extending. And the 5 major street wall components that we've identified, starting from the top and moving downward, are first the curtain wall, which Chris described in more detail. And then in some instances, we have a steel canopy that we added to the end of the curtain wall to accentuate the edge condition and also help improve the weather protection. And then we have a structural steel frame that connects to the structural glass facade. And then lastly, we put a finished surface on top of the structural steel, and we refer to that as the sculptural soffit. So I'm going to start by talking about the steel frame, which we affectionately call the roller coaster, which was an appropriate physical metaphor for the project, but it turned out it was a very appropriate emotional metaphor as well in some ways. So this is an early concept sketch for the steel frame. And the way that it was composed is that we have two large HSS primary members, one along the inner and one along the outer. And these 2 primary members were then connected by a series of curved outriggers. And the entire structure, fascinatingly, was cantilevered off of these vertical concrete columns, which are in green, inboard of the facade. And as you can imagine, the steel frame was highly complicated and very large, and it needed to be divided into many smaller segments, which were fabricated, shipped, and installed separately. They were actually fabricated in Quebec by a company called Supermetal, who over the course of the project eventually became Canem. And the steel frame extended around the entire perimeter of the building, all the way around the backside as well, for a length of more than 300 meters, which for our American friends is more than 1,000 feet. And having now established this steel frame, we had a support for the curtain wall system, because the curtain wall system was supported along that outer edge of the steel frame. So of course, there needed to be a lot of collaboration between the curtain wall trade and the steel trade to ensure that that connection, where we have the curving shape of the steel matched up with the shape of the bottom edge of the curtain wall. And then on the inner portion of the steel frame, we then use that to support the structural glass system, which is shown here in pink. So the structural glass system was a double glazed glass system. It incorporated both a low E coating and also a neutral, it was a low iron glass, and also incorporated a low E coating to essentially create as clear a glazing as possible, which was important because a lot of this facade was for retail component. We wanted to make sure there was visibility into the facade. At the head condition, you can see we have our primary, one of the 2 members of our roller coaster steel here, and it supported the head of the structural glass system. Similar to the layout that Chris showed, we have on the left is our original design concept, and on the right we have our shop drawing. And given the significant height of the structural glass system, in some cases we needed to provide an intermediary support, which we achieved by adding additional pieces of steel. This is a horizontal piece of steel as opposed to the one that's undulating above it. It was applied to the front of the concrete floor slab, concealed or incorporated a typical base condition here as well as a typical head condition. And then we were able to clad the entire system with stainless steel here. And again, we have our shop drawing detail on the right. Along the base of the system, we have a somewhat typical base condition for the structural glass. One thing to note is we were able to incorporate a thermal break into the system to help improve the thermal performance. Here are a few more construction photos showing the relationship of the steel frame to the curtain wall. The edge condition that was really important, you can see here. A closer zoomed in view of the curtain wall system abutting against the steel frame. A nice view of the extended steel canopy here. You can see all of these curved outriggers. They were fabricated in pieces, as I mentioned, and had to be bolted together. Another view here showing the relationship of the inner piece of steel to the head of the structural glass. And so while the structural glass was done in a curving shape, the top edge of the structural glass, excuse me, the steel was done in a curving shape. The top edge of the structural glass was actually faceted, but we were able to accommodate the difference between those two shapes with the head condition. Another view here of the complex steel. And then this is just a fun view showing all of the highly complicated shapes. This happens to be the condition where the steel goes and touches down on the ground. And this is the archway that you'll all be able to walk through on 41st Avenue here. So now that we have this curving, undulated soffit, the challenge that we were confronted with next is how do we finish this feature in a way that celebrates it as the architectural feature that we wanted it to be. So we started by thinking about the materiality, and we could have used a more malleable or soft material like aluminum, for example. But we were really keen on the depth and reflections that were offered by stainless steel. And rather than using the typical silver stainless steel, we actually were able to use a tinted stainless steel. In this case, it's a bronze tinted material. And that tint was achieved through a vapor deposition process. So you can see that the soffit material was one that was going to extend the full length of the soffit surface from the inner face all the way to the outer face. And as you can see from this section detail, not only was it curving in and out of the plane of the page as it went down the face of the building, but we incorporated a gentle curve from the structural glass all the way to the outer edge. So how could this material accommodate curving in two directions? That was the question that we posed to KPS, who is our metal panel trade, Keith Panel Systems in Vancouver. And this is an initial mock-up they did to investigate how this would work along those curves. And what we wanted to achieve is a dragon scale, as we called it, pattern. So we took a square-shaped panel and we investigated various sizes. We landed on somewhere around 14 inches square. And then they laid out this initial mock-up for us. You can see, though, that it didn't incorporate an overlap in the panels. So in this second mock-up, we were able to work with them to incorporate a slight overlap that worked with them from a constructability point of view, but also allowed us to achieve the aesthetics that we wanted. And having now established the parameters for the material and the size and shape of these, they created then a more significant mock-up, which was really impressive for us to see. We really enjoyed seeing this. I do want to note that the material that they used in the mock-up was the typical silver stainless steel, because at this point, there wasn't yet a commitment to buy an entire coil for the tinted bronze material. But the purpose of this particular mock-up was so that we could view the material in the construction and its actual overhead position. Here's another close-up view. We were also able to use this mock-up to understand how the soffit panels would work along the edge conditions, both at the outer edge and along the inner edge here. Another view, which is a nice view showing that kind of dragon scale or snakeskin pattern. And while the construction is obviously ongoing, as you saw through some of the various photographs from before, this portion, the soffit and its cladding, is yet to proceed with construction, but we are able to kind of give you a flavor of what it looks like through these visualizations, which we think really capture the idea of this shimmering quality, which is going to also be accentuated through this linear LED strip that we've incorporated along the edge condition to wash across the surface at night. So here's a view looking west along 41st, and then flipping around in the opposite direction, looking east down West 41st. So now I'm going to hand it over back to Rui, who's going to close out the presentation.
So I was able to sneak in a few more under construction images, so I thought we'd end with that. They have started the substrate, the sheet metal substrate, under the dragon scale skin now on site. You can see that there. This is an image of the canopy coming back around over the park, so showing that continuity from the street side, which is what we've been focusing on today. Here's a little zoomed in shot showing the terraced planters coming down. And then if you look in the top left corner is the first of the balcony pods, which we didn't really touch on today. And then this is just an aerial view looking back. Here in the foreground, you can see this is the, I'm going to try this, the food hall and the food hall roof. And basically everything you see will be fully landscaped on all levels. We're even enclosing and landscaping to conceal all the mechanical penthouses for the food hall, etc. And that's a view looking east over the park as well. So our presentation today really was just one example of dozens of design challenges that we worked through, and we could probably take up 2 days of Zak presentations with Oak Ridge. Not this year, we only have half an hour, and in fact, it's going to be blinking red. I have to get off the stage. But just wanted to thank Zak and thank you all for joining us today. Hope you found this informative.
Thank you, gentlemen. That was a very interesting presentation. To see the context in which the site is located is really interesting, but to see how conceptual details goes from sketches to shop drawings is also quite impressive. Next, we have Lisa Rammig, director at Eckersley O'Callaghan. She's gonna talk, actually, I was talking to her this morning and I have to say, she's quite the jet setter. She's in Los Angeles normally, but she flew here from New York last night and she's going to Miami for tomorrow. So we're really lucky to have her today talk about the pursuit of transparency and how it changed an industry. So the stage is yours.
Can anybody hear me? Yay. Let me find a clicker. Thanks for having me. I'm very excited to be here. I'm not going to talk about facades. I'm going to talk about glass instead, and I hope I won't bore you too much. This is me looking at a lot of glass. What do you guys think? Which piece of glass here on the table is the most transparent or the most clear? Sounds like a really boring question, but perhaps allow me to tell you guys why I've been for a very long time fascinated with glass. So if we want to use glass as structures, and if we think about glass as a structural material, that's actually not a very new thing. Glass has been used for a long time to bring light into buildings. Initially, that was only possible through actually just window openings, bringing light into greenhouses to grow plants inside. And then with the development of wrought iron, larger spans were possible and glass was used as an infill material. And what developed out of that was a very early use of glass as a structural material, which was done in a way that really those very slender iron profiles were stiffened by very small glass panels, which achieved incredible transparency, as we see here, just through that combination. And we can from there then define different generations of structural glass, and I'll show some projects that have contributed to that. So where we were a few years ago, 2006, this is a project that perhaps some of you will know, the first Apple Cube on Fifth Avenue, which was made out of the largest glass panels that were available at the time to form this 10 by 10 meter cube. And these panels were connected with clamp connections that obviously are very visible. A few years later, Apple then decided that they wanted to rebuild that structure because the industry had responded to that demand of making or wanting larger glass panels, and so they rebuilt it with what was available in panel size in 2011. And we've got the same structure built twice, being much more transparent. And actually, in 2019, it was rebuilt again as the same thing, just adding more stuff around it, building a new staircase, etc. But really that the idea of generating transparency was taken through the latest technology 3 times to improve it as the industry moved on. Kind of the next generation we went to was looking at the same size. This is also 10 by 10 meter, but using less connections. So this really just uses 4 panels of glass that are connected with a silicon joint at the edges, and then has an FRP roof stuck on top of it. Now, this height is obviously then limited by the width of glass, but really this entire pavilion, which sits in a seismic zone in Turkey, is really just 4 pieces of glass. Very similar concept in California, much larger scale, is this theater, an underground theater very similar to the underground store in Fifth Avenue, an entrance space to that underground theater, which is 60 meters in diameter, and it's a carbon fiber roof that is sat on glass panels, and on glass panels only. So the roof is made out of cake slices that were prefabricated in Dubai and then shipped to California, bolted together on site. So here you see one of those little slices. They were then bolted together on site and lifted in a single piece from a temporary substructure onto the glass panels. And this being California, obviously also highly seismic zone, there's no other connection between that roof and the ground other than these glass panels. You see, though, the lights are on, and we also had to make sure that the building can actually be sprinkled. So how did that work? Actually, in each of these panel joints, which are about 1 inch of a silicon joint, there's a conduit for electricity that runs up, and in every other one, there's a sprinkler pipe. So all the electricity and water runs through the glass joints, and really the thing you get is this floating roof on the glass panels. Another concept that goes back to the idea of the Victorian greenhouses is this pavilion in Singapore, which is all glass with the addition of a very slender steel structure that helps keep these pieces of glass in place. So this, from a scale perspective, this pavilion is 35 meters tall, roughly. And it's really just very small vertical mullions that are about 50 by 50 millimeters. And then those are kind of connected, and the glass is filled in to stiffen the steel structure. And it only all holds up when the last piece of glass is set into that structure. So reasonably complex analysis to make sure that we had a good understanding of where the loads go, and very complex installation, because really here you see how slender that 50 by 50 mullion is in going 35 meters up. So they had to build a whole scaffold, three-dimensional scaffold of the entire thing to be able to hold the steel up while the glass was being put in place. And only when the glass is up, the entire structure is stable. And what you get here, you see at the base, we have this super clear view outside, and then above that are shading elements that actually make it bearable in the heat in Singapore. But an old concept just reimagined. So as we've seen with all of this, in the design with glass, it's all about the detail, because what you see is the detail, because often you don't see the glass. So the way that these traditional structural glass details that we're seeing everywhere now have developed was driven very much by Apple and by Steve Jobs wanting a retail environment in which everything was visible within a store. This was the first store in Soho where he wanted a staircase through which you could see all products within the store from every angle in the store. So again, like the cube, this was made with the size of pieces available, and therefore you see a lot of connections. Initially, these connections were bolted through the glass until a time where larger pieces of glass could be manufactured, and the use of an interlayer developed, a structural interlayer developed for a hurricane application, which could transfer loads, was then used to actually transfer loads from a metal fitting into the glass by just using shear in the interlayer. So from there, these connections were embedded into the glass, and what you get is a very smooth surface on the outside of the glass, and the reflectivity of that surface actually leads to much higher transparency. And while the fitting is still the same size, it just gives you much more appearance of that transparency. And then we're changing architects, fitting sizes and fitting design changed, but really the principle is still the same. And what you see is not so much the glass, it's really the connection. And this is just a little overview of how these connections developed, and the industry, the glass industry, really developed with this, making these connections smaller, making pieces of glass larger, developing products that allow to transfer loads better, to take movement. But really, we're seeing this is a very long time with very little incremental steps, and only when you zoom out you can actually see the innovation in this. Where we want to be, though, is have fully transparent connections. So this is some of the work that I've done in my research at TU Delft, is to make connections that are only made out of glass. This is a fitting that is an additively applied glass fitting to a sheet of glass that is fully transparent. Equally, we've got T-beams that are heat bonded, I call it, but basically it's welded glass. And you see that these connections are not visible at all. We're seeing here, that work? Only at the edge, you can see a little bit of a change in the edge of the glass distortion because it wasn't done super well. But really, here in the center, you don't see anything. It's just glass. And it behaves like just being glass. A lot of similar technology came up at the time. And again, this is already nearly 10 years ago. At MIT, a team developed a 3D printer for glass, which was then commercialized. On the right, you see that here, by a company in the Netherlands. And really, we're getting to very transparent connections. In parallel, a kind of different thing happened. We're working on a project in Hong Kong which really aimed to be very transparent with as little material as possible. So the architect wanted to use glass tubes to span 10 meters on the 8th floor of a tall building in Hong Kong with very high loads. So we kind of wondered, how do we do that? How do we get to this type of aesthetic? And because of the research work I'd done previously, I had very good connections to Schott. So we went to Schott and asked, hey, Schott, what's the biggest tube you can make? These were roughly 3 meters long, 400 millimeter diameter, which was kind of half of what we wanted at the time. And so we tried to apply the same principle that had been done for that first cube on Fifth Avenue, which used a timber lamination technique, splice laminating, to make these glass columns out of smaller pieces much longer. And so we tried the same thing with those tubes, cutting them open and laminating on top of each other so that we'd actually get to a 9 meter tall tube. Didn't work so well. After we tried that a couple of times, and because of the tolerances of the tubes in the way that they were fabricated, and also just the timeline of the project, we had to go somewhere else. So we went back to kind of more traditional glass bending techniques and thought about, okay, what can we do if we slump that glass? It's a super tight radius. Can we actually find someone who can make it in the quality that we need? It's a 400 millimeter radius at 9 meter long. That was at the time very difficult. This is roughly 2015. So we found in Precursor someone who could actually do that, who could make those tubes. And now this facade is made out of 2 10 millimeter sheets of glass with no other structure. If we compare structurally, if we made this a flat sheet, we'd need about 100 millimeters worth of glass, so we'd need 10 layers instead of just 2 layers, and really the geometrical thickness or stiffness of the glass on and off that shape makes it work in super high wind loads in Hong Kong. So it uses, as a result, also only a quarter of the embodied carbon than a thick facade would do, and it doesn't use any aluminium mullion. Back to the transparency question. So why is this important for transparency? Transparency really is theoretically just the amount of light that passes through a material, but really in glass, where we see it is impacted very much by the color. So the more layers of glass, the more we see the color and the less we perceive it being transparent. So these tubes were just really beautiful, very transparent, and really just looked like a beautiful sculpture. So at the time this building was built, it was a very long schedule, and so the glass fabricator who had invested a lot into making new ovens to actually do this had asked us, can we do something with it? Can we show this technology? Because the owner of the building wouldn't let them release any information about this facade before the building was finished. Now, they just wanted to put it up somewhere like this, and I thought, well, maybe we can make something more fun. So what we did is we took 2 tubes, leaned them against each other, and made a slide. Obviously that needed threads, and those threads needed connections. So at the time we were experimenting with a new material that was a structural silicon that is transparent and came as a sheet material that you could laminate in the same way as an interlayer. So we were trying to do that for the threads. The threads couldn't be laminated, so we did a lot of testing to actually look at how do these break. Is it dangerous if they fracture? Yes, it is, so we need to make sure that they don't break. And then these big tubes were first laminated with an SG. Here you see that structural SG interlayer that goes in between. And then the rods were fabricated, they were machined so that they would fit the radius of the tube, and they were then all placed, and the whole arrangement went into the autoclave a second time to fix these small rods into one of the tubes. That's the connection that you see in the end. And again here, because the full connection is transparent, you just see the difference in color of the glass. The rod is borosilicate, which is a different composition, so it has a slightly different color. That's the thing, it was quite big. So it's 12 meters long, 4 meters tall, and the only connection it has is a silicon joint at the top, which you see there, and otherwise it's just glass. I thought nobody would ever want to go on this thing, but actually a lot of people did, which made I was very nervous for the time that it was up in the installation. I was basically just scared and couldn't sleep for the whole time, but I guess that's how it is. So after that, people realized that actually for people to better understand materials, it's actually quite useful to do these things. It's useful to not just hand people a material, but think about what you can do with it and how you can design with it. So we did a couple more of these things. This one was interesting. A seesaw. I don't know. Do you guys call it teeter-totter too? I don't know. A seesaw made out of a single piece of glass 10 meters long. It was very thick and very heavy, 10 layers, 11 layers laminated, all sat on a central acrylic rod that would allow it to actually move. Now we need to try to get this video to work. Can you guys try to play the video? No. Okay, it doesn't want to play. I can see the... Ah, there you go. So, it worked quite well. This whole thing weighs about 1.5 tons. And people really interacted with it quite a lot. The details are beautiful, just the quality of the material makes people interested in glass. But really now we live in a time where we should be using much less material, right? We shouldn't be doing these things. So we started investigating how can we, for a large span structure, reduce the amount of material and use much more lightweight glazing. So this is an IGU that was made out of the glass that's on your phone. 0.7 millimeters twice laminated together and made on a traditional IGU line. This really is just a Gorilla Glass IGU that can be treated with coatings with anything, like any normal piece of glass, but it's super lightweight. So that's pretty cool. It's developed for a big structure in California. The idea being that actually when you do that, when the glass becomes so lightweight, obviously you need less structure, use less material, use less embodied carbon, but also it becomes much more flexible. You can think envelope in a very different way. Don't think about a window that has a frame and a handle and you open it, but you can think about a facade that breathes because it only needs a small actuator and the glass can bend, and therefore it can actually breathe independently. But, as I'm saying, less isn't really enough, and that's something that even in this world of retail structures has arrived, the fact that we have very limited time left until our CO2 budget is running out. So we know that, a third of the global energy construction is done or comes from the construction industry. We're not only using a lot of energy, we're also using a lot of raw materials, water, waste, etc. So we need to do something about that. For glass, what's very interesting, that despite the fact that glass is fully recyclable, it's actually not being done at all in the flat glass industry. The bottle and container glass industry, quite good at that, but the flat glass industry really isn't. So only 6% of flat glass is recycled, which is far too little. So here comes in a little industry initiative that we started that looks into that and tries to, in the same way that our developments of connections and our kind of demand and desire for transparency has driven an industry and has completely redeveloped that industry, we're now trying to get the industry to rethink how they take back materials and how they recycle that glass. So 2 years ago at GlassTech, we founded that initiative. It's now about 75 people globally that work together in 5 groups, and all of the stuff they are doing really just tries to make sure that we can get glass produced with less energy, but also recycle material. We know that the floating process is the most energy-intensive process, and therefore the energy we use is very important. Now, Europe is generally much better than North America in figuring out how to manage their energy consumption. In Germany, there's a big initiative that tries to actually decarbonize the entire glass industry by using different energy. Fabricators are trying to be off-grid, which is easy for the fabricators because they use less energy than the floaters. There's a lot of initiatives of reusing material, building with reused windows. Here in the middle you see a project that is quite well known in Brussels, is the EU headquarters, where every member country was asked to bring their best window frames, and out of those was constructed that building, that facade, with reused windows. This is a project in Paris that our team there has worked on, which is a heritage building designed by Jean Prouvé in the 70s. It had to be redone because it looked a little bit sad. It was built 1970 as a component facade, so a very innovative system for the time, and our team went in and managed to actually reuse most of the aluminium. The glass was fully recycled. Some of the steel guts inside the system had to be replaced, but really it came back with about a 96% saving on embodied carbon compared to making this system completely new. Then there's people that can actually open IGUs. There's developments of machinery that does that automatically so that you can take IGUs apart and reuse the glass. Saint-Gobain have developed an initiative in which they are taking glass back off buildings, bring it back into their float glass production, which poses the question about transparency, because everything I showed before is very much made out of low iron glass, which looks so clear. But as soon as we recycle, we have to think about differently about the quality. And we have to think about, do we need that super low iron glass for everything, or do we have applications where we put coatings anywhere and the glass can look a little bit differently? Then design for disassembly, everybody loves this group because it's thinking about how do we improve the design that we make now, which has perhaps less of an impact though on our energy consumption right now, but definitely in the future. But it's also about understanding how easy is it to take things apart that we have now. And what we found, this was a workshop with Enclose we did a couple of years ago, where we're trying to time how long does it take to take a typical glazed curtain wall unit apart. And we found that actually it's quite easy with the right tools to cut the glass off, take the silicon off, and much more difficult is actually to remove the fittings, screws that are gunged full of silicon, and that is what takes the time. So these guys are now in the process of developing a better design process where you would, rather than putting silicon everywhere, perhaps where you use gasketry to deal with water tightness so that it's easier to disassemble. And the last little bit is a group that deals with data, and what we've got in that group right now is a website, glazingrecovery.org, which is online now. Right now it only has data for the UK, but we're in the process of gathering data for North America as well. You type in where you are, it tells you which glass reprocessors are around you. So it tells you the recyclers, the waste collectors, the waste carriers, so that you can determine, is it worth for the building that I have to bring glass back into the process? And this group will present all of this stuff in a couple of weeks' time in a conference in Germany at GlassTech. If anybody of you happens to be there, please come by. It's all about the reuse of glass and much less about perhaps the fancy designs, which are very close to my heart, but I am very conscious that we need to rethink the way that we use material. And with that, I'll end.
Well, thank you very much, Lisa. While your flying habits impressed me, what you have been doing with glass impressed me even more. Like, that's amazing what can be accomplished in terms of structure with glass, and the attachments. Like, this is pretty exceptional. Don't go too far, because what I'm going to ask before we go into the next session is for our speakers at Henriquez to also come back to the stage with Lisa for a photo of her at the end of the session. Okay. So before we go for the break, that is. Okay. I misunderstood that. Sorry, everybody. So don't go away at the break. We'll need a photo. Our next speaker is Dan Geddes from Flynn Group. If you haven't had the chance to go and visit their plant in the Lower Mainland, it's quite an interesting visit. So kind of talk to him and see what you can do there. But what he's going to come and talk to us this morning is about a factory-controlled modular wall system. So I will invite Dan to the stage.
There we go. So I'm Dan Geddes, Business Development Manager at Flynn Group. I've been privileged to be along for the ride from inception, development, testing, all the way through to execution on this project, BCIT, which is our first modular project in the Lower Mainland. So a bit about what I'm going to speak about today is understanding the challenges faced by construction, primarily on the shortage of labour and also from a performance standpoint. Understanding the benefits of modular walling and also the challenges that come along with it. And a brief overview of TEDI and how modular helps in that space. So the construction industry as a whole, we are definitely facing a shortage of qualified people in the trades. We see the ratio of journey persons to apprentices falling across the country. But also, the same square foot of building takes far longer to build today than it did, say, 20 years ago. 20 years ago, we weren't putting 10, 12 inches of insulation outboard with big thermal clips and complex panels. So that same square foot actually takes nearly twice as long to build as, say, 10 years ago, where we were just putting a membrane and probably less complex panels on the wall. I know there's a discussion around productivity in the construction industry, but I do believe that the complexity and the improved performance is actually having a detrimental effect in that space. And that's driven by code changes. And then we have increased material costs coming, with the way the industry's been over the last 10 years. So trying to manage that in the modular space becomes a lot easier with upfront procurements and planning. And it really helps out on dealing with project delays. So these things, the modular systems get built up front and stored, and it allows that workflow to be determined and to stay on schedule. But about modular construction, prefab's been around for a long time. If you can think of kitchen cabinets, that type of modular has been in the industry for decades. Modular 3D volumetric, we've seen a bit of it with the likes of our Intelligent City, our prefab washroom pods. A lot of that is moving along in the Lower Mainland and across the world. And we're primarily going to focus on panelized construction and what we call modular. So BCIT, it definitely reduced the project schedule. The structure and facade was going up in a 2-week cycle, week after week after week. There was no delays throughout the entire process. It was quite impressive to watch. That allows you to get your building watertight and completed sooner to get your interior trades in place. Definitely an essential for mass timber projects. It's, you know, the one thing with mass timber, the trick is to build quick and keep it dry. So that establishes an earlier substantial completion and a predictability on construction costs, less on-site labor, and simplistic adjustment of the modules with easy anchors. This should be a time lapse if that can queue up. We were surprised at how fast it installed. We underestimated how fast the guys would be on site. It did address the issue that we need to up production on the factory floor to keep up. The guys actually were asked to slow down on this project because they were working faster than our factory could. But through analysis, we should get between 20 and 30 panels on a day. So you're looking 3,000–4,000 square feet of completed assembly on a daily basis. A second time lapse again. And this is no different than unitized curtain wall. And, you know, there's been healthy debates in our office. What's modular? What's unitized? How big does the panel have to be to go from being called a unitized panel to a modular panel? And they are actually one and the same thing. As you can see up the middle here, that's actually a unitized module in the inside corner. And it's the same joinery on the back. So you go seamlessly from opaque modular to unitize, but in actual fact, it's one and the same thing. Performance and liability. The best bit about modular is, you know, I leave my office and I walk the factory floor on a daily basis, but I actually get to tour the job site because it's on the factory floor, on the tilt tables. For me to, or one of the members of our team or the consultants, it's a lot harder to get into a swing stage at 200 feet and review the quality and detailing of the project. When it's sitting on the factory floor, that can be monitored heavily, which creates a far better product and far less issue with leakage, air, water, and things like that. And if there's challenges in that construction process, it can be easily dealt with immediately on the factory floor. It also allows for, you know, one-stop shop manufacturer, one installer, one warranty. It's robust, turnkey, and reduces the interface between associate subtrades on the job site and that management. It does also, however, have a heavy reliance on BIM up front to be collaborated on. Most of these projects, we collaborate in Revisto for class detection. We really want to build digitally first prior to being on site because once this is built off site, it really has to fit together, just like unitized. Logistics and transportation. This was actually a lot more challenging than you might think. You know, these loads are over heights. There were no trailers available in North America that were really suited to shipping modular. We wanted to be quick and nimble. So trailers were developed specifically open throat to get the deck as low to the ground as possible and specialty racking systems to hold 4 modules in place. But also with that just-in-time delivery, and say you're on a tight site downtown, you really want to get them off the trailer onto the hook and up into placement immediately. So, you know, just even the racking systems and how everything unfolds and gets picked up was a large challenge. And then also, these are big wind sails. So, you know, further development on stabilizing these panels under wind conditions without taglines. What you can see in the bottom photo here is there's actually 3 Abrams batteries from tanks with 2 air turbines on either side with GPS to stop the panel from rotating. So you can go memory A on the trailer, memory B parallel to the facade. So when you pick the load up, you push one button parallel to the facade, and it will operate in wind conditions higher than what the crane can operate. So there's a whole bunch of work that's gone into the background just to deal with the logistics. Safety. It's a really big thing for Flynn. It's one of our core principles. And leading edge work is really one of the biggest dangers we have in this industry. You generally get through 20, 25 square to 35 square foot per day per person if you're constructing traditionally. You know, these are, you know, out of swing stages, you know, in a harness all day. A lot of leading edge work and a big safety issue. By building modular flat in a factory, you drastically reduce that leading edge work, and, you know, barring some minor tie-ins for the silicone stripping and the chicken heads and placing the panel, you've got a roughly 1400% reduction in time on a leading edge through this type of approach. As we're further developing, we're looking at control of material use and looking at batch processing multiple projects at a time, so we can get our material utilizations up to, you know, 85-90% across the board. Basically, trying to reduce the amount of material going to the landfill through that process. And that's been looked at through parametrics and considering more than one project at a time on parts that you can use on multiple projects. So the back section is basically same from project to project to project, and the insulation system is the same. So if we can consider multiple projects at one time, we can then optimize that material usage and bring that waste number down. So just a bit of a recap. The safety, less labor, less cutting, less time on site. It creates a far safer and working environment. And it really deals with the labor shortage, you know, and combined with the complexity of the facades we build today. It really deals with those cost overruns, change orders, delays, all the costs you generally see after a construction contract is awarded, because it's all set in stone and dealt with through BIM up front. The chances of change order due to delays or change of design, we're starting to see, you know, what's traditionally in the industry, 18 to 23% change after award and going to build. We're seeing that number drop well below 10%. Again, maintaining the quality control, I can't speak enough about that. Again, get to walk the job sites on a daily basis. You know, it's just down the hall from the office. And challenging climates and locations, you know, extreme weather events. I imagine putting up membrane in a swing stage in Vancouver on a rainy December. One, what is the quality of that workmanship like? And two, is it going to keep that building airtight? It's a dry environment, controlled, same product over and over and over again. And then meeting the building codes with step codes, and, you know, they drive for TEDI 15 or passive house. It really helps, and that's based on those two key metrics of thermal resistance and air tightness. You can see, you know, if you're building air tightness or code or super airtight, as that super airtight building has meaningful deductions in the thermal resistance that the building has to have. Designing with modular, there is one big challenge in that space is when you onboard in that space. It generally takes, most of our projects are going through a design assist process that get rolled into a construction contract. I mean, BCIT, I believe, there was a 9-month design process before it was agreed upon on construction costs, and then another 12 months on site. So to kind of execute in this space, you really minimum 12 months for the less complex facades, and probably 18 months from inquiring to deliverables on site. So it's not something you can ask for and expect on site six months later. But with that, that allows that collaboration, clash detection in that space, again, reducing change on site so you have quick deliverables and, cost overruns because of that. I'll skip past that. So what's behind Teddy? You have your losses up top, window losses, wall losses, ventilation, and an infiltration. And then you have your gains below. Heat recovery gains, lighting gains, or the energy outputs from the interior of the building. For facades, we really focus primarily on the losses up top, barring the gains through solar heat, and improving on those losses, which are substantial, really helps to driving down to Teddy 15. Further to that, and again, primarily to the facade, building shape, the more complex the building shape is, if you think the surface area to interior space ratio, geometry really has a massive impact. Window to wall ratios, window performance, building envelope thermal performance, and building air tightness. If we can improve on those key metrics of air tightness and better thermal performance, it will end up allowing more freedom on your building shape, your window to wall ratio, because it's doing more of the heavy lifting. So just a quick overview, and these were the core principles of why we went down this path. We wanted to stick with the chassis or known technology that was seen in the industry. So the back section is aluminum curtain wall. It's identical to our curtain wall system. It's one and the same, completely interchangeable. And then over top, we use an insulated metal panel, be it rock wool or polyiso filled. The reason we did that is to drastically reduce the thermal bridging. The only thermal bridging that you really see there are long stainless screws that go through the panel. There are no thermal clips in it, and we've basically created an almost perfect thermal plane across the conductive side of the chassis. So it gives extremely good thermal performance. The other thing with steel, it's a phenomenal air vapor barrier. That's sealed together. The air leakage results on the test apparatus were absolutely amazing, like 10 times better than allowed for unitized. So it's super airtight. And then it gives tons of freedom on how you want to glaze, so agnostic on window openings, from fiberglass to vinyl to, high-end passive house windows, unitized. And then on the face of it, the cladding is really just the jewelry. We've tested multiple times without the cladding in place, but lots of freedom on the exterior of the panel. One of the other things we really wanted to do with modular is, modular has to play nice with structure, and having it have the ability to span from column to column allows to tighten up the stack joints. What we really wanted to see is make that horizontal joint disappear aesthetically. On the visual mock-up we have in the yard, you can't tell where one panel stops and the next panel starts because it matches the reveal lines on the panel. We really wanted to take away that blocky look. The other thing that's achieved by tightening the stack joints is the value or thermal transmittance through the joint because it's a lot tighter. There's far less thermal loss in the middle of the panel. So I'll looks like I'm well out of time, but I'll briefly touch on BCIT. It's nearing completion, on schedule. Extremely happy with how this project's turned out. Telus Ocean, is this modular, is this unitized? It uses the same concepts as our modular system, but in a vertical format. But 40–50% of it is actually the modular portion stood vertical and using that same principle of aluminum chassis, insulated panel with no thermal bridging. On this project, you get a typical R6, R7 out of a spandrel condition with backpan. I think we're getting into R30s on that spandrel based on that principle. This is a Teddy 20 project, probably one of the most highest performing office towers coming up in British Columbia. And then Vaha Affordable Housing, BC Housing Project with ZGF. This is Passive House certified. Challenging project to be involved in. Now having balconies integrated into modular. The next evolution on dealing with modular and structural connections through that thermal plane. And then hospitals. Oops, did I touch? There we go. We are also definitely ramping up in the Ontario market. Toronto Western Hospital is going into this space. Large panels, vertical format this time because of hospitals floor to floor, 4.5 or 7 meters. But again, same concept, stood vertically. And that is it. Morning break. Thanks, guys.
It's not quite the break. Nobody goes out. We have one more presentation before that. Thank you, Dan. The next presentation is from Dean White, the regional facade sales manager at Constantino. He's going to talk about sustainable facade design with ultra-compact stones.
Can you hear me fine? Good, great. Just to clarify Dan's previous point, we are the jewelry on the facade. So when you see decked and ultra-compact stone, that's the role that we play, except I need the clicker. Thank you so much. So I'm going to give you a quick overview of Cosentino and what we do, how we focus on sustainable manufacturing, how we arrive at a product that is carbon neutral from cradle to grave, talk about what constitutes an ultra-compact stone, and how you can get it on the wall and ventilated rain screen attachments or glazed into curtain wall and window wall. And we'll take a quick look at a couple case studies. I've been practicing speeding up since this is, I don't know, about my 6th or 7th Zak. We are a global company based in the south of Spain. We manufacture near Almeria, Spain. We're in 120 different countries and we go direct to the market. We don't go through distribution, etc. So we are in control of our own destiny. From a sustainable manufacturing approach, we use the 3 pillars of environmental, social, and governance. So social means we want to have a long-lasting impact on the communities that we're in, giving back and being a viable employer for the markets that we're in that is long-lasting and having a positive impact. And governance just means that we are third-party validating our sustainable reporting, and we're transparent about it, and we report it on a regular basis. When we talk about the environmental side, that's where we get into the physical part of it. So we have the approach of a circular economy. So not in the past, like manufacturer would produce a product, it would go out to market, it might have a warranty on it, but it was kind of a one-way transaction and not recyclable, etc. It goes out to market, then they forget about it and they move on. And that's the way manufacturing has been done for decades. 25 years ago, most manufacturers wouldn't be able to sell or spell sustainability. It's very much at the forefront in manufacturing these days, in particular with us. So we have this circular model, and it starts with where do we get our raw materials? We're going to source our raw materials from other companies that have a sustainable approach. If we have 2 products that are alike, one is a sustainable approach, we're going to purchase from that sustainable vendor. So raw materials is one thing. The next thing is designing the products from the beginning to be sustainable. So you're calculating embodied energy, you're doing all this, that's work up front now with the product to make it as sustainable as possible with the given technologies available at the time. Production is where you can really impact, you know, the material part, the physical part of the sustainability. So one thing we look for is best available technology, and I'll give you a good example of this. A decked-in production line is about 1 kilometer long. We have 3 of those in Spain. We have a 4th one coming on and another one going into the U.S. in a couple years. They're 1 kilometer long. They use a lot of energy, and the last phase of the production are 200-meter long ovens that the material goes into, gets heated up, gets to a liquid state, then it cools. We run those off natural gas now, but we're switching those to hydrogen. That's going to have a huge impact in reducing the emissions. Currently, we have carbon credits and projects we invest in to get to a carbon neutral status, but that's going to be much easier for us now as we move to hydrogen energy source. We also use only renewable electricity in our facility. The facility in Spain is about a 25 million square foot facility. All the electricity is renewable. We have the largest self-consuming solar farm in Europe, and that only provides us with about 20% of what we need. We use about 400,000 homes with electricity, and we use only renewable electricity for what we purchase. It's all certified renewable. Water efficiency is really key. I heard earlier a comment about water. We use a lot of water in production. And we're in the south of Spain, right near where all those old Clint Eastwood spaghetti westerns were filmed. It's about an hour from where our factory is, so it's dry. And that water is really precious. If it gets discharged, it evaporates very quickly. It's those areas where you see dry riverbeds, dry creek beds all the time, except for maybe 2 weeks of the year. So we recycle 99% of the water that we bring into our production process. We do feed a green belt around the factory with some of it, and the rest evaporates. And water is so precious, we built a treatment plant to recycle and treat the water from the communities around us as well, because otherwise their water would just get discharged and evaporate into the environment. Very, very key. We have a zero waste model. So that means if we're bringing raw material into the facility, we want to make 100% use of that raw material. We're not there right now. Our philosophy is to get to zero waste, and our R&D team's continuously working on how do we reintegrate into our products, or how do we find secondary markets for the byproduct of the production. So very, very key. So we have a very intricate waste management site that monitors the different materials, and we're working with them constantly. And the other way that is really, really important to reduce emissions is in how you're moving materials around. So in our factory, we use robot sleds to move the slabs around. And these robot sleds go from point A to point B. They're not me on a forklift. They don't see their buddies stop for 5 minutes, have a chat, start driving all over the place, then finally get to my destination, right? They don't have any friends. They just go A to B, and they keep it down. We partner with, and we look to partner with logistics companies across the globe that have a sustainable focus. I don't know if you've seen these new ships that they're testing, where they've got great big metallic sails on these freighters. You can be sure once that becomes a viable option that our products will be going on ships like that to help reduce the emissions, getting our product around the globe. Very long life cycle for this product. You know, serviceable life is easily 60 years with very low maintenance. So the total life cycle cost is low, and the energy used to upkeep the material is very low. And it is recyclable at end of life. And we calculate our carbon neutrality based on the raw material, the production of the product, delivered anywhere in the globe and delivered anywhere back to be recycled. As someone said earlier about flat glass, I think a lot of it doesn't get recycled. That's true for a lot of products that say that they're recyclable, because the cost to get them back to a recycle point is normally more expensive than buying new material. But at the end of the day, the material is recyclable. So our ultra-compact stone decked-in is carbon neutral, and it's the only one in the class that's carbon neutral cradle to grave. So what is it? Ultra-compact stone are 20 plus different minerals that we mine out of the earth that have gone through the metamorphic process. We break them down, we mix them with water to make a slurry and a powder basically, and we dry that out and leave just enough humidity in there to make a slab. So the important thing to know about these products is they're a slab product, they're not an extruded product. So from a design aspect, that means you're looking at flat surfaces, you're not looking at profiles and things like that with these ultra compact products. We then mix those, as I said, we produce a slab with them, and the first station it hits on the production line is a 25,000 ton press. It presses the slab for 10 seconds to make it ultra compact. So that's where that terminology ultra compact comes from. And then it moves on and hits 3 different decorating stations where mineral pigments are dropped on it to create the depth and the colors and the direction, all these types of things that you see on the material. And then finally, the last is the 200 meter long ovens where it goes and it heats up to just over 1,300 degrees Celsius or around 2,300 degrees Fahrenheit, gets it to a liquid state. It won't flow, of course, but it's in a liquid state. And then when it cools, the material is bonded at the molecular level, and that gives it some very interesting physical properties. First off, it's UV stable. That color will not degrade over time. It's going to look the same 40 years down the road to the naked eye. There might be some measurable difference with instruments, but not to the naked eye. So very, very important. This means it can be used everywhere, interior, exterior. We're talking about facades here, but also hardscaping, pools, all that kind of stuff, pedestal decks as well. It's non-combustible, so we have US testing, and Canada we have the Kenyon S135 test, and it's a non-combustible product. The graffiti and stain proof, it's very non-porous because of the compaction and also going through the ovens. So if you get graffiti on it, you can wash it off with soap and water the same day or 10 years down the road. It's not going to bite into the material at the molecular level. Very, very key. Low coefficient of thermal expansion, of course, being Canadians, we're highly attuned to thermal expansion. And it is relatively inert. You have to still have panel gaps, minimum 5 millimeters, more standard is 8 to 10, and that's because the building's going to move and breathe, etc. But really the ultra compact stone is relatively inert. Freeze thaw proof, it can be cycled through freeze thaw, no issues. This is the same basic technology that used to make the heat shield tiles on the space shuttle back in the day. So it is very, very highly resistant to heat and cold and shock as well. Large formats, which we'll talk about in just a minute, very dimensionally consistent. So this is a material, unlike a porcelain, although they often get lumped together, it is dead flat from slab edge to slab edge, the same gauge from slab edge to slab edge, and the same density all the way through. So there's a very highly engineered, consistent product. Very, very consistent on the dimensions. It's 7 on the Mohs scale, so it's diamonds or topaz or itself to scratch it. It's highly impact resistant. Of course, the thicker the material, the more impact resistant it is. When we did our Miami-Dade NOA testing with the missile test, we use 12 millimeter Dectin, half-inch Dectin, and when the missile hits it, the missile shatters. So it doesn't go through it. If you were to use a 4 millimeter material, which we also have, it will go through it like it's butter. So thickness has some impact, battling impact resistance. Easy to clean and maintain, low life cycle costs, like I said, carbon neutral, and has a 25-year material and finish warranty. So sizes. We have 3 production lines currently. In our first 2 production lines, we have the older ones. They produce a slab size that is 1440 by 3200 millimeters. That's 56 by 126 inches. Our third line that came on in the fall of 2022, we do 1630 by 3300 or 64 by 130, and that 64 was really, really key for us because this product is easily integrated into curtain wall and window wall and modular wall like we saw previously, and that 5-foot width was really key to work into those modules. And it's relatively lightweight. You've got 4 primary thicknesses, 4, 8, 12, and 20 millimeter, and they range from just over 2 pounds a square foot to 10.8 pounds a square foot for the 20 millimeter. Most common in facades is 8 millimeter and 12 millimeter that are used. Lots of different standard colors. Manufacturers of ultra compact come from different places. Some come from being flooring companies, primarily focused on flooring, other interior design like countertops, and their selection of colors are a bit skewed by that. So we come from the countertop world. We're the largest manufacturer of what was quartz countertops. It's changed now. And so a lot of our designs were very conducive to interior, and we did introduce over time colors and patterns that are more conducive to exterior facades, and we keep adding to that all the time. So we've got a lot of stone type products. This material is very good as a value engineered option to natural stone, limestones, etc. And we're just reintroducing a new wood grain collection as well. Some of the colors are 90% recycled content. customization is something that the industry does, and every company does it differently, and particularly when it comes to minimum quantities. So we do it for the lowest minimum quantity. We'll do a complete custom from scratch. If you send us a stone and you say, we'd like you to replicate this in ultra compact, we'll do that, and the minimum is going to be 25,000 square feet from scratch. But if we've got a color we've done before and a texture we've done before, and we're bringing things together in new combinations, then it's a 10,000 square foot minimum, because we've done a bunch of the R&D already. What you're seeing here is a project that was, base design was originally an ultra high performance concrete with a terracotta color. The curtain wall company came to us and said, we'd like to use Decton on this job. Do you have anything in a terracotta color? We said, yes, here it is. And it was a matte finish, a flat matte finish. And the architect said, can you add texture? So we added texture. And so now we are the product of choice on that project. Of course, in the current climate, it's actually on hold, that project. So we'll see when it goes. But one thing I want to point out about this is it's really important with the materials that you select that you can get involved in design assist early with the supplier to help optimize panel layouts with you, to bring down the waste and help bring down the cost. So we came in later in the design assist process here, and it was not designed with our material to begin with. So we had 49% waste in making the panels for this job. That is not optimal. I'm sure you all understand that. At the time, we only had the smaller slabs, and I knew we were coming with the bigger slabs later in that year, so I said, you know, budget it with the bigger slabs. We brought the waste down to 25%, which is still not ideal. I like to see it down in the 15, and we're really smiling if we're down in the 10, 12% range. But sub 20 is better. So our third production line not only makes a larger slab size, but we can make custom slabs off that line. And this is really key to help reduce waste and be easily integrated. So I have a project, 38% waste with the full jumbo slab, the 64 by 130. We found one that brought the waste from 38 down to 10%. That's a very big savings, especially the large at the facade. And custom colors. So what you see in the bottom there is a bunch of solid colors that we don't advertise. We have them in our back pocket because we like to compete against other material classes like terracottas and fiber cements and high pressure laminates. And a lot of those are solid colors. And we have the capability to do those colors, so we'll do them on a project by project basis. We supply full slabs. Some of our people take full slabs and cut it and fabricate it themselves, or we provide a cut to size with no holes or grooves. Often the case when it's being glazed into a curtain wall or a window wall, for instance. Curtain wall, they want to be as much plug and play as possible, so we'll cut it to size and deliver it. Or we'll cut it to size and put undercut anchor holes in it or kerf grooves on it, whatever's required for the attachment system. Always with the fiberglass mesh on the back of it when it's a ventilated rain screen or curtain wall or window wall. That's for fall protection. So if it's up at height, gets hit by a crane, the shards will stay attached to that fiberglass mesh on the back. So our latest production line 3, has higher capacity, has same capacity as our 2 older lines. It's more flexible in manufacturing. The changeover times are quicker, and we can do things like change the plates on that press, that 25,000 ton press, to create custom textures that we press into the product. That's where we put the texture in. So those changeover times are simpler, which means the costs are coming down, and we can do a custom texture on a large project. Larger format, custom slab sizes, and through body colors. One of the knocks on ultra compact materials over the years is that it's not normally a through body pattern, like you see with, say, a quartz countertop. You compact at the beginning so that, initial tests on how to get through body colors, when you start compacting, you turn it into like a 7-layer dip and it starts losing the orientation and the direction you needed to match the top surface. But we've mastered that now. So we have some colors that are through body and more coming all the time. So that's a big develop for the industry. So you can get it on in ventilated rain screens, in mechanical or chemical attachments. You can get it on in curtain wall and window wall and unitized applications, and you can get it on the wall in old-fashioned direct adhered, where you might see down at grade around an entrance, around a lobby, where the same trade just direct bonds with thin set adhesives at the entrance. So what you have here is different attachment systems that can be used with our ultra compact stone. And we take the approach that we're open to all the attachment systems that will work and perform and help us get on the wall and hit different budget points. So we're not pigeonholed into one kind of attachment system as we were in the past, where we're using Kyle anchors with 12 millimeter or 20 millimeter material. It comes up there. So there's many different attachment methods to hit the budget points, and you can glaze it in captured or SSG systems. Here's an example in Cap West in Germany where it's a unitized system. We shipped them actually the panels with the clips on them, and they hung them. And a couple local projects. We've got 8X on the Park that KPS installed. GBL was the architect. And those flat white panels are ultra compact stone in a polish. Again, the Pacific, you've got it here wrapping on the balcony slab edges with undercut anchor. And I'm just going to jump to this real quick. This is a signature project for us in Tel Aviv, the Toha, where they created some very interesting panel installs. You can see this X-shaped pattern there. That's because down low on the project, that is where the mechanical is and where the ventilation is for the mechanical. So here you kind of have form meet function. And that was the first phase, the small building. We're now working on the second phase. Starts construction, should finish in 2027, and decking is on the large tower as well. That's what I've got. Please stop by and see us out at our table, and we'll fill in more on our product and our capabilities. Thank you.
Well, thank you, Dean. Before we break out, I would like to invite Vikram Kalsi from Rainers to thank the speakers of the first session. So if you can hold on for a minute. And before you make your way to the stage, I would like just to say that the break will be about 40 minutes. We'll call you back in, but take the time to go and see the sponsor's desk and discover the products. Vikram, specialist at RDH, and he's gonna talk to us about choosing a facade for your iconic building.
Thank you. Just wanted a big thanks to Susan for bringing Zak back for another year. This is great, second year in a row, or second year. Love the conference. This is a little disclaimer, so you can't sue me for anything I say here. All right. So today I'm going to talk about choosing a facade typology. It's the little sliver of thing that we do in between having a concept and starting to put details on paper to kind of optimize what we're going to choose and to make the rest of the process easier. Okay. So this is a little download I made from the internet. Yanko Design actually used AI to do this, but there's some magic that happens at an architectural firm between looking at the land, the use, and putting it together in a way that looks really cool, that's functional. It's magic to me. I'm just an engineer. But I'm usually given something like this, right? To say, now just make this work. And to do that, there's a lot of details I have to work through. So what I'm going to talk about today is that sliver in red there between a cool rendering, maybe a model, and us putting together details for all of the different intersections and try to make the building work from an engineering perspective. First thing we do when we, especially in Vancouver these days, is we do a bunch of parametric energy modeling. This is complicated, don't try and read it, but these are all the possible paths to achieve that TEDI 20, step 3, and to achieve a certain amount of greenhouse gas emissions and embedded emissions. So we do a whole bunch of modeling. We pick a couple of paths forward, right? Here's an example of one with a very high R value, a reasonable window to wall ratio, and with that path you can choose almost any window on the market, right? Something like that, a good example of that would be what Dan was talking about, right? A very insulative wall panel, then you can use other things in that are less. Here's a path here where we use a more conventional curtain wall type effective R value, and for the spandrels, in this case, we need to use windows and fenestration that are very efficient, usually more costly, right? So we pick a bunch of paths that we know will work, and we start to look at, are they going to work for your building? I'm getting a bit of echo. So we pick a bunch of those, we throw them into a tool we have, which kind of estimates cost for differing R value, and we optimize that with mechanical and electrical, because even a small change on the facade is a lot of money. And so you can sometimes buy more efficient mechanical systems to offset some of the extra expense. But the key is, what do we use for square foot cost for curtain wall or for window wall or for an iconic facade? You know, I've worked on projects where it's been $50 a square foot, and I've worked on projects where it's $800 a square foot. And for typical typology, you know, for typical window, typical unitized curtain wall, and typical panelized systems, if the building's simple, that's an easy number. I can grab that from a, you know, an average number from the last few projects that I worked on. But once it's iconic, could be anything, double, triple, quadruple, depends on the building, depends on the form, depends on the typology. The very first slide that I showed is going to be very expensive per square foot if we built that. Okay, so one of the things you have to think about before you choose a system is how it's going to move and how it's going to interact with other things you're putting on the building. Balconies. Dan set me up for this because the last thing he said is, this works great. It's worked great on BCIT. Didn't have balconies. We add a balcony, things start to happen because things are moving differently. So we're going to talk a little bit about that. Curtain wall, window wall, site-built windows, and large panelized projects like Dan's. These are the things I'm going to talk about and give you some ideas on how to optimize the right choice before you start doing details. So once you've done details, like Dan showed, the cost of making changes goes up once you've produced a detail set. Bare minimum, you have to redo all the details if you switch systems. And we see a lot of times where you make all the details, you tender it out, and it goes to a different option, and then you have to redraw all the details, right? So that's what we want to try and avoid. We want to get that most optimal solution early as possible. So when buildings move, we have interstory drift, right? And in Vancouver, we care about that a lot because we're sitting on a Pacific megathrust potential earthquake sometime in the next few hundred years. And buildings also move like this due to wind and small earthquakes, which we're going to see in our lifetime, for sure. When buildings move like that, it's called interstory drift. When we design our systems, we design for two different kinds, elastic and inelastic. Elastic's the one it's going to see for sure during its life, and those we want it to be air and watertight and structurally sound and basically have no damage. Then there's the big one, the inelastic interstory drift. Those are bigger numbers because that's the big one. And there we're just happy we're alive and nothing falls off the building. It doesn't have to be air and watertight. Nobody's going to care if your curtain wall's air and watertight after the big one. You'll be worried about other things. When things move sideways, buildings aren't two-dimensional, they're three-dimensional. So when you have interstory drift sideways, you have in and out drift on the other side of the building. So you have to worry about those at corners. You also have to worry about differential vertical movement due to frame shrinkage over time, long-term creep of concrete, live loads, dead loads, all those things. So you have to be able to take all those movements and still have your system work. Okay, iconic building facade types. Main difference, and you can sort of go back to the two basic systems, even if you're building a speed wall project like Dan's. It's a unitized curtain wall that's really big, right? But it's based on a unitized curtain wall chassis. Other big panel systems are based on a window chassis where they sit on the slab. So the big key difference is curtain wall's hung. It's hung from the slab. It's usually installed from the exterior. Window wall sits on the slab and is usually installed from the interior. They're usually smaller panels. People can lift them. It generally has been that window wall has been a little more efficient cost-wise, but has a different look and is less customizable. But those are the basic differences between the two. Little glossary of terms, people in the room that aren't familiar with this. Anchor is the thing that holds it, dead load. Stack joint is the thing that takes the vertical movement and the interstory drift. Lifting lug is what you pick it up with. When you talk about window wall, you talk about a sill angle. That's the thing that holds it in the building, so the wind doesn't suck it out. And a deflection header, which takes the movement and allows it to shift, interstory drift. Slab bypass is part of the system that runs past the slab to simulate that slab band. So they sit, window wall sits on the slab, curtain wall is like a curtain outside the building structure. Is that a window wall or a curtain wall, right? That's curtain wall. That's classic curtain wall. I can run my algorithm to figure out, economy, because those buildings are so alike that the cost is going to be much different between them per square foot, right? They're great buildings. Every building is an iconic building, but these aren't the ones that I'm primarily going to talk about today. Those are conventional curtain wall. This is a conventional window wall building. I don't know if you've read Douglas Copeland's City of Glass. This is what he talks about on his book. This is classic window wall. Glass panels, a little smaller than curtain wall, with a opaque spandrel panel at the slab edge, where half the system goes past the slab edge. Okay, we got all that done. 3 types of facade movement: racking, rotating, and translating, right? Racking, you actually take the system and shift it. When you talk about stick-built curtain wall and a lot of other things, that's the primary way it takes interstory drift. That's why you don't see 40-story stick-built systems. They're also really expensive to do that high. Rotating, this is primarily how curtain wall works, right? It's prevented from moving sideways, and it rotates, and you allow enough movement for that to rotate so the slabs can move. And translating. So translating is primarily how window wall works. It translates, it slides this way. Almost every system does a couple of these things, 2 or 3 of them. But you think about the primary movement type. When you talk about big panels, they can't rack and they can't rotate. So when you're talking about a mega panel, speed wall or others, you're always translating. And that works great in the middle of the wall, but the minute you hit a balcony or a corner, you have this thing that wants to move that can't rotate or rack, and it's going to move that corner. Like this. So this is a translating window wall, and you can see what's happening at the corners. This is a large PMU test that we do on all iconic buildings, any new system that we're developing or help develop. You can see how this is translating, and then the corners are opening and closing, right? Small earthquake, that still has to be air and watertight. Big earthquake, this is the big one. Things can bend, but they can't fall off, right? Here's a mega panel, right? And this is a mega panel with bolt-on balconies. So the balconies are just going to ride on the panel. And you can see, nice, easy translation, but the minute you hit a corner, right, or a balcony that's not in line with this, you have to think what's going to happen. And look at how much that corner's moving in and out. So you need a very large joint in there that's really going to take that movement and still be air and watertight after it. And this is classic curtain wall. This is pure rotation. So you can see this 401 West Georgia, right? Pure rotation in this curtain wall. Perfect. And you see it almost touches, but doesn't touch. If it touches, it'll clash. Glass will probably break. In and out on the glass side, and rotation on the panel side. All right? And this is everything. This is an example of everything. You've got racking, rotating, translating. I'm going to talk a little bit more about this one next. So I won't show the whole thing. What's okay? In the elastic, everything has to be air, watertight, nothing can break, nothing can crack, glass can't break. In the big one, nothing can fall off. Glass can break, panels can deform, even anchors can bend, right? That's a big panel system where the anchor's bent. That's all okay, because all you care about is get out of the building and not have curtain wall fall on you as you're leaving. Or stay in the building and still have a wall. Now, let's add some complexity, right? Complexity means increased risk. It means increased budget, money, right? And it means, well, increased time. It's going to take more work to do these details. Straight curtain wall job goes up super fast. Straight mega panel goes up super fast. The minute you stop at each balcony to do something, it adds complexity and risk. So curtain wall versus window wall, when you have a balcony, window walls work really good because it's not part of the window wall. It's just punching through and you leave the slab band off. There's really nothing you have to do except for detail around. But everything's sitting on that balcony. Everything's moving with the balcony anyways. There's really no differential movement that you have to worry about. You take it all up in the head. With curtain wall, you're actually punching through the curtain wall system, through several panels. So now what do you do? What's the easiest way to deal with this? And what are some ways you might want to avoid, right? The easiest way to do this is to align that stack joint. So you align the stack joint across all your balconies and everything and run it on one plane all the way around the building. That way the curtain wall installer can just keep going. He doesn't have to do something really complicated at each balcony, right? If you offset the stack joint, that's called jumping the stack. That adds a bunch of complexity, a bunch of field work, a bunch of risk, and a bunch of extra money. So you want to try and avoid that. Bottom bearing's the same thing. If you bottom bear at a balcony and you hang it from the balcony beside it, causes problems, right? That's a good way to do it. And then I like just, if this works really good for say a roof, right? Because your door is high enough. If you're on a balcony, you've got to lower that door down so you can have an ADA threshold. That's okay too. So you're bottom bearing the door, but everything else, the stack joint lines up, and all your complicated interfaces are underneath the balcony above, all protected. It's a good way to do it. Even if you mess up, it's likely never going to see water there, right? If we offset the stack joint, we have at the most exposed location where water's draining off the balcony above, we've got a detail that's complicated, takes time to do in the field, is more risky and costs more. So you're adding some cost there. All bottom bearings even worse, right? Now you have a very large vertical there that you're having vertical movement this way, and you saw those corners, how they were opening and closing. That's going to happen there as well. You're adding risk, complexity, and cost. So you want to avoid that, but there's cases where you have to do that, and there are systems that are better at that than others. So if it's got a big silicone gasket in the middle that you can tie into, that's going to take that movement better than, say, a system which is straight up, relies on two gaskets that just mate together. All right, window wall to curtain wall. Right, this is curtain wall. That's what that would look like if we bottom bared on top of the balcony and hung it from the slab above. Now think about when that moves, interstory drift, in either direction, right? There's complexity, there's risk, there's extra cost. We want to try and avoid that if we can, but if you have to, you have to. Now let's offset the balconies. Let's add some real complexity. Now you're offsetting balconies. I can't even begin to explain this to you, but you have a balcony, you have another balcony beside it. Now your doors don't have overhang protection, and you're jumping around, trying to hang curtain wall from the underside of the balcony, hang it from the slab, hang it from top. There's a whole bunch of ways to do this, but they're all complicated and they all involve a lot of time on site, doing site work, which we want to try and avoid. As Dan said, best site work is done in the plant. So here we look at it. Okay, this is a building here with lots of offset balconies. Curtain wall installer didn't understand this when he got the job, so he actually ended up developing a new system which had a slab band panel that he put all the way around the building in curtain wall with very, very complicated support system, metal supports that you could, because you put that in, you have to actually be able to tilt it this way and that way and get it lined up properly. And then he dropped curtain wall on top and had the stack joint aligned around the whole building. It was a great idea. It worked good, but tons of work on site. And turns out when you install two things, it's twice as much work as installing one. Actually, more than twice as much, probably 3 times as much, because you have to kind of plumb everything up before you put your next layer in. So that added a lot of cost to the project, where we could have avoided that if we just used window wall. Window wall would have just gone straight through there, no problem. So if you can, you look at the maximum spans, the maximum size of glass. If you can make it look like you want to with a window wall system, this kind of offset balcony works so much better, and it's so much less expensive and has so much less risk if you can do that in a window wall. You can still use curtain wall mullions. You just bottom bare them and run part of it past the slab like a window wall. So we just look at this again. You can see what's happening here, right? This slab band here is moving with the balcony, but you can also see these doors racking. What happens when you rack a sliding door, right? It comes out of alignment. You need to do more service work on it. It requires more maintenance, all those things. So took a lot of work to get this to work. And even with all that work, it's going to take more maintenance. So we want to try and avoid that. Use window wall for this kind of thing, and it's going to be way easier and cheaper. Bolt-on balconies. There's another one where I think, we're all moving to some way to do balconies more energy efficient, right? Because you got to meet step code 3 and 4. Bolt-on balconies are one option. They're good. How you do them will really impact the complexity and cost. So in this particular building, it's the way it started was put curtain wall up, leave a hole, bolt the balconies on. Nice and simple. The way it went, cost-wise, balconies go up, not quite finished, they're not finished. You leave a hole so you can put the curtain wall in, then you put the curtain wall in unfinished, and you finish it on site. So again, you can do it. It'll work, a lot of water testing, but there's a lot more work there. Right? So there's balconies are cheaper, but the curtain wall is more expensive in the end. Is it any cheaper? Probably not. And is there more risk there? Yes. Extras, right? Very cool. This is the title slide for our Zak World of Façades today. Fantastic way to do it, right? Support all of your complicated things off the balconies, completely separate from the curtain wall. Make it so that you can install the curtain wall. It was a little harder to put the curtain wall in because it had to come in from the inside on a sliding beam. But the right way to do it. This is all curtain wall, boom, done. Shifting balconies, a curtain wall that's specifically designed for shifting balconies, all after all that complicated feature is installed. So this is the right way to do it. Don't penetrate your curtain wall system. Every penetration is cost. Every penetration is complexity. So what does it want to be? A couple examples here of projects I've worked on. That's got to be curtain wall, right? The feature wall on this building is curved. It's structurally glazed. They're huge pieces of glass that span floor to ceiling. There's no option. You're using curtain wall. Anytime you have that much complexity, you need a system where every unit is different size. That kind of complexity is ideally suited for curtain wall. But you flip the building around the other side, it's got balconies. It's got eyebrows. It's got a whole bunch of shifting things. Probably window wall. So on this project, they did curtain wall on the feature side and window wall on the balcony side, and they married them in a kind of protected location in one of the balconies. So not a bad way to go. You know, save some money on your balcony glass and spend it where you really want it, where it's facing the ocean. Shifting balconies. This is another one. It's curtain wall, specifically designed to be able to mate to those shifting balconies and still take that inner story drift. Curtain wall, right? Bottom bearing the whole way around. So align the stack joint, bottom bear it all the way around, so you don't have to switch between hanging it from the soffit and hanging it from the slab and having those different movements. So bottom bear everything. Curtain wall, big units, structurally glazed. I don't think you could make it look like that in window wall. Window wall, clearly. Classic Vancouver building. Curtain wall, very difficult around each one of those balconies. Part of the reason that this project, you know, this was the costliest part of this project was interfacing at all those balconies on site. Everyone's different. If every unit is a different size and a different rotation and a different angle, it's got to be curtain wall. There's no window wall manufacturer that could pull that off. It needs to be customized. Curtain wall, you saw that picture of the movement there, right? It's got to hold up the planters, the soil, everything else. It needs to be very strong. Custom curtain wall design with enough strength to hold the planters and to hold and to look that good. Believe it or not, this would normally be stick built, but believe it or not, they did this in unitized curtain wall. So all these are units, a lot of CAD work done to make that work. Dropped in place, unitized. Really impressed with the way that came together. Window wall, but interesting, you've got these feature mullions. That's something you don't often see with window wall. Easily done. Put them on the inside, put them on the unit, drop the unit in place, have them line up, and you can make some really neat features with window wall. Very, very effectively from a cost perspective. And my favorite, this is so the curtain wall means up and down. I call this a Y-light and a waffet, right? They're not vertical. That needs to be curtain wall, and it needs to be custom designed for this building so that when it's sloped backwards and it's a skylight, it still drains. Because most curtain wall systems only drain when they're vertical. So it's got to be customized curtain wall. Big panel, again, just like Dan said. I actually had BCIT in here, but I switched it to Brock. You notice something about this building? Look at the simplicity. There are no balconies. I almost guarantee this wouldn't have gone forward. If there was a bunch of balcony stacks and they were shifting, they wouldn't have built this building because it would have been too expensive. We barely made it with the cost of this system. So again, if you've got a nice clean facade like that, you can make it look real good with big panels and come in super on budget. Nice and simple, no complexity. And I'm just going to leave you with this. I'm driving around the city a lot. I drive around other cities in the world. All the testing you've seen, all the stuff you saw previous to this, it's all glass, aluminum, and silicone, right? Doesn't care how long it's wet. Wood does. So if you're going to use wood on the outside of a building, do it like we were going to do here, where it's printed with a 1080p print printer on the back side of the spandrel glass, and it's a picture of the actual wood we were going to use on the building. If you put it outside, it's going to do that. That's not that old. That wood's starting to decay. There's a job here in London. I just walking by. It's a Koya. It's a really neat curtain wall system. It's brilliant. It's got wood supporting the mullions. Wood supporting the mullions is kind of cool, but the wood's on the outside, right? And at the top of that, you can sort of see it. This is under construction still. So again, you want to definitely manage where you put wood and try not to use it as an actual cladding on the outside of a building unless it's well protected. A Koya is called a silated Radiana pine. Radiana pine's super not durable. So this is a little, Radiana pine is not durable. A Koya makes it more durable. And this is some testing we do at RDH for everything we use. That's new Akoya. That's Akoya after 16 months. That's hemlock after 16 months. So it makes Radiana pine, which would probably have fallen apart in 16 months, be about as durable as hemlock, which you wouldn't, that's not a tropical hardwood. That's just a wood we wouldn't use as a deck material outside. It's not a cladding system. Wood is not a cladding system, right? You can't separate inside from outside with mass wood because mass wood cracks and then it leaks through the cracks and it goes somewhere. And finally, last slide. This one's out at UBC. You can go see it. It's near Brock. This gives you a perfect example of how much cover you need when you're using mass wood to keep it looking good. The top of these columns, beautiful. Bottom of the columns, starting to fade after a couple of years and starting to crack and check. And then over here where we have a column that has no overhang protection, it's not looking good top to bottom, right? So as an architectural community, if you want to kind of look at this, this is a perfect example of how far water comes in and wets things on a normal day without any wind in Vancouver out at UBC. So you can go, okay, just measure how far that is from the top where you don't see any problems and just keep your wood protected with that overhang ratio. And there's no time for questions, but I've enjoyed talking to you. So thank you very much. I'm going to be around the rest of the day. You can come chat with me.
Thank you, Brian. Now you can catch your breath. Thanks for reminding us that there's cost and there's durability to consider when we build iconic facades. The next in line is Jordi Marasse from Rainers. He's going to come and talk to us about improving the living of people now and for generations to come with VR.
Oh, I need the presenter. Where did it go? Oh, okay. Hello, everyone. My name is Jordi Marasse. I'm managing the projects department of Rainers in North America. We're all here to discuss and understand the various advancements in the field of facade design and engineering. I would like to explain to you today how we're implementing virtual reality into our day-to-day workflow in projects. But first, I recognize for many of you, this may be an introduction to Rainers, so I'll just take a brief moment to explain a little bit about who we are. First of all, Rainers is a world-leading specialist in the design, development, and marketing of sustainable aluminum solutions for the building envelope. There are lots of other words you could use to explain Rainers as a company, but first and foremost, we like to emphasize that we are a family business. Company was founded in the 1960s by this man in the black and white photo, Jan Reinaars. Jan was a fabricator and installer of aluminum systems, developed his own solutions, which started to gain a lot of traction in the Flemish region of Belgium, where he's from. A lot of companies started to reach out and say, Jan, I really like your product. I want to work with it, but rather than buy fabricated windows from you, I'm going to buy profiles, hardware accessories. I'll do the fabrication and installation parts myself. To give a little bit more responsiveness and flexibility to my customers. That's how Rainers as a system supplier came to be. Unfortunately, some 7 or 8 years after founding the company, Jan died very tragically in a car accident, leaving the company to his 5 children, who you see here. The eldest of the children was Martine Reinaars. That's the lady in orange sitting on your right. Martine was 17 years old at the time of her father's passing, so some family friends had to step in and help run and maintain the business until Martine was able to graduate in her early 20s with a law degree, at which point she took over the company as CEO and really built it into what it is today on these 4 pillars: innovation, excellence, loyalty, and respect. Our mission is to improve the living and work environment of people for now and for generations to come. We blend design, technology, and digitalization into innovative solutions that add value and inspire our partners. Our partners are, of course, the fabricating clients who work with our systems, but of course as well, homeowners, architects, developers, engineers, general contractors. We all consider to be partners of Rainers, which is why our motto is Together for Better. There's our global footprint. You see indicated on the map our campus. That's the headquarters in Duffel, Belgium. But we do have other facilities, legal on-the-ground presence in 48 countries now globally. Sales in more than 82 countries, the last that I heard. More than 5,000 fabrication partners globally, more than 2,600 employees, and an annual turnover of about 1.1 billion Canadian dollars. That's basically the trajectory of the company since Martin took it over. You see about 1986, 15, 20 million euros in turnover, let's say. By about 2010, we're approaching 300 million in annual turnover. That's the time that we took the decision to go global. Started entering markets such as North America, etc. And then, you can see really the impact on the growth of the company since that time. The revenue is, of course, generated by a wide range of products, a very expansive product portfolio. I will not be too specific. For those of you who know us, you maybe know there's lots of options, lots of systems, lots of variants, etc. Very generally, windows and doors, everything from your economical solutions up until passive house insulation levels, extremely large dimensions, super slim sight lines, etc. It's all possible. Sliding systems, super minimalistic sliding systems, large format lift and slide doors, offering near passive house performance levels. Facade systems, stick facade curtain walls, unitized curtain walls, window walls, as Brian was just explaining. We're doing that as well. We have of course, our standard catalog off-the-shelf products that our customers locally keep in stock, for example, and they can deliver to your projects at a moment's notice. Separately from that, we're doing approximately 30 to 35% of our business globally in custom solutions for projects. So we have a team of more than 100 engineers and designers who are busy every day improving our existing systems, developing new ones, and working on these bespoke solutions. Of course, we live in a world that's highly regulated in the construction industry, as you all, I'm sure, are well familiar. So everything we do has to be tested, retested for every different market that we're supporting, always different regulations, and constantly validated for your projects. That's why we took the decision to invest in our own research and testing facility, which is now the world's largest research and testing facility in the private sector of aluminum worldwide. Reliable network of fabricators, like I explained, more than 5,000 globally, and a good chunk here based in North America. I see some present in the crowd. For the fabrication partners, we're really trying to offer, let's say, more than just a system, windows, doors, profiles, but we really try to offer the entire ecosystem around the development of the products. So that's software that's doing everything from their design and estimation, engineering calculations, ordering, etc. We're developing softwares for our fabrication partners to link them with dealers so that the dealers are empowered to produce their own quotations linked to our fabricators' estimation data to make sure that our fabricators are not bogged down with constant quote requests, etc. We're really trying to also CNC machines in the shop, everything around the products we're providing as well. But like I explained, more than just our fabricators, we consider as well project stakeholders, architects, developers, engineers to be partners, and we're busy every day also developing such solutions for you guys. And one such solution that we have developed for project stakeholders is Avalon. Now, what is Avalon? Avalon is basically a virtual reality cave that is built to optimize and enhance the working collaboration of various project stakeholders. What is virtual reality? It's not a new concept, as I'm sure you're aware. It's been with us for about a century now. Basically, it's just two images placed at differential depths. Your brain works to fill in the rest and give it a full spatial field of view. There are many devices you can use for purposes of virtual reality. I'm sure some of you architects in the crowd have used similar things like this in your project applications in the past. We did too explore such devices when we were looking at implementing virtual reality into our workflow. Ultimately, we felt these devices were too limited in one very specific way, which is that they are too immersive, but for only one perspective. If you want to bring those various perspectives and stakeholders of differing backgrounds, some technical, non-technical, together, and try to work on this experience, it's not an easy thing. You're sharing goggles back and forth. It's a lot of guidance needed. No, sorry, your left, my left, up and down. It becomes a really tedious, frustrating process. We wanted to take it a step further and really provide an environment where all project stakeholders of different backgrounds could meet, could share the experience. And so we started to explore the concept of the cave. The cave is also not a new concept. It's used most predominantly in the automotive and aerospace industries for basically virtual prototyping of vehicles. What's different about the cave is that you're standing in a room and everything around you is a screen powered by very expensive laser technology behind it. You're wearing see-through glasses. So basically you can stand in your project looking at it in one-to-one scale with proper perspective. I can look at you, you can look at me, and we can look at the detail together. We can have our discussion and make informed decisions. And this is our virtual reality cave, Avalon. I will let the small video just explain a bit more.
Welcome to Avalon, a space to explore architecture through a shared virtual reality experience. Did you ever wish you could walk into a building that is still in the design phase? Avalon can take you anywhere you want. 25 projectors make architectural designs come to life in unequaled resolution, with cutting-edge laser technology creating the most vivid colors, contrast, and brightness. Active 3D glasses create a natural spatial awareness, and as a user, you are instantly immersed in a true 3D environment that creates an incredible sense of scale and depth. You are able to share the experience with your partners, allowing you to discuss and evaluate your projects before they are built. Avalon is a collaborative working tool, offering a joint experience between architect, contractors, investors, engineers, fabricators, and Rayner's experts. Virtual reality is set to play an important role at all stages of the architectural process, from evaluating design options and showcasing proposals to detecting construction issues before breaking ground on site. Starting at the conceptual phase, VR has proven to be effective in exploring the relationships between spaces. VR gives you an immediate feeling of being inside the building. You can experience the impact of light on a room, or evaluate the different interior viewpoints. The spatial realism makes Avalon an incredibly powerful tool to communicate design intent. When the architectural design is further specified, BIM files are effortlessly translated into VR, providing architects with even better tools to communicate about their choices and improve their designs. Enabling architects to effortlessly move between BIM and VR truly revolutionizes the way buildings are designed. Avalon allows you to explore your projects inside your usual design software. Its powerful main workstation handles 3D models produced in any commonly used software in the architecture industry. By tracking the visitor's movements, real-time rendering engines create the ultimate VR experience, from initial sketches through detailed technical models and realistic scenes. Before your visit, you provide the 3D model of the project. In consultation with the building team, the objectives are set and the model is adapted accordingly and prepared for VR. Different options can be prepared to compare several Rayner systems, configurations, bespoke solutions, or specific design variants for your project. Avalon is perfectly suited to create diverse virtual mock-ups. You can make sections, explain complex technical setups, or examine specific construction details or project solutions. This new way of virtual prototyping reduces costs and increases efficiency drastically. The high-resolution real-time renders allow you to see every detail so you can experiment with different configurations. evaluate simulation or BIM data, and further improve your design. You are able to experience Rayner's systems up close and compare the different solutions for your project. Discover Avalon, the space where future projects become a reality.
So why is it that we felt that such an investment would have value both to our partners and to the industry? Number one was really avoiding mistakes. There are lots of studies that indicate that most mistakes are what you would call stupid mistakes or avoidable mistakes if you want to be kind. If the right people were looking at the right thing at the right time, you'd catch him. But because the project environment is so dynamic, involving so many different collaborators of so many different backgrounds, so much coordination of different companies, etc., ultimately things get missed, resulting in problems like this Photoshop on the screen. At least I hope it's a Photoshop. Second was making better and faster decisions. So like I explained, projects, lots of stakeholders, different backgrounds, some technical, some non-technical, different pains and gains amongst those stakeholders. I have personally and firsthand experienced where that cohesiveness of the collaboration of the various stakeholders is not necessarily aligned, and this can bog down the decision-making process and ultimately lead to delays in taking decisions and delays on site. We've boiled it down to really 3 different types of evaluation that we're doing currently within Avalon. The first is a concept evaluation, technical evaluations, and high-quality design evaluations. I'll use a couple real-world examples to kind of help highlight what is meant by these different types of evaluations and how we apply it to projects. So this is a very simple one, an early concept design evaluation. I've personally done this for several potentially upcoming towers here in Vancouver. Basically, yeah, we're involved quite often very early in design processes on projects. Maybe there's an idea of what the building wants to look like, or several different ideas of what the building wants to look like, or maybe we've gotten as far as doing very, very preliminary technical feedbacks. But what we can do, we can take that project, we can provide the context around it, let you experience it within the skyline of the city, for example. This is a technical evaluation using an example. This is one of the FIBA World Cup stadiums that we did in Qatar, together with our partners at Deed Architects. Yeah, you can see there's not a lot of glazing on the building. We did provide curtain walls, windows, and doors to this project, but that is not why they wanted to visit in Avalon. Why they wanted to visit in Avalon was really to sit in various perspectives there in the stands and try to get the feeling for what the spectators would actually see and feel from those various perspectives. Based on what they saw there, they changed inclinations of seats and angles. They moved some stanchions around to really try to optimize the field of view for all the spectators, both in the lower seats and in the upper bowls. You had as well a big, large service maintenance bridge traversing the entire arena to service this large retractable roof. And then they really just wanted to go in it in Avalon and try to understand the related safety aspects. Were people working up there going to be safe? Would they feel safe? Would they find people willing to work up there? Was really what they were trying to understand. And ultimately they determined we walked the bridge and somebody else can too. Virtual visual mock-ups. This is it's becoming more of a trending topic, especially during the early days of pandemic. This really we saw a huge uptick for this. Projects looking to address costs related to inflation, etc. One of the ways stakeholders were looking to do this was by slashing away at expensive and sometimes time-consuming visual mock-ups. So what we can do, we can take shop drawings from various contractors, etc., models, and we can produce as close to a lifelike visual mock-up as you can get, only significantly faster and significantly cheaper. High-quality visual evaluation. This is an example of a multifamily project we did in the Netherlands. kind of a tale of as old as time. At the bottom of the building, you have one wind pressure. At the top of the building, you have a higher wind pressure. And now the windows are calling for reinforcement for inertia over the span. Big fight between the project stakeholders in this project. The architect said, absolutely not. You cannot put the reinforcements on the outside of the windows. You're going to destroy my entire facade. What are you doing? The developer said, absolutely not. The reinforcements can't go on the inside of the windows. It's going to mess up the interior space. I didn't sell this to my tenants. What do I do about blinds, etc., etc.? It went on for weeks. So we invited both project stakeholders into Avalon. We rendered the building to the inside, also to the outside. We put the reinforcements on both. We stood the stakeholders at the foot of the building from a respectable distance. And the architect looked up and he said, okay, now show me with the reinforcements on the outside of the windows. And we said, Mr. Architect, they're already on there. And the decision was made like this, that the reinforcements go on the outside. Sometimes putting things in proper scale and perspective and giving that proper visual feedback can really help to expedite that decision-making process. We also showed them the interior spaces. We rendered these spaces with different types of furniture, big table, small table, different flooring, etc., because they were in Avalon, and why not? This is a project, it's called Quad Central. We just completed a couple of years ago in Malta. The topic on this project was that this was the largest project being constructed in Malta and in its history. We, as a designer of the facade system, had a lot of concerns about what would be the quality of the workmanship for every contractor on this project. It was their first time doing something like this. So concrete formwork, what would be the tolerances we're working with? As you can see, it's a unitized structurally glued curtain wall system, transitioning seamlessly into a window wall system. Installed between the slabs. Brian just kind of explained a lot of the complexities related to that, so I don't need to, but yeah, you see the alignment of all the vertical profiles, horizontal profiles, especially in the curved area where we had bent panels and hot bent glasses was going to be a highly sensitive topic. We had foreseen of solutions on how to address these problems or what we anticipated to be problems on this project into our design concepts and of course into our price. At one point, our fabrication client, he called us and he said, guys, I have a problem. The problem is the developer is going to award the project within the next week. I'm up against a Turkish competitor. He's 20% less than I am. And I'm having trouble to explain to him why my facade system has more value to him and why my price needs to be where it is. We invited the investor into Avalon and we showed him, basically we explained to him, a non-technical guy, all of our technical concerns related to the facade and the construction. We showed him how we had planned already to address these potential challenges. Also, the integration of the zero sightline curtain wall vents and integral stepped glass sliding panels into the facade to give it additional aesthetic impact. And really, upon seeing it, the investor immediately understood that this was something different, and before leaving the room, elected to award the project to our partner. This is a Quatuor in Brussels, Belgium. Yeah, this brings up a topic I think we're going to probably cover quite a bit today, which is that regulation changes are kind of pushing for new and different materials applied to the facades. Architects are becoming more and more creative about how to integrate these materials into the facade systems. This was such a case. The architect wanted to use soft architecture, working with natural stone boxes, but applied to a prefabricated modular structurally glued facade system. One of the big topics on this project for us was that the natural stone boxes applied to the outside of the facade system were going to obstruct a natural replacement of the glasses to the outside of the building. So we had presented a bespoke cassette system which would allow for the replacement of the glasses to the inside. We were able to put all of this in Avalon to kind of demonstrate the entire constructability and sequencing of the events, also for the servicing related impacts. Yeah, yeah, this is another concept evaluation we can do. You have your project early on. Maybe it's a multi-residential building and you have balconies. You don't know what you want to do with it. Is it going to be a big sliding door with a gigantic side light, a balcony door, folding door? You have so many options. What we can do within Avalon is we can, model 5, 10, 15 different options for you. With all the stakeholders at the table, we can discuss feasibilities related to these. Maybe the architect loves the one at the bottom, but the general contractor says, okay, how do I replace that glass on the 20th floor when the service elevator's gone, et cetera, et cetera. And we can make decisions. If we have the fabrication partner on board at that time, we can even put a price to each model. Everybody stands in there. Here's your cost, here's your solution, and you pick one. This was a project we did just outside of Brussels in Belgium as well. It was an older industrial building working with steel windows, with crossbar patterns, etc. It was being refurbished into a kind of a rental office spaces, WeWork kind of a scenario. And the developer had concern that because of the crossbars, which were protected by heritage, what would be the impact of the light in the room in this building? Would it be disruptive to the people trying to work inside? Would he find people ultimately that were willing to work in here and rent these spaces? What we can do is using Google Earth data based on the location of the project, etc. We can render the path of the sun and show you inside at 10 a.m., 2 p.m., 4 p.m., and so forth, what that light is going to look like inside. And we're also using it kind of like the automotive and aerospace guys to develop our own systems and tweak our systems. So everything that we're launching into the market now, we're doing first within Avalon before we cast any dies or extrude any profiles, etc. So yeah, I would like to thank you. And if you have any questions, feel free. I would invite you to come by our booth and meet some of our North American team. Thanks.
Thank you very much, Jordi. Yes, I'll keep that. Well, that tool is certainly a step up or 5 over using my hands to try to explain what's not working in the system. Next, we have a keynote special where Jonathan Kahn, an associate with Büro Scheeren, will come and talk about their project, the 1515, here in Vancouver, a 3-dimensional sculpture for living riches out to engage the space of the city.
Can everyone hear me? Hi, I'm Jonathan from Büro OS. It's our honor to be here today to present our project to you. So this project is it's high-rise residential with amenities. It's being developed by Bosa and Kingswood Properties with Frankel as the architect of record and Büro OS as the design architect. To start off with, we'd just like to make a quick intro of our company. We're a little over 100 people scattered across the globe. I myself am based out of Beijing, where 1515 Alberni was designed. Our company is led by Ole Scheeren, our founder and the chief architect, together with Dan Chong, design partner. We work in a series of different sectors, from cultural to retail, developer projects, institutional, media, technology, and beyond. And for a young firm, we're also humbled to have received the recognition of a number of our industry peers. So we wanted to start off with talking a bit about our general approach before leading into the main topic, context, function, and identity. So this is an inventory of some of our projects, and just wanted to touch briefly on 5 of our projects to explain a bit our approach. This is Mahanakhon in Bangkok. It's a 300-meter plus tower. In this one, we were interested in taking the base condition of an extruded tower, the mute shaft of the tower, and opening up to the cityscape around, resulting in a series of pixelated forms with terraces on the top. Our buildings tend to be iconic, but we don't do iconic things just for the sake of being iconic. We like to try to study the specific conditions surrounding the buildings, and then through a series of understanding and harnessing the external forces such as context, internal forces such as program, you end up distilling it down to something which is a very specific approach that can only occur in that particular location. And then the project, through that process, ends up becoming iconic. This is another recently finished project, the Axiom in Shanghai for Tishman Spire. When completed, it will be the world's tallest twin towers with offset core. We ended up with this solution through actually studying the floor plate and then having an interest in moving away from the traditional center core typology, pulling the core outside to free up the floor plan to make it as flexible as possible. We were able to have very tall 5-meter floor-to-floor height in the section to allow a lot of daylight to penetrate into the space. And then the offset core becomes one of the major aspects of the expression of the building. You can see on the back of the building, it almost feels like a spine holding up the building. Duo in Singapore. In this project, we're interested in starting with defining the public realm. There was a dead space in between two existing towers, and then trying to create these almost bay-like gestures in between existing towers to welcome the public in and connect the public realm. And then the building itself ends up taking up the spaces between these bays. And then Guardian Arts Center in Beijing, trying to relate to the two different massings that intersect on the site: large-scale institutional buildings, and then also smaller-scale historic Hutong fabric, which is composed of a lot of gray brick. And then lastly, Tencent Helix, a project that we're now just going through SD. It will be the global headquarters for the tech company Tencent, where the gesture of the building actually grew out of the master plan, a sort of spiraling master plan that binds a lot of the other buildings in the surrounding sites, and then becomes the form of the building itself and even the internal program organization. So I just wanted to quickly show you these buildings because they all look very different because they're tailored solutions for unique conditions. But with all of these, we think it's very important that the facade is really something that enhances the expression of the massing and doesn't compete against it. And we try to distill down to a limited number of facade languages, facade geometries, whether they are rectangles or rain patterns, hexagons, brick patterns, prisms. We try to distill it down so that there's only maybe 2 or 3 types that then are, which we try to express and realize in its purest form in the end. And now to 1515. This tower is about 133 meters high with 23,800 square meters of GFA, roughly. It's located just at the main axis of West Georgia Street, which divides the neighborhoods of Cole Harbor and the West End. It's also at a location which we like to call the urban pivot, where West Pender splits off from West Georgia. So it's almost like a crossroads or a gateway into the downtown of Vancouver. And it also benefits from really great views towards the water and the north and the south, views to Stanley Park and views to the city. And then the existing conditions, there's a triangular building on the site, 1500 West Georgia, which had to be preserved, and then a podium building and a reflecting pool, which has been part of the urban fabric of downtown Vancouver for a long time, which was to be preserved. So our approach We understand that Vancouver is in some ways a city of glass. It's a city of verticality. But then amidst all of this, how do you create a new type of experience for its inhabitants? So we're inspired by this, this image of this case study house and this idea of how do you introduce horizontal living into an urban high-rise. This is our massing build-up. So we start with this idea that there's a generic shaft that is then split, rotated to create these cantilever forms. The bottom of the building is raised up to free up space for the urban plaza. The top is shifted to create an identifiable skyline. You result with a series of terraces that can be occupied, and then there are forms that look out to the water, the city, and the park. This shifting also allows you to create diversity of floor plates from a series of limited modules. So it creates a lot of variety in the floor plan. And then you end up with what we think of as a sculpture for living. And it also, on the street level, it feels almost like a signpost at the crossroads of the downtown as you enter in from Stanley Park. And it also stands out with an identifiable profile in the skyline. As you look closer, you can see that the cantilever forms engage the city with glazing on all sides where you can look out towards the city. And then in an interesting way also contains echoes of the vernacular of log cabins. Groundscape in public realm. I just wanted to quickly touch on this because we also think, because engagement and connectivity is very important to us, not just how the inhabitants engage the views, but also how the public, general public, can maintain this connectivity across the urban fabric. So you can see how the rectilinear forms merge with the triangular shaped pool. And then how the street edge is defined by this fountain, which splashes down into this triangular brick paving, and then the steps down from Alberni Street, creating a moment of urban connectivity, but also a moment of gathering where people can move through the site or sit and rest and enjoy the reflecting pool. And then this is a simple section that shows how you transfer down from Alberni to West Georgia. Touching on the key amenity and unit spaces, there's a sky lounge and then art gallery and lobbies below. Just wanted to quickly show you how these engage the different views and also their particular relationships with the different types of facades. So this is a view north towards Cole Harbour and Stanley Park. And then you also get views south towards the West End and English Bay. From within the cantilever facade, we try to open up the view as much as possible with very large glass panels with only the diagonal structural bracing coming through, which becomes part of the character of the space. And then a similar gesture from within the cantilever facade of the residential unit. And then in the lower floor, the gym, where you can look through the Flynn facade and still have daylight coming through, but with an increased measure of privacy. And now to the facade. So we have three main types of facade: the Flynn facade, the cantilever volume, and the balcony facade. So this is the location of the solid and glazed Flynn facades. So this is just showing that with the dense spacing of the fins, it allows you to integrate different types of conditions. So sometimes there's glazing, sometimes it's solid, sometimes there's MEP louvers, but we just want to use this as a way to hide all of these elements so that from the exterior it looks as clean as possible and and really expresses one condition. For material, we are using anodized aluminum, sort of natural silver finish. And then you can see here in this junction detail for the solid panel above integrates the insulation, and then the glazed condition below contains these slightly tapered fins for the interior to make it feel a bit more open to the views outside. And then here you can see my colleague Jose with a small mock-up that we did in our Beijing office to understand the how the reading of the transition between the glazed and the solid feels almost seamless from certain angles. And then just understanding the setting out of the corner conditions, we always try to, at the negative corner, leave it open, or the positive corner also leave it open. There's always a slot to increase the sense of articulation, to increase the feeling of verticality. And then this is just a zoom in of the different corner conditions at the fin facade. This is the cantilever facade that shows, you can see that we try to have these as distinct as possible from the fin facade, which is very vertical. These are we try to make these as very pure, tight, flush glazed glass boxes. And then they have a series of these picture frames that contain Juliet balconies at the end, so it really expresses a sort of pure, abstract sculptural tube in contrast with the fin facade. This is a zoom-in render, so you can see that at the slab edges and then at the picture frames, they are spandrel conditions, whereas everything else is full height glazed. So we just try to keep it as clean and as abstract as possible, with even the operable windows being full height. And then this is a view from the interior. Of course, I also just wanted to mention that we are using the drawings and images from DD to illustrate our approach. Of course, it's very understandable that as the project moves on into its later stages, some things will change and evolve, but we like to think that the general design intent has been maintained. This is a zoom-in drawings of the cantilever facade. Again, everything is just kept as a very clean envelope with a triple glazed IGU. And then on the top of the terrace, you can see how we set back the balustrade from the edge of the cantilever volume so that it preserves this sculptural reading as much as possible, with the aluminum panels wrapping around the top edge to keep this metallic reading, reflective reading as much as possible before it switches to GRC or stone. And then section at the top of the cantilever facade. So we've had you can see there's a slight fall for water drainage, but actually what you read on the exterior at the top of the volume is still very horizontal, and then the flashing is also flush to the horizontal panel at the top. Condition at the spandrel backpan also flush with the vision glass and minimized joints between the spandrel glass and the vision glass. And then at the soffit with the drip edge detail, also flush to the finished surface of the soffit. Initially, we were thinking about using glass as the soffit, but due to concerns about maintenance, durability, we've switched to aluminum. And then here you can see the Type C, the balcony frames, also with the picture frame gesture similar to the cantilever facade, but a bit more quiet. It's split up into a series of limited series of modules. And we tried to, for the picture frame of the balcony edge, we tried to use this, give it a translucent expression, so it lets in light, but still gives a measure of privacy, which you can see here in this zoom-in view. Initially, we were studying the use of a type of a metal mesh sandwiched in between two glass panels, but ultimately we decided to go with a sort of a fritted facade, which would have a similar effect from a distance and would be more cost effective. And this is a view, this is a section of the balconies at the intermediate floors at the balcony facade. So they're just very simple. The bottom capture of the glazed balustrade is flush with the exposed fair-faced concrete slab edge. And then this is the section at the bottom of the picture frame where you see there's also more of a finished panel. Again, initially it was a glazed soffit, but now we've switched to aluminum. Again, with the drip edge showed as a reveal similar to the cantilever facade. And then this is a view of the underside of the soffit. So recent site status and looking ahead. This is an aerial view of the construction site from August. So it's actually now, the project as of 2 weeks ago has reached grade. So we're very excited about that. And we hope that in late 2027 or early 2028, it'll be a part of the Vancouver skyline. So we look very much forward to seeing that. Yeah. Thank you. Yeah.
Thank you very much, Jonathan. You gave people a little bit more time for their lunch, which is great. I'm sure they will appreciate. Talking about lunch, I just want to remind everybody that food is not welcome in the room, so you can eat outside, bring back coffee after lunch, and so on. Also reminding the speakers from this session that we will be taking photos after the panel, so to stick around. Our next event is a panel, and it's going to be discussing how developers leave their imprint on Vancouver. The moderator for this panel is Julien Léger, the only name I can pronounce properly today. Anyway, I will invite you guys to the side slowly, but I guess we have to wait for all the sofas to be on. You know what? Like, I'm not the kind of person who talks in front of a crowd and makes jokes. I usually laugh at them. So, like, I have nothing prepared to keep you entertained, unless someone has a joke to tell and I can laugh. I will get out of the way. You can talk amongst yourself for a little bit and we'll be ready in a minute. Okay, I think that we're ready to go. So I will reintroduce Julien, the moderator, who will in turn introduce the panelists. Welcome.
Hello, hello. Hey, good afternoon, everybody. I'd like to introduce you Al Bushby from PCI and Nathaniel Funk from BOSA. Al, tell us a little bit about you and your company.
Okay, do we have the clicker? Because I think we're going to have some slides. There we go. Excellent. I'm willing to share. If I can get it. Do I have to point that way? That one? No, that one, that one. Okay, I've been defeated by clicker. Are they coming? Oh, fantastic. All right. Well, in the absence of slides, I will You'll forgive me, the title of development representation is fairly new to me. I joined PCI this year. So what I have got prepared is a commentary from one of the OG inceptors of PCI, Andrew Grant. So I'll share that with you before we move on. Andrew has to say this about how developers leave their impact, or imprint, I should say, on Vancouver. So in his far wiser words than mine, our city of Vancouver is enhanced by neighborhoods and walkability. Rather than focusing all the attention on the skyline as a local developer, we're focusing on the ground plane, emphasizing retail experiences, deploying architecture that is conducive to walking and that doesn't overpower the street, introducing compelling public art and functional landscaping that creates interest, encourages porosity, and creates a sense of place. PCI are proud of our projects, not because of their size or stature, but because of how they've created or improved their respective neighborhoods. So with that, I'm going to just quickly talk to some of the projects that I've worked on that I think speak to neighborhood at various different scales. We've already had people discuss, my former colleagues at HPA have done a wonderful job designing Oak Ridge and really needs no introduction or discussion, so I'll move on to the next one. Another Westback project, this was Main and Fifth. The Main Alley project, which again talked about a lot of aspirations for neighborhood integration, bringing people in at the ground plane, and also attacking some of the traditional massing that had been originally discussed by the city. We managed to come at it from a different way to get away from the layer cake and get into something a bit more compelling. Some residential towers downtown. This was the Mirabel project that I worked on tangentially, but I thought was a successful project in the downtown, as it had a large social component for the social housing in and around the bottom portion of the tower. This was a project I worked on recently out in Kelowna. This is a large mixed-use rental development, 9 towers, plugged-in townhomes to a raised above-grade parking lot with a park space, communal space on top. Again, speaking about developing an entire community pretty much from scratch in that neighborhood. And now most recently at PCI, this is the Spring Street project out in Port Moody, which has got attached to a transit plaza, which we're working on and developing keenly there. And then this is another transit-oriented development along Broadway and Arbutus. Again, we're focusing very much on the experience at grade because we are bordering the Greenway at Arbutus, for those of you familiar with the city. And we also have the new Broadway SkyTrain station is right underneath this building and will be potentially popping up in the basement as well. My background is architecture. I've been practicing in the city since 2008, and very honored and delighted to share the stage with colleagues and friends who I've known Nathaniel since UBC days. Julian and I have met very recently, but I'm excited to have a valuable conversation. So with that, I'll pass this along to you.
Thank you, Nathaniel.
Thank you. It's a pleasure to be here. My first Zak conference, so thanks for the invitation. I see a lot of familiar faces out here, which is great. A little bit about me, Vice President, Boldt Properties. I've got a tale of 2 careers, really. Kind of first half of my career working in architecture, and then the second kind of phase has been on the ownership side and the real estate development side. I'll start with a bit about me. I think this is going to go forward. I've got some slides to just share my background. Although I've been in Vancouver with my family here for almost 20 years, I raised in Chicago and began my architecture career in Chicago, so I thought I'd take us there. This is not a building I worked on, but one that I really enjoyed in my youth, and I think it's applicable to today's conference. This is the Inland Steel building, if any of you know it, built by in 1958 by SOM architects. Brushed stainless steel, aquamarine glass, and I always loved it because I'd walk on my way to work every day, and it would catch the light and shimmer in a way that was quite astounding and reflect light all over the plaza and the neighborhood. Also, nice kind of proportions and held well over time. All the columns are on the outside of the building, so there's column-free space, and the elevator core is a separate structure. So it's a 60 or plus year old building and holding up well, and was inspirational to me in my early career. Staying in Chicago, this is the Aqua building that I show only because it's kind of full circle. I'm working and managing on projects that look a lot like this today. I was actually, if you look at the bottom left-hand corner, there's a little like brown building. That was where I sat when I was working as an architect, and I watched this building get built. And I appreciated the efficiency that it brought to building housing at scale. I think it's over 50 stories, maybe 60, built on what was a golf course in downtown, kind of east loop of Chicago. Here's just some images of it. You can see what this is. I mean, consistent actually with what we see a lot in the Lower Mainland in terms of housing typology at scale. I'll flash through some of my projects that I've been involved with. My very first project was this one in Kansas City. I only flash it because, I mean, I was a green architect, and I didn't design a green building because of that. I probably didn't have any say on the color, but interestingly, it's a press hall, and it had a interior humidification that was very high for a climate that was very cold. So I only show it because it was, I don't know if it was innovative at the time, but 20, 25 years ago, we were able to get glass on a press hall, which was pretty unusual in this kind of climate. Just a picture of the detail. This is partnered with Zahner. It was actually in Kansas City, and I think Juno Glazing, which maybe is in Toronto, or they still exist. I'll flash through some of my other projects. I've done a lot of work in chemical laboratories and pharmaceutical is the laboratory building. Flashing forward to Vancouver area, the community center, spent some time in some aquatics work, done work in housing and infill. And then when I'm jumping to real estate development, kind of my first job on the real estate side was this giant tower in Calgary, the Tall Sky building, which was flashed on the screen, I think by Brian earlier. Certainly a lot of complexity in the unitized system there, integrated lighting into as public art into the facade. Every single kind of unit is really unique and customized. Lots of post-applied panels to resolve all those geometries, making it a very complex project to build. In Vancouver here, 400 West Georgia, Deloitte Summit Tower is involved with, which Brian also showed on the screen. All unitized curtain wall, including the perforated panels, reflective glass soffits. You've seen this one. Now we're jumping ahead to my current role at Boldt Properties. We're building this, as you've heard, 1515, as well as our Central Park House in Burnaby, our Soul House project in Burnaby also, and a master plan project of 4 towers in Surrey called Parkway. And also on the boards right now is twin towers in Vancouver, we call it Barclay and Thurlow. Starting hopefully soon. I think that's it.
Very good, thank you. So we're here to talk about how do you guys live your imprint in Vancouver? Are you looking to make a statement with a signature massing of facade, or would you rather blend contextually in the heritage fabric of the city? Nathaniel?
Yeah, it's an interesting question. I would say there are certainly some iconic buildings in our portfolio of projects. I would say we don't start with that premise at all. We really start from a bottom-up approach, which is to collect the information that will go into making a sound and responsible business case project. So it usually starts with really collecting customer intel, understanding of the context and the place, as well as all the requirements. As we all know, the regulations continue to get more and more complex every year. So the confluence of bringing those things together to make a project that really is a kind of market fit for that neighborhood is really the key. Mm-hmm. It may end up as an iconic piece of architecture. More often, probably ends up being more contextual or certainly more rational and efficient. Because we're quite focused on, at least in our residential work, building homes at scale. And whenever you build it at scale and in vertical format, there needs to be a level of repetition that's quite key to the business case behind it.
Yeah. What about PCI, Al?
Well, I totally echo Nathaniel's opinion on the matter. I think from PCI's point of view, we're focused primarily at the moment in rental housing. And with that comes certain obligations to the market that we have to, bake in early doors. So when it comes to designing sort of massing and facades and whatnot, I think there's definitely an intent to provide something that is going to be able to be built given the existing constraints we have in the local market in terms of construction costs, schedules, the delightful impacts of the municipal system we have here. So I think we don't go out of our way to make something look iconic. We want to make something that is going to be practical, is going to serve the needs of our target demographic markets for our rental tenants. PCI has a partnership with our own property management company. So we have the benefit of developing something which we will then go on to own and manage, which I think informs a lot of the design that we are currently undertaking, which I think is a slightly different lens, potentially, than maybe some of the other developers out there on the market right now. But I think ultimately we have to deliver housing to a market that is extremely taxed right now. So those design decisions that are made early on are usually informed by pragmatics initially as a subject of cost. So right now, whilst we'll start with something fairly generic and try and add value where we can to help give people some exposure to good design as and where we can. So.
So what are the key aspects of understanding your clientele? Do you use sustainability or a healthy lifestyle as a marketing tool, or what are they looking for?
I think ultimately everyone wants to live in an environment where they can feel happy and healthy. Nobody wants to, wake up in a space where they don't feel that they're being in a healthy environment by any means. So I think the sustainable side, I think, is in part mandated by, Vancouver's got very high thresholds for sustainability and livability. We do target in-house, the LEED program, the WELL program, as part of our sort of development patchwork as we're tackling these projects. So I think we have traditionally worked with architectural partners who have a strong sense of sustainability and where they need to be locally, not to just meet the existing code, but perhaps go beyond it where we can. And I think given the nature of us trying to work on making our developments really a neighborhood that people can feel that they're part of and engage with, that the sustainability from design from that sense, folding in transit, walkability, a little bit of variability in terms of the material palette here breaks it up, that gives it a sense of, like I said earlier in my statement, is a sense of place. So I think there's a lot of opportunity for us to look at our projects through the lens of sustainability, not just in the prescriptive method, whether it's LEED or passive house potentially, but also just the overall livability of those spaces. So maybe just more of a holistic view of what sustainability means when you were talking about this kind of density.
Mm-hmm. And BOSA, I understand it's at the core of your business to understand your client and what they're looking for. And so what do you learn from them?
Yeah, I would say for sure we start with a customer's centric approach. There's lots of different customers out there. I mean, everyone in this room is a customer in some respect, whether it's a home or an office space, and everyone has different wants and needs. And so we really try to unpack that and understand all the various segmentations and types of customers to inform our decisions. And you mentioned sustainability. In our experience, or mine certainly, we haven't seen a really significant uptake of residential buyers valuing sustainability. We just haven't. Are they willing to pay for it? Not usually. We see that in commercial. Office tenants they want to have a more sustainable office environment for their employees, and they'll pay for it. I often use the car analogy. I know when you're buying a car, are you gonna pay more because it was built or manufactured more sustainably? Maybe not. So that's not to say that we don't do it. We do it. It's the right thing to do. Oftentimes it's required by law to hit certain sustainability targets. but it's understanding what is required, what is right, and what is needed, and really being quite rigorous around those decisions and that process is kind of key to our approach. Again, coming back to the car analogy, if you might say every car should have air conditioning. That might be table stakes, so it has to be in the design of a building. Whereas a moonroof is maybe a nice to have. So we kind of think about design and buildings and marketing. I guess is at the when it goes to market in that way, in terms of like what are all the value adds that we can give to a homeowner or a tenant. That they want, and kind of really take it from that approach, kind of bottom up, as opposed to we have an idea of what they might want. Try to use the data and research that we have to inform those decisions.
Mm-hmm. And so that's you both touched about the changing of the regulation and how rapidly they do. So how do your design reacts to those changes that are constant throughout our designs?
Well, that's where you guys come in the architecture field, right?
We try to follow our best.
Yeah. The municipal landscape has been changing, to your point, quite drastically in the last 10 years, has been my understanding. And I think most people in this room who work in architecture will understand that that's a huge challenge to the viability of projects, whether it's the increasing requirements by step code for energy performance, or whether it's the new 2024 building code for adaptability requirements, which is going to lead to an impact in overall suite size for aging in place. Nathaniel mentioned, are these the right things to do? Of course they're the right things to do, but given the fact that there are so many pressures coming to market all at the same time, it's another set of obstacles that you have to overcome, not just in the design phase, but almost ahead of the design phase. When you're trying to make just the numbers work. My experience in the last, what has it been since April, so 6 months or so since joining the development world is, it's hugely challenging, not just from a design sense, but just from an investment sense, trying to get these things to actually align well and find those synergies and those efficiencies where you can. So I think when you layer in the municipal requirements and certain municipalities, some are sophisticated, some are not so sophisticated, so they're leaning on whether it's some City of Vancouver standards or trying to create their own. It creates can be a challenging environment to tackle the design of some of these large-scale projects. So I think we are very optimistic that we can meet these challenges, but I think trying to tackle them, on the boards right now is very, I'm not going to say it's overly challenging, but it certainly presents an opportunity to look at things through a very different lens when you're trying to get things built. We have, very fortunately, good construction partnerships, so we can get pretty accurate building construction costs back on a regular basis, and we do find ourselves in situations where we're having to go back and look again at certain things, even at concept design, just to make sure that we can make these things work based on, and every project's different. So whether it's contextual pressures, whether it's, time coming to market, the long lead times and having to wait for municipal permit approvals, all these things can make life challenging. So it's not easy, but it's, we are working towards it. And I think we are going to be successful, but there will be definite design impacts along the way.
And you, Nathaniel, do you forecast and foresee the changes right at the beginning, or how do you proceed?
Yeah, we're talking about like designing for the new regulations, right? Yeah. It's very challenging.
Like step code, we know it's happening. It's next year. Your project is designed now. Do you try to squeeze in before? Do you?
Yeah, I mean, we map a detailed schedule, and if we can, we'll deliver the design that meets the regulations at the time. What's really difficult is when there's uncertainty about the regulations. So it does help when there's a lot of when there's confidence about what's coming. I thought you maybe mentioned something about agility or flexibility in the design, which is interesting at this time. Like right now in this market, at least in Canada and Lower Mainland, it is really hard to get buildings built. Like it just doesn't work. The costs are the highest we've seen. I think last 5 years, the Canadian Construction Price Index has gone up about 50%. For context, I think the last 3 decades it averaged around 30 to 40% increase over the decade. So we've already exceeded a decade of cost increases in 5 years. Interest rates are high. Municipal fees are high. And for the most part, most of the revenue sectors, sales, rental, office certainly is flat or down. So it's really, really challenging right now to make projects work. So it's, when we talk about changing regulations and flexibility, our focus is really on efficiency and optimization and making really smart choices that give each project a chance, because it's very, very difficult. It's really easy to draw, the designs and have it come with pretty pictures, and that's all great. But to actually get it built and procure it and construct it, it's a very difficult time. So we're really focused ourselves on making every dollar count and being really effective in the application of those dollars into every design decision. So the last few slides I showed were mostly rectangular, straight, up and down, repeatable floor plate buildings to try to combat the challenging market it is.
Very good. That leads me to my next question. So how do you select your material or construction system? Is it the cost, the value, the durability, the look, means and methods? What comes first?
It's cost, and it's cost. No, but in seriousness, it's probably more cost effectiveness, I would say, because there are things that people want and need, and there's an element of not designing to the bottom. There's an element of trying to bring really high quality spaces and solutions to the marketplace. In the case of housing, everyone I hope and presume lives in a home and wants to have a great place to cook and spend time with family and friends. And so there's an element of wanting to put your money into the right spots. Right now, the kind of mantra we live by is like inside out planning. Really like design the home, at least in residential, probably all building types or asset classes. Really designing the home from inside out, and in the facade in this market is a reflection of what the end user is going to want to have in their home to make it functional and livable, or an office tenant in terms of optimum working experience.
And PCI cost, only cost?
Because we are developing for owning and operating, I would very much echo the same sentiment, because we know we want to be able to bring our product to market and look after it. Right now, primarily we're looking at costs associated with making sure the suites have got long-term durability, making sure that they meet market expectations for what tenants are looking for. So not just in the suites, but the level of amenity. We're focusing very heavily on our amenity offerings, and making sure that we can provide something that's going to be meet or if not exceed the level of expectation. Some of that is prescriptive by municipalities, but a lot of it is us going to market and looking what our competitors are doing or what is available, what the trends are, and trying to meet those and sort of future plan to deliver on those. So, and again, to echo Andrew's comments, we do want to make sure that we are providing that sense of neighborhood, the sense of feeling like you've been designed to be accommodated well, given that there are a lot of stresses on the rental side. Typically, people expect a slightly lower class of product from a rental perspective than necessarily from a condo. But given the challenges, that's we still have a lot of people looking to get into rental housing. Obviously, it's a hugely demanding market, and their expectations are still there. So certainly in order to make projects pencil, the costs of rents are only going one way, and when you're paying that much rent, your expectations for what you're going to get in terms of your living space is going to be pretty high, relatively speaking. So I think the willingness to look at developing a building which is as wonderful on the outside as we could possibly hope to be, given the pressures of trying to provide a great product for the individual tenants, in a rental unit, there may be some, cost savings that go into that exercise. So, whether it's more classic design style, whether it's sort of more rectilinear design, or whether it's trying to keep costs down in a more value engineered facade system. These are all elements that are certainly being felt and being brought to bear on the products that we're developing.
Yeah. So with escalating costs, escalating regulations, how do you build resiliency in your decisions when you are designing today, but you're only going to start construction 3 to 5 years from now? You mentioned 50% increase in 5 years. So how are your decisions today are resilient to know what's going to happen 5 years today? And how do you accommodate that?
Yeah, that's a great question, especially with like the burgeoning of AI and what that means for this industry. This industry, when I say this industry, construction buildings is a slow-moving industry compared to, like, say, technology. I went to university and we have cell phones, and look at where we are. Construction 20, 30, 50 years ago it's different, but it doesn't change at that pace. And so one of the things that we're thinking about and actually working on is how do we improve, rather than building in resiliency as like a flexibility for later to make changes? No, more like how do we build in resiliency by getting the information that we would need at the end earlier, so that we're making better decisions earlier. And that's really around, from our side at least, it's like leveraging our vertical integration of, from acquisitions to through design, construction, and property management. The knowledge of the data that's informing the decisions early on. So resiliency, in my mind, I think of it as getting more data to inform better decision making early, so we get the decision right and we don't have to make the changes later on. And I think there's a role to play for AI in this as well, or at least how we manage data. At the end of the day, AI is kind of all data and data management and coding. So that's I don't know where it's going to go, but that's kind of where my head's at least in terms of. Can we leverage technology to improve our decision making when it comes to design and effectiveness?
Definitely. What about Tao?
Yeah, I think from my mind, I think it's going to be given the lag in the ability to get a building permitted. I think whatever you can do to save time, effort, and money on the back end is going to be where you're going to end up looking to make some cost savings. So, we had the presentation earlier about the panelized cassette wall systems, reducing lead times and getting buildings built faster. I think that's probably going to move the needle a little bit. But I think the amount of design that has to go in the front end to achieve that back end sort of speed of construction is going to be a sort of a system change from what some of the developers might be used to for doing sort of rental or residential construction. But I think, given the needs for air tightness, building performance, all these other things that are getting more and more stringent, I think the panelized system that speeds up construction on site, I think that's will be of big help going down the line. If we can say that, if we can't get the municipal system moving any faster, at least we can move faster on site. But obviously that means that, to your point of having data that we can feed in the front end quicker will mean that we can then look to adopt these sorts of panelized systems in the future to help expedite construction. I think is going to be, for my money, is where I would be thinking things are going to move to.
Yeah, definitely. Sophie, do we still have time for a little Q&A maybe? Or are we running out of time? All right. So is anybody would like to ask the panel questions here? Anyone volunteer? If not, I point you. Fashid.
From the city's perspective, what would you say they try to streamline or make the project right now? Where do you think they should focus? Like, do you think some of the requirements actually like the environment or?
Great question.
It is a great question.
Go first? I got a lot of ideas.
By all means, I'll tack on whatever you don't cover. I'm sure I'll get to.
First, great question. Thank you. First, what I'd say is I think more than I've seen. I've been working in Vancouver region for 18 years now. In the last kind of 18 months, I've seen more progress than I've seen probably in the previous 10 years. So kudos to all municipal staff and levels of government who are trying to get moving in the right direction. Look, with the housing accelerator funds that are out there, and those funding is dollars are tied to things like, meeting housing objectives like streamlining applications, for instance. And we're involved with many of the cities right now on discussing what are the best paths forward. So there are lots of options. I think some of the things that are happening that are good are an intent to streamline, which is to say, reduce the level of conditions on applications in design, which I think is a great thing. Sometimes we just so many conditions to try to make everything perfect early on. So reducing that. I think we're starting to see evidence of condition complexity coming down, but there's a long way to go. I would say every municipality in some ways is competing for investment dollars. And some municipalities are doing a better job of that than others in terms of trying to actually expedite approvals. There's such a huge contrast right now between municipalities on how long it takes for things to change. So I would say just sheer speed, and that's either in the way of manpower, leveraging AI, or reducing complexity. All three of those are areas that most of the municipalities that we're talking with and working with are trying to do and are good things. Where I think there's a lot more work to be done is fees. The fees have been going up dramatically. Some new fees being added. Certainly, if you look at the cost structure of a business case of a project, municipal fees used to be a very small percentage. It's been growing and growing and growing, and now that pretty much governments are one of the biggest sectors of the cost structure. So that's being passed on to all the end users for buildings, and it makes it really challenging in a difficult market to get projects off the ground. So reducing the costs would be, at least at this moment when there's a need for incentives, would be valuable. I think I'll stop there. So I could keep going. Maybe I'll think some other ones, but you could.
I think you pretty much covered it. I mean, I know my colleagues at PCI would definitely echo the statement on fees. I think I am heartened to see that there are trials running right now in terms of digital submission of plans and plan review, and I think getting a handle on that process and getting it done faster is going to be a big one. Making sure that all the parties that need to have their eyes on the drawings can do it effectively and efficiently. I think there's definitely some room for improvement there, and I'm looking forward to seeing what the digital submission process looks like in terms of speeding up municipal approvals. We shall wait and see. Yeah, that's pretty much the only thing on my radar to add to your very comprehensive answer on that. So yeah, we've got time for one more question, perhaps.
Yeah. One more.
Or is everybody hungry?
Oh, we said it all. All right. One last but not least.
You would.
Thank you. Maybe. Oh. Maybe a follow-up question. So when you erect these huge towers, obviously there's more likely going to be some infrastructure implications. I've noticed that on a couple of projects, when the city takes on the upgrades, the costs are racking up. From our estimate, like 3 to 5 times what we would estimate those costs to be. I wonder if you feel like you can deliver those infrastructure upgrades that are directly tied to your development more cost effectively, and are you indicating that to municipalities that it might be more efficient for you to take that on as opposed to the municipality contracting someone on their side, and we're seeing those costs are a lot higher than what we would expect.
I've not had a lot of experience with that, so forgive me. My understanding is from some of the projects that I'm working on right now, there are sort of aspirations on district energy and all these kinds of things, so tying into like bigger neighborhood systems. And then we are neighbored to other developers who are also coming online in a similar time frame, so specifically the Spring Street project in Port Moody. Whether or not developers should get involved in the infrastructure game, I'm not entirely sure if a city ceding that to developers is going to necessarily make things better, just because I don't know if infrastructure is something that developers want to take on board in addition to everything else they already have to deal with to get a project off the ground. I'm thinking about various delays, permitting, all these kinds of things, you add another layer into this to make life even more complicated, I think it's going to make our capacity to deliver on these projects that much harder, would be my expectation.
Yeah, I mean, I would say something similar. I'm not sure I can answer that question because I don't have enough experience to know how the public sector or municipalities really deliver it in a number of examples. I would say generally our approach is one where, less is more here. Let's try to keep, like, a project is hard enough and it starts to get tentacles and gets bigger and bigger. It gets harder to manage and harder to prove viability. But often our projects are very big and complex, and we find that the city may say, hey, we would like you to deliver this on our behalf, which from time to time we will say yes, or from time to time we're conditioned to do it as a condition of our approval. I don't usually want that, but I think there's some good things that are happening. Is what you call cost sharing. I understand that helps. So every frontage kind of shares in the cost, although there's time limits on that, which is a problem. Because you might be building upgrades for a 20 to 30 year growth cycle, but there's a time limit on the cost sharing agreement to 10 years, which is really problematic if you're a first mover, which we are in a number of our sites. That would be one that I think there could be improvements if that cost sharing was longer. And then I had another thought, but I'm losing it now. But yeah, maybe it'll come back to me. But maybe a follow-up question on that if you want further explanation on it. But yeah.
Very good. Well, that wraps it up. We should have lunch, everyone. Thank you so much, and we can still talk in the lounge.
Well, thank you all for the discussion. That was really interesting and grounding. It's time for lunch, and some of you have already left, but I will invite the speakers of this session to come back to the stage for a photo. So, for those of you who are leaving, we'll have about an hour, a bit less than an hour for lunch. We'll call you in.
Welcome to Avalon, a space to explore a shared virtual reality experience. Did you ever wish you could walk into a building that is still in the design phase? Avalon can take you anywhere you want. Active 3D glasses create a natural spatial awareness, and as a user, you are instantly immersed in a true 3D environment that creates an incredible sense of scale and depth. Avalon is a collaborative working tool, offering a joint experience between architect, contractors, investors, engineers, fabricators, and Rayner's experts. Virtual reality is set to play an important role at all stages of the architectural process, from evaluating design options and showcasing proposals to detecting construction issues before breaking ground on site. Avalon allows you to explore your projects inside your usual design software, from initial sketches through detailed technical models and realistic scenes. Discover Avalon, the space where future projects become a reality.
Okay, everybody. Lunch is over. We can take a seat and proceed with the afternoon. I hope you had good food and good conversation with colleagues that perhaps you haven't seen in a while. This morning we saw pictures of buildings that have curves and different forms that are quite extraordinary. This afternoon, starting the afternoon with a little bit of a hard job of keeping everybody awake after a nice lunch. We have Leonard Pianalto, who's going to talk to us about facade maintenance access when architectural form, sustainability, and worker safety meets.
Is this on? On? Yeah? You can hear me? Okay, that's why you guys are sitting up front, right? Thanks for the introduction, Sophie, and I'm very happy to be here with all of you. And we had some great speakers this morning, and hopefully I can measure up. So we're all good after lunch? You didn't eat too much pasta? Had some coffee? You're all like ready to go? Okay, so I'm going to shift gears a little bit. Everybody's been talking about all these beautiful facades and low iron glass and optical clarity. But, you know, what good is that if the windows are dirty and you can't see through them, or if the windows have fogged up and you need to replace them? Of course, I came across this image recently, a newspaper story, and I thought, okay, well, I guess I have nothing to talk about, right? Because it's all been solved with drones and robots. But I'm going to try and convince you there's more to the story than just washing your building with a drone. Just tying into the theme of, you know, how technology changes the way we design and maintain buildings, I'd like to just do a little historical perspective on how facades have changed over the ages. I always love this picture here, and I try and weave it into any presentation that I do. Sort of the earliest form of glass production dating back to the 16th century, relying on spinning a blob of glass, molten glass on the end of a tube, creating these discs, cutting them up into little squares, putting them in windows. Fast forward to the London Expo in 1860. This is the Crystal Palace, and I believe that this is one of the first examples of a metal-framed curtain wall assembly. And just to juxtapose the way the workers are situated on the building. And fast forward to a project that I worked on in Calgary, the Brookfield Place building with Dialogue Architects. This was the podium with a very, I feel like you can hear me breathing in the mic. Is that supposed to be that way? Sorry. So this was 2018 or so, and very high-performing facade, closed cavity facade elements. They're double curved glass, and this just shows the workers that are installing that glass. Who happen, I think some of them happen to actually maybe be here. That I learned earlier that those are folks from Dessa Glass. The manufacturer was Sealy, who I worked with as their engineer of record. But that panel there is 10 feet by 20 feet, or 3 meters by 6 meters, and it's about 3,000 pounds. So a lot of labor and equipment to get that piece of glass in. Okay, so I'm here to talk about fall protection and building maintenance, and at the heart of that is worker safety. I think it's well accepted that in the workplace, falls are the leading cause of death in the construction industry. So this is a real problem that we have to think about and face, and there's a more than just a practical imperative, but a moral imperative that we think about these things when we design our buildings, that they be maintainable. But modern building codes don't get you to think about building maintenance. They're focused on occupant safety and occupant comfort. So the worker safety comes in on the other end when the building is built and needs to be maintained. So this is just there's 4 basic elements to protecting workers when they're working at heights. There's travel restraint, so you're stopped from getting to the edge, or you're using suspended equipment, or you're using trained workers that can do rope access techniques, or Bosun chair as the person on the bottom right, or there are fall arrest methods where the worker can work in a place where they can be in a fall hazard and they can fall, but then their fall has to be arrested. And what I want to talk about in the rest of my talk is how codes are changing and authorities are changing their stance on this. And I think there will be a code change that are going to invoke the requirement to consider building maintenance. And I'll give some examples of where the authorities having jurisdiction have imposed this as a requirement to get your occupancy permit. So at the heart of designing these types of systems and thinking about worker safety is, at the heart of that is what's called the hierarchy of safety. This is a framework that safety professionals rely upon. And we have on the vertical axis what's called effectiveness of whatever method you're using. And on the horizontal axis is the defeatability of that method. So it means what does the worker have to do in order to be safe? And the more that's expected of the worker, the more defeatable it is. So if he has to wear a harness, he or she has to wear a harness and connect onto something, they have to have training and the right equipment. And if they don't do that properly, or if they just decide not to do it, they've defeated that. And so as you move from left to right, the worker is exposed to a greater hazard, and therefore that's reflected in increasing risks. So another component of this is what is risk? I mean, risk is very different to different people. So here's an example of a specially trained rope access technician worker. This was the Blodell Conservatory reglazing that I did a number of years ago with the city of Vancouver. The Blodell Conservatory is on top of Queen Elizabeth Park, and if you haven't been there, you should go check it out. It's this tropical environment built inside this geodesic dome. And so inside this building, there's 200 different species of birds. This is a bit of a tangent. But so part of this job meant that these special workers had to go up and put this netting up so that the birds couldn't escape. And something that was a bit new to me is that there's predator birds that they didn't want to go in and kill the birds that live there. So the whole point of this is that this is just another day at work for this fellow. But for me, I like to sit at my desk in front of my computer. That sort of terrifies me to think about doing that. So again, that person's definition of risk is much different than mine. So to try and normalize that, we use this risk definition. So I'm gonna just, this is like one equation that's on the board here, although I've disguised it a little bit, right? There's just a bunch of words. So risk is the product of consequences times vulnerability. This is a very common framework for defining risk. And so we've crafted it to include that defeatability component by considering those two blue terms, the frequency of the activity and the required skill of the worker. And so that will change that risk score. We tried to develop a database of numbers so we could have this quantitative score of what a risky situation is. And we published that in 2018. And so, I just thought we would change the world of risk definition, but I don't know that anybody's referenced it other than me, but anyway, let me move on. So what happens when it all goes wrong? So here's an example. This is in Vancouver a few years ago, and I'm not going to get into the details of whose building it is or where. Some of you might know of this, but this was I call it near catastrophic collapse of a swing stage. It's a 22-story building in downtown Vancouver. It's probably, it's a 20-year-old system or so, plus or minus. So there was this incident, nobody was hurt, there was minimal property damage, but there was an investigation, and we were hired by the owners to investigate how this happened. The Occupational Health and Safety Authority also did their investigation, but we both concluded, essentially, that this was a worker failure, and it was worker error, I should say. And then this ties into that idea of this system being overly complex and therefore somewhat defeatable by the worker, and they just didn't follow the procedures properly and caused one of the masts to come detached from the rail. And then this happened. So what we did was, moving forward, we repaired it by simplifying it. So it used to be that there was this track that rode along the roof, and it was kind of like this roller coaster that would go up and over the barrel vault. I think it was, a good piece of engineering, but again, it was just too complicated for the workers that were just there to, wash the windows. So we simplified it by decoupling it, and that meant we put this fixed rotating mast on the top of the barrel vault. So nothing overly, novel about that. But the cautionary tale here is for the architects in the room, and that is that, protecting your architectural vision means that you should think about this when you're designing your building, so that people like me don't come along and do this to your building after it's built, right? The architects in the room know what I'm saying. So if you stand in certain places in Vancouver, you'll see this thing atop the barrel vault. I mean, I think it looks pretty cool. I don't know, but probably not part of what the architect wanted you to see when you stood and looked at that building when it was first built. So here's a first example of where the authority said, we need you to build a maintenance plan or we're not going to give you occupancy. And so this is the post office in Vancouver. It was a heritage building, and out of the middle are these two new towers. So we had many people in our office that were part of the structural design team, and myself and my colleague Carmen, who's in the room here, we were part of the heritage preservation team, the heritage facade preservation team. So on the lower floor, that's the original post office in downtown Vancouver. And there's large precast elements, there's large granite panels, and these massive aluminum emblems that you can see. It's facing Georgia Street there. So we embarked upon this work to preserve that facade, and a lot of that was focused on seismic retention of those heavy elements. But the city said, we need you to convince us that those elements are maintainable and that you can do regular inspections, and you have to develop a plan that shows that you've considered those things. So again, that it's not really concerned with worker safety, although that was the basis of what we had to build our plan around, but it shows that the authorities having jurisdiction are thinking about and pushing people to, that are building owners and operators, that you need to consider these things before you finish construction and occupancy. So you heard about this project earlier. Our friends from Henriquez and Partners talked about the Oak Ridge project, which is a massive project. I don't think they really talked about the scale of this, but sometimes this project is touted as the second town center in Vancouver. There's 14 residential towers. It's like 1 million square feet of retail space, a lot of amenities. So, and Adamson and HPA were the architects, or are the architects on this project that we worked with, and we were the facade maintenance consultants for the entire site. And so the challenges that I want to talk about here focus on the geometric complexity of some of the buildings, something that was talked about quite a bit this morning, and also just the scale of the project and how that influences the way that we thought about and managed the building maintenance. So, first of all, dealing with these complicated geometries, this building here, I don't know if you guys used this term this morning, but the way it was described was the bones and the veil. So this created this facade with these flybys that it was almost like a double facade. But anyway, you can see that this is just a geometrically interesting and complicated structure. And part of what we did in laying out the access plan was to create this graphical way of expressing the vertical columns that the worker could, where the worker would be and how it could touch the facade. And so you can see in the bottom right, these circles that would be extruded from bottom to top and connect where they would be connected to on the roof with where their hands could reach. And the little blue circles would be the physical reach of the workers. And so that allowed us to sort of tackle the complicated geometry and efficiently plot out where we would put these devices that would allow you to suspend from the rooftop. So you might be asking yourself, well, why didn't you put a building maintenance unit or one of those traveling machines that are on a track? Well, there's sort of two schools of thought in the discussions I've had with many different building operators and owners. And some really like building maintenance units, and others dislike them and want to do everything to avoid them. So there's a very specific clause in the suspended access standard, the CSA Z91. It says that buildings less than 150 meters or 492 feet do not require a building maintenance unit that's on the roof. So this building, if I'm right, is less than that. So we were able to kind of get around that. And again, the operators of these buildings have had problems with BMUs. They do require a lot of maintenance, and that example of what I showed you where there was the failure was one of those systems. And so again, certain operators want to avoid those things. Part of the facade geometry required that we penetrate through this the veil at the top, and you can see there's this sort of curving feature, and the curtain wall kind of runs past the roof. And in order to get the suspension points through that curtain wall, we had to work with the facade consultant and the curtain wall manufacturer and the architect to get the geometry right so that the booms could go through these operable windows. And allow us to create suspension points, both for just window washing access and then for more heavier duty activities like glass replacement and gasket maintenance, those kinds of things that are less frequent. So this was another example of where the authority having jurisdiction got interested in how we were going to maintain and access the building. And so in some of these terraces, there were planters or rooftop gardens, and the city said, we don't want those gardens to get neglected. And so we know that in residential buildings, some tenants don't like landscapers or workers going through their suites. So we need you to show us that your system will allow workers to come descend from the roof, get to where they need to go, do their thing, and get back down to the street without having to go through people's suites. And that was an important thing that the city wanted us to demonstrate. So you can see, and rather than show you the nicely cleaned up sort of BIM images, I'm showing the notes that were done by the engineer in our office that planned this out. And this is my colleague Kelsey Van Steel. She's an engineer, but she's also a rope access technician. So she kind of knows how the equipment works and knows what it takes to maneuver yourself when working in these situations. And so this, or maybe a cleaned up version of this, was brought to the city, and they said, okay, you're good to go. We believe you. We know that those gardens will get taken care of. Part of that is, again, related to the geometry and having the workers have to use their suspended equipment and ropes to travel down the building. They would have to redirect their forces, redirect their ropes, which meant that there's forces that have to be transmitted through the stabilization pins back into the curtain wall, back into the slab edge connector. And so in doing this analysis, we looked at the forces that would have to get redirected through those stabilization pins. And if you look at the very top of that image, that's sort of your traditional 6 millimeter or 10 millimeter diameter pin. But because we had to manage larger forces, we had to go to these larger pins. And you'll see each little triangle on the elevation of the building represents where we wanted the stabilization pins to be. So if you just look at these things, they're very small when you look at them on your desk. But if you imagine standing back from the building and seeing all these little holes, as those holes got bigger and more numerous, they would impact the look of the building. And if you're not careful, you can change the sight line because you have to manage the receiver, which means you might have to make your mullions a little wider. So there's a lot of talk and discussion around that, as I remember it. And so those are some of the considerations you have to make when, again, the combination of the confluence of all these different factors in designing a system that is a little bit irregular or not like your normal swing stage access system. So looking at the interior, there were massive interior spaces and large exterior terrace spaces, which can present difficulties when you have to access those areas that are very high up. And you can use things like platforms and monorails. But because we worked with the building operators, the people that were going to have custody of the building after it was sort of built and handed over, we arrived at the use of crawler booms, and you can see some images on the right-hand side there of actual physical examples of them. And we settled on two different sizes. There's a 60-foot one and a 100-foot reach boom. Now they move very slowly, under 1 mile per hour, and these are the kinds of things that you have to discuss with the operators so that they know that there's going to be a certain time element involved. But in the end, we determined that this was the more cost-effective solution, including all of the practicalities of moving these things around the site, storing them, and then we used our modeling to ensure that these things could freely move around. They sort of collapse in, and they can drive around, and you can go through doors and such. And we made sure they could reach all the areas they needed to reach. Now, they're very heavy. The largest unit is about 17,000 pounds, and that's just sitting there. And once the boom is extended and the outriggers have to go out, you have very high concentrated loads. So you had to really think about where the machines were going to be, how they were going to get there. And so we created these maps that are load maps, and we gave those to the structural engineers so they adequately designed the slab to accommodate that. Okay, I'm getting close to the end here. Here is an example of a double skin facade that I was involved in the design assist phase. So the building has not advanced past that. It's probably still a secret, so I can't say which building it is. Some of you might know. But so this is, I think, something we should expect to see more of, double skin facades. Just a regular unitized curtain wall up against the slab edge, and then what they called like a fabric brise-soleil that was projected out. So you can just imagine some of the challenges with that. First of all, you have this heavy element that's set farther out from the slab edge, so that's going to create much larger forces that you have to deal with. You have to be able to get into that interstitial space to maintain and clean the windows, maybe do some glass replacement or whatever you need to do for maintenance. And the other thing was that this was a fabric element on the second outer skin. And that one of the defining load cases was ice formation. And I guess rain would collect on the fabric to an extent and then create ice loads. So you're pushing a very heavy load far away from the slab edge, and you have to transmit that force through the curtain wall. And that meant creating large anchorages and dealing with all those movements that Brian talked about earlier, interstory drift and that sort of thing. And so that automatically led to concerns over thermal bridging and condensation and those sorts of issues. So I thought this would be a nice kind of, one of those images that people like to see of a 3D Thomsol analysis in optimizing the connectors and the arrangement of the steel connectors to create this very large anchorage to bring that large load back into the slab edge. And so this is sort of this coalescing of many different engineering disciplines to arrive at this, one very special connector. And finally, and this is sort of a thought that I want to leave you with, and this is where I think one of my main themes is that the building codes as they are written now don't really require us to think about the maintenance of the building and the worker safety, but we anticipate that those requirements will be brought into the code through the 2030 edition of the National Building Code, plus or minus, through the adoption of the CSA S478, which is the code for durability, the Canadian code, or the standard for durability in buildings. And so just to leave you with this thought, I mean, these are, I don't know if they're just aspirational common sense statements. Buildings should be durable and functional for at least the time period required by the owner, right? Like, duh, I guess, I don't know. But the part that I want to hang my hat on is, components that are not expected to last the life of the planned life of the building should have with it a method of replacing those parts. And so this is an example of the Canaccord Tower, and we worked on this with Perkins and Will, reglazing this tower, and you can see we had this wraparound scaffold that transformed that, that dark black monolith that was in downtown Vancouver into this beautiful sort of white crystal appearing building that we know it to be now. So I think that's just the underscoring that the building structure is going to outlast the facade. So you got to think about how you're going to maintain and replace the facade. And that's it. Thank you.
Well, thank you, Leonard. Some more things to think about as we imagine the facades of the buildings that are to come. No questions, because we have a very, very tight schedule, although you answered one of the questions from this morning that I heard at lunch, so. The next presentation is a duo. We have Martin Nielsen and Ryan McClanaghan from DIALOG, and they will talk to us about the hive, inspired by the pattern of nature.
Microphone, good. We can hear. Excellent. I don't think you can hear me breathing, but maybe. Very, very happy to be here. This is a project we're very excited about. It's in the False Creek Flats. It's an emerging neighborhood. There's a push for more diversity in this industrial neighborhood, and there's a discussion around wood innovation, but also a facade expression that actually follows the structural system, the structural solution, which we think is kind of cool and worth talking about. My name is Martin Nielsen, partner with DIALOG. I have Ryan McClanaghan with me. He's a senior associate. He's our wood expert, and he sits on the COV, City of Vancouver Mass Timber Advisory Panel as well. Next slide. So our anchor tenant for this project, it's 165,000 square feet. How many people know the building, drive by it on a regular basis? Yeah, I get a lot of, oh, your building's coming up, finally. Well, we started this in 2015, so patience as a virtue. The anchor tenant is Nature's Path, and for a long time it was top secret, but it's now out in the media. And they are organic farmers, like they're going back generations on Vancouver Island. They were organic farmers, and they produce organic, non-GMO cereals and breakfast. Everybody knows Nature's Path, right? Yes? Okay. That's actually their mission statement. That's kind of the first thing we were introduced to when we met with them, and the kind of objectives were being laid out. And this is from Villas's farm in Montana. It's 2,800 acres of organic farm that they own. They're vertically integrated. They own another 5,000 acres of organic farms in Saskatchewan as well. So it's a very holistic family, you meet at the kitchen table kind of client. That was really a privilege. So the site right at Great Northern Way in Clark, very strategic location in terms of transportation and infrastructure. This is the condition of the site when we kind of inherited the project. And it was a site owned by the city of Vancouver, and it hadn't been developed in as long as I've lived here, which is a long time. It also sits in the shadow of the East Van Cross, or the monument to East Van, Ken Lum. One of the most politically charged pieces of art. I remember this as a kid. You know, the tough kids would have that image on the back of their jean jacket. It's very cool to be, and it was fraught with danger as well, working in that context, but that's a whole other story for another day. It's a really tough site. We're right up against the SkyTrain station. There's a 4-meter setback requirement. On the east side, we have Clark Drive, arguably the busiest arterial in Vancouver, trucking, noise, pollution. We have a 6-meter setback here on the Central Valley Greenway. And then you have a very busy transit exchange that serves the station itself. So by the time, and then the sewer right away, that's a 9 meters, right? 9-meter right-of-way that we couldn't build over. They have to be able to get at that pipe that's in the ground. So we had a 41,000 square foot site. By the time you took off all of these deductions, there was about 25,000 square feet left. It does have some positive attributes. Great views to the north. Really no shadow impacts in terms of the existing conditions down there. You have this long, skinny site that's facing south, so you can control the solar. And so and what you see there is essentially that 25,000 square feet extruded up, 10 stories. And we were at an FSR of 4 when we finished. What's cool is the way, when you zoom out and you see the way it's embedded in this site, it's a really complex, dynamic site, and it does appear to kind of be rooted in the site, but also grow out of it in a very natural way. And I think the building responds quite well to climate, topography, infrastructure, and all the movement that's happening around that station as well. So how do you design a building for organic farmers? What does organic architecture mean, right? And how do you express that with mass timber? What you see is a traditional post and beam version. There was a breakthrough moment with Fastanet, and they're the structural engineers. They're brilliant. They kind of own, I would say they own mass timber. Paul Fast suggested taking the seismic structural elements, the seismic resisting elements, and moving them to the perimeter because we have this long, skinny floor plate. And he kind of drew, on the elevation, he drew the diagonals. He said, we'll need one here, one here. You can see them on the middle image. And that freed up the floor plate. And it made it far more flexible, and they could reconfigure, and we looked at how the core might be reconfigured. And then Ryan kind of went up to the board and connected, that ziggurat, connected it across, and out of that came the honeycomb. We kind of, if we move this a little bit, it's a little like a honeycomb. So we thought, pretty cool, but it's actually part of the structural system. It actually reflects, we call it facade follows forces. And so it's it's been a fascinating project for us. That said, we're really pushing the boundaries of traditional seismic codes and restrictions. So we were very lucky to get $3.5 million from the federal government. This was the NRCan program. And what it was for was to make this a case study building and to pay for anything but the wood itself. You couldn't buy lumber with it. But you had to, and in our case, it really paid for extensive design, analysis, research, code-related research, but more importantly, structural testing and destructive testing, right? Just looking at different joints and how they responded. So that was a huge gift to the project, and I think we probably would have backed off from this concept if that hadn't happened. So let's start at the ground plane, lobby and all the ancillary back of house services. The site or the landscape has to reconcile 12 meters of grade difference. And then and part of the theme, having organic farmers, was an edible landscape. And celebrating with rainwater and treating and managing runoff as well. There's your typical floor plate. As I mentioned, it's 165,000 square feet, 18,000 square foot floor plates. You can see where those perimeter brace frame elements are, where they kind of double up. There's 10 of those. The other thing that we did was, in the narrow direction, we couldn't, the frames on the north-south couldn't work hard enough or do enough work. So the cores are actually mass timber elements, shear walls. So there's no concrete. We do not have a concrete core. We actually found a pathway to eliminating that and integrating it into the design of the building. I like the section on the right, and this is a blow-up. It's got the nickname The Hive, and obvious with the honeycomb, but also just looking at the activity and diversity in that building. I like that we can do a interconnected floor plate or connecting two floors through just by removing CLT panels. So just pulling it apart, we have a four-story parkade underground. We have a single-story concrete podium, which actually embeds itself in the site. It didn't make sense to make that out of concrete because it actually is underground at some point. And then we have a 9-story perimeter frame mass timber structure, and then the series of balconies. And it's really a contiguous frame element, and I think it works at a bunch of different scales. It kind of gives an identity to the building at a neighborhood scale. It actually reduces the scale of the building because they're 2-story volumes from the street level. And then there's an individual level, when you occupy that balcony and the garden or whatever that will be on there. And it's kind of a prospect and refuge opportunity. These are diagrams that were very early on in DD. We brought in a pre-construction consultant to understand how the building would come together, how you would integrate those balconies into that sequence, and the idea that you needed the kind of unitized curtain wall system that would very quickly close up the building because we were going to be building through rainy season no matter what. We're now at the 9th story. We've got one more story to go, so drive by, have a look. The most important part of the whole story is really that little HSS stub, which allows for the attachment of the balcony system and to integrate it into that unitized curtain wall. So then you can see this combination of steel and mass timber balcony structure. The mass timber is actually exposed. It is the soffit of the building. So when you look up, you see the warmth of that wood. And then a thermally isolated joint, and then the cladding system. With that, I'm going to pass it on to Ryan, who's going to get into the details. There you go.
Thanks, Martin. So some of the principles as we were starting to plan the facade, the glazing, the vision glazing goes to the underside of the beam. There's a perimeter beam at around it. We have a sill for desk height, we have operable windows, and then we have doors to the balconies. As you can see here, there's an idea that the facade really traces the structural system, and so the spandrels here are set at the same depth as the balcony, so it's sort of continuous expression along. A lot of work went into having a very clean interior, so it's not really the focus of today's talk, but thinking about mechanical, electrical devices, your in-room acoustics, so a lot of structural and architectural ingenuity to have a really clean interior expression. So we have a really simplified facade palette. We have the silver metal panel, we have the exposed CLT soffits, and then we have the glazing. As Martin mentioned, sorry, spotlight. The underside of the horizontal balconies will be exposed, as well as the underside of the diagonal, and the top side here are clad and protected. So we're only using wood on the outside in sort of a soffit condition, and those will be treated with a protection system, a wood treatment. As Martin mentioned, you see the facade follows these forces. In blue, the perimeter braces, and in blue again, in the interior and the cores are the shear walls. What we really liked is through some serendipity, there's kind of an even number of braces around the outside, which allows the pattern to kind of flow continuously along and actually turn the corner quite nicely. So you sort of have one bay of that on one side and one bay on the other side. As part of that structural testing from the funding from the NRCan, there's full-scale testing at the University of Alberta and Queen's University to study the seismic movement of the building, which really gave us a lot of good information to pass along about interstory drift and movements and design. So we're quite confident in how the performance of the building and things that people had to incorporate further down the line in their more detailed work. It was important to us that the balconies kind of provided this depth to the facade as opposed to kind of a shallowness because of the SkyTrain right away along the north, and north being kind of less sunny, there's no need for balconies there, so it's much slimmer. You can see it kind of tapers out at the east and west ends and then goes to a full sort of 2 meter, 6 foot depth along the west, south, and east of the building, shown here in plan. With structure and architecture really working hand in hand, it was important that we had kind of multiple elements line up. So the creation of shared geometry was important. So we used work points, which are centered around the structural nodes. That's kind of the centroid of those HSS stubs. But the HSS stub was also kind of the centroid of those brace frames and their connections. So it gave us kind of the shared geometry and work point to come back to and work from. So that drawing previously was structural. This is architectural. What we did is we did an offset. So quite a simple offset of the buildup of the balcony that we needed to create kind of that banding in the facade, and then matching that same one for consistency along the diagonals. So here's our drawing showing the work points, and there's kind of previously sharing the work points. A big day when the concrete finished and the mass timber started arriving on site. So you can see, as Martin said, there's no concrete structural elements up above that level 2 deck. These are the first of the CLT shear walls. The trade, George III and Kolesnikov, opted to prefab these as 3-story tall panels, and they're stitched together. It's quite a big day on site. You can see here the size of them. They're using Tectonus force-resisting devices at the bottom of the shear wall, allowing them to rock, recenter after an earthquake. As the building kind of grew from the neighborhood, the second element of the project, the facade skin of the project, followed. You can see here this kind of space in the interior view that we started looking at. The Tectonus devices were also used at the head of the brace here in silver. These will be exposed. These dissipate earthquake force by using a series of plates, and they sort of provide friction in the most basic way and resist the forces coming through there. The idea is that these self-center after an earthquake, they can be retuned, and that the building is almost kind of post-disaster. So as the curtain wall started getting installed, it's a unitized curtain wall system. Some of the larger mega panel systems weren't as popular back in design when we started this a long time ago. It was also kind of important that, you know, curtain wall is a fairly common building material and approach that allowed like a lot of different systems to be carried. So we actually had a performance spec for curtain wall, allowing different solutions to be brought forward. Due to kind of a quirk of the structural geometry, the braces are top aligned here on the ground floor and then bottom aligned on the typical floors. And that's really where that connection happens and how sort of the forces of the building come together. So the north facade, which is kind of the slimmer expression, has a metal panel here, which provides a profile and follows that honeycomb shape. On the right is a typical spandrel bypass detail. These are being installed with the panels as they go up. So the north facade is actually sort of what we're going to get in the final condition. You can see there's a little bit of a shadow line and trying to create a bit of depth on that facade. Elsewhere, this is the mass timber balcony. So there's been a lot of discussion about mass timber balconies recently. We kind of predate all that. What is happening here is that the balcony steel has an HSS stub out, and it's hanging off of the top of the column in sort of this hanger detail. There's a custom thermal break here, which is within the back pan of the curtain wall, and then the rest is kind of subframing for the balcony. So this is thanks to Façade, their structural drawing. And you can see here, as those are getting installed, as the structure climbs, they're located here, kind of tracing and showing where the balcony structure will be next. It was considered in design that thermal break would actually be the connection point where you'd bolt the balconies onto the building. But through kind of the mock-up process, it was decided that that was a little too risky. So a next level of construction break just outside of the envelope was introduced. It's also here, which gives a little bit of tolerance so that they're not installing balconies tight to it. And what you can actually see here on the building if you drive by, this is actually spandrel panel. So it's not going to be the final finish, but it traces the geometry. So that's sort of inboard of all the balconies. So this is sort of a few weeks ago where we were at, and you can start to see the expression of the building. But what I find really exciting is that the balconies are still yet to come. This is our architectural drawing here. Oops, sorry, I actually don't want to spotlight that. So what we were looking for is an exterior deck with the same elevation as the interior floor and sort of a flush threshold, and waterproofing in sort of a more typical way around the balcony support structure, the HSS. Is also important. We didn't want to move rainwater into the building. We didn't want to introduce rainwater leaders and things like that. So all the water on the balconies is treated sort of on its own. So they're treated as a series of roofs, and it will drain down through the balcony surface and then into the landscape. So the line of the building envelope is quite simple, actually. It's sealed at the curtain wall back pan here with a solid red line. There's a cladding panel that closes that off in the dash line. And then all water kind of moves on the balconies, and there's a little drainage gap between the two systems. It was really important when you kind of have these things that, from a design point of view, we need to align and have kind of complement each other as you work inside to out, from structure to curtain wall to balcony, that we had a really good digital coordination process. So a big shout out to George Third & Son, Kolesnikov, and Apex Structural, who are the detailed modelers. This is a fabrication model view. They're kind of the unsung heroes, the mass timber detailers. But what was really great is every kind of screw, bolt is pre-planned, pre-drilled, prefabricated, and clash detection way before we're on site, which was also really the case in facade tolerances and the layering of things. So just an image here, you can see this was submitted as part of the shop drawings from George Third & Sons. This is an axo of the balcony steel structure with all the parts labeled. What was really interesting is it was quite open-ended, actually, how the balcony structure would be kind of delivered and assembled. The trades elected to prefabricate the entire balcony structure. So the horizontals are all one piece. It's about 2 meters deep and 12 meters wide, with all the steel, including the CLT panels, shop fabricated and then brought to site and installed. The diagonals are all one piece as well. They're about 8 meters long because of the angle. And so the mock-up here in the photo below. Here we're in quite kind of traditional sealing around an HSS stub out. This is at the back pan, and here you can see kind of the first view of the mock-up on site with insulation and that bolted connection happening. So we're quite relieved, personally, to see that things are lining up well enough for now. As the first part, there's kind of 6 panels were installed to do a mock-ups to allow roofing, guard, cladding all to come. So this is a in-situ mock-up. This will stay in the building. And as you can see here, it's kind of that first entry to Keith Drive and Great Northern Way. You can kind of get a sense of the scale and the depth of the facade as it will carry on. So we're very thrilled to be this far, and we're heading into the rainy season, so fingers crossed. Oh.
We have 4 minutes. Can we have questions? Does that?
We can do that.
I do want to add a footnote. Our organic farmers decided not to move into the building, and some of you've probably read this already, but ICBC is moving in. I'm not saying anything. Your reaction was good. That was, questions? We have 3 minutes. No? Nobody's brave enough? Okay. Great. Well, thank you.
Come find us afterwards or shoot us an email. Happy to chat about it.
What I can say is that I've been driving by and I knew that there was more than met the eye, and I was really glad to see how the balconies are coming together and see the intricacy of all that. But it's going to look great. Thank you.
All right. Thank you.
Thanks.
So we are switching to a little bit more of a technical presentation. Our next presenter, Harold Louwerse, practice lead in Western Canada for Stantec. He's going to talk about energy code and window wall. Because his title is too long, I'm not saying it.
All right, is the microphone on? Okay. Good afternoon. Hope everybody's still awake. Otherwise, this will be a very boring presentation for those who are. A lot of echo. All right. So here today we're going to talk about a little bit of energy codes, a little bit of window wall, and some of the past presentations have teed this up nicely, and hopefully I can tee up some of the panel discussion later on this afternoon as well. So moving on. So we're going to cover off what is typically known as Canadian window wall. We'll look at some residential energy codes in brief, and then we will move to some of the architectural design implications that impact the building envelope. Cover off what the window wall systems look like today versus what they may have looked like, let's say, 20 years ago, and some of the implications of going down more of an unconventional road using window wall and some other products. So as was alluded to before, window wall, pretty straightforward. It's aluminum framing with factory installed glass, more of a modular type or prefabricated type of assembly. It's interior glazed, which is great for residential, keeps the cost down from a maintenance perspective. And as indicated previously as well, it's loaded on the slabs and anchored to the slab. So it's all captured within the structure. Whereas curtain wall is traditionally all outboard of those slab edges. And you have your choice also as to whether you want metal or glass spandrel panels for those opaque wall areas as well. This is one of the first tower projects I worked on almost 20 years ago now, and learned a lot about window wall. This is Seasons in Richmond. And yeah, still today looks good and is performing quite well. So conventional window wall is your typical 4.5-inch wide assembly, and as you see on the image on the left, that's what we're showing there, with a glass spandrel panel. In the middle is window wall with more of a metal panel as a spandrel covering the slab edge, the opaque areas, and then the image on the right is your higher performance window wall assembly. This image I've shamelessly borrowed from Starline Windows, who we use a lot. Most envelope consultants would be recommending their systems here in the Lower Mainland. It's not to say that there aren't others. There definitely are. This just happens to be the image I chose because it's nicely showing the differences. Design process. So very high level. The developer, the owner, they have a dream, right? The architect then takes it a little further, adds their vision, and puts together a design. Then we start getting into the nitty-gritty, the preliminary energy models. Some of the envelope assemblies are put together, and we do more of a schematic design review, right? Then we start playing around with window to wall ratios, and we start finding that maybe the performance of the building isn't quite going to work the way we wanted it to, right? And so we start playing around with the design a little bit, adjusting things to make the thermals work, right? And this is a struggle that I think, well, maybe hands up those developers in the room, who's struggling with choose your own adventure energy models? Anybody? Yeah, there's a few, right? So there's a lot of different ways to go about putting together a building envelope and an energy model, right? And because we're working with performance-based codes now, it's not as prescriptive as it used to be, right? And I think that can frustrate people, but it also creates flexibility, and it's just knowing where to pull and where to push. So as we move through this, obviously architectural revisions, we move through the rest of the design process. And then, as we hit design development and we start to put together cost budgets, we start to realize, oh, this is going to be expensive, right? And so, we continue to move through it, and there might be some value engineering that happens, some trade-offs and things like that. So a bit of a case study. I don't have any photos of what this building looks like apart from this image and maybe one other. Still in design, technically. It hasn't moved into construction. So it's a 3-tower, 17-story residential project in Richmond, BC. Richmond, BC says thou shalt meet step code level 3 or step code level 2 with a low carbon energy system. So according to that means you have a TEDI target of 45. And understandably, different buildings, different typologies, they have different TEDI targets. For residential, this is what you need to meet in Richmond. So we started working with the architects back in 2021. That's the middle of COVID, right? And cost escalation on materials and things like that happened as well. So it's been challenging, and kind of show you the process that we've gone through. So the initial design, we started with this high performance window wall assembly, the 6-inch version, knowing that just given the schematic design that we had, it was fairly articulated, lots of balconies, lots of ins, lots of outs, and a lot of balcony length as well. So we knew up front we would probably need a high performance system to get there. This obviously created that maximum design flexibility, and it also increased the cost. And that's maybe how we ended up where we are today. But we'll get there. So this is that 6-inch system on the right. So just shows you the anchoring, how it sits on the slab, and how that slab edge is quite insulated, which is a good thing from a building envelope perspective. So obviously we moved into more of the value engineering process, right? It was confirmed it was too much cost for that 6-inch system. So what other options do we have? Different architectural design, right? Are we going to play around with the architecture? Maybe we look at a different window wall manufacturer. Do we go with a different glazing system, or do we take more of a hybrid approach, or pull aspects from all three? Choose all of the above. So we started evaluating insulating with other materials. Obviously, trying to keep the cost down. And someone asked the question, well, do we want to put mineral wool on the inside of your metal back pans? And the answer is no, you don't, because now you're moving the dew point within that spandrel assembly, you're moving it to the inside of that panel, and now you're at risk for condensation on those really cold days. Especially in a residential building where humidity inside the suites can be elevated, not something we want to do. Not mineral wool is not the answer. Next option, spray polyurethane foam on the backside of those spandrel panels. Good option. it's step code, so there's also an air tightness test that we have to consider. Adding air vapor barrier to the inside of a prefab modular system sounds good, right? It's going to be all the things we're looking for. Questionably sustainable recyclability of the product comes up, right? We don't necessarily want to use this product if we can help it. Spray foam has also come a long way in the last 10 to 15 years as well as more of a sustainable option, but still not the first choice. Option C, as alluded to previously, so we can also look at reducing the window to wall ratio. So this is playing around with the architecture, adding more spandrel areas, reducing balcony lengths along the facade, reducing the points where it comes through, maybe creating points. Maybe it's a different material, right? Maybe it's not a concrete balcony, maybe it's a prefab modular bolt-on type of assembly. So these are all the options that we try to bring and have discussions with the owner, the structural engineer, and what have you. So the building envelope, this is all from the thermal bridging guide. I want to highlight these numbers here. So a conventional window wall without spray foam, roughly, and every manufacturer is going to vary a little bit. So no spray foam, R7.1. That's your effective clear wall R value. So that's not factoring in any thermal bridging from the architectural components. It's just your basic wall assembly. Versus with spray foam, you're almost at R10. So there's quite a jump in performance when you add, let's say 2 inches. That's actually what's modeled here is 2 inches of spray foam on the backside. So sounding pretty good, right? That's what it will look like. So they build a little furring wall on the inside, and you get, continuous insulation up against the backside of the window wall system. So it's been done on numerous projects in the past. In this case, that's what it looks like in section, right, in plan view, sorry. And so impervious to air, impervious to vapor, it's airtight. We're only going to enhance the performance by doing this. That's what the thermal bridging guide will show you if you look this up, thermalenvelope.ca. The challenge is you've now added a combustible material to the backside of your assembly. And within the code, there are mechanisms that indicate now you need to have an S134 test. So by doing that, you need to, in order to pass the test and for it to work on your project, you need to basically put on what was tested. So you can't change the spray foam manufacturer, you can't change the configuration. It all needs to follow the exact test in order to be code compliant. So some of my colleagues out east have witnessed this test down in Texas at Intertex Lab, and the assembly passed the test. But again, it's a costly endeavor. These tests, run over $100,000, and they have to fit you in on the schedule. It's not something you can just, say, oh, well, let's go get the test done, right? There's some planning that happens ahead of allowing it on the project. So the manufacturer that we had slated had this testing. We were good, and still all systems go. The challenge we found with cost escalation is the project became essentially not viable using that manufacturer with the spray foam. And so now we've started exploring other options, which is where we get into that offshore curtain wall, window wall manufacturing discussion, which I won't steal their thunder for. But that's a reality where developers are looking offshore to still meet the requirements of the project. So in this case, they're looking at an offshore window wall manufacturer, 6-inch wide system, and they're looking to make some modifications. They're insulating their thermal breaks. They're looking at having back pans that stick out past the interior framing, so you're increasing the depth of the insulation. And it's just packaging at the end of the day and how these things are shipped to site. So it can be done. It just requires some tweaks and changes to those assemblies. At the end of the day, we know a window wall system like the 9,000 Starline system, the 4.5-inch system, we know that product can work on a step code 4 building. The challenge is you can't have balconies. You can't have an articulated facade. It's a box, basically, right? So as soon as you start adding all of these additional things, like balconies, lots of vision glazing, right? You're reducing the overall envelope performance. And obviously, we're talking about a residential window product. People need balconies. People want vision glass, right? These are our homes, right? So it's knowing that that product has a limitation, right? The 4.5-inch window wall. And so we need to explore what other options are there. And does that mean we need to move to call it the Cadillac system, the high performance system? More than likely, yes. But then how does the architecture work, right? And how can we simplify those details where the performance is going to be impacted in a negative way, and how can we still make it work? So, and then it's also looking at the rest of the systems, insulation on the roof, HRVs, all the rest. So mechanical, electrical, you name it. Just as a comparison, there's some talk about stick-built versus, sorry, not stick-built, built-in-place walls versus modular walls. Here's two towers from a different developer. One is in design, the other one is already built. The one on the left is the one that's already built, and that's all built-in-place metal panel. So they had scaffold, they had swing stages, and they hand installed all these metal panels on a 4-inch thick insulated assembly. If you look at I'm going to try spotlight this here. Oh, it's failed me. There we go. Okay, so you look at these numbers here at the top. So R6.7, that's your clear field R value. If you look at the percentages, there's not a lot of spandrel bypass. The majority of the insulation from an opaque wall area is the 84%, which is the exterior insulated wall. So that's where they've invested their money. And arguably, they have a higher clear field wall R value. Comparatively, on the right, they have a much lower value, but a lot of the emphasis is in the window wall. So sorry, I should have said that. The one on the right is a window wall wrap. So there's no metal panels. It's all integrated within the window wall assembly itself. So it's one manufacturer bringing a product to site and installing. Whereas the one on the left there's a window wall trade, there's a metal panel trade, and there's a lot more labor going into that installation. So the other big difference is the window to wall ratio. So the one on the left, much higher value, 48%. One on the right, 30%. So it's a big difference there. U-value glazing as well. There's a big number difference there. So they've invested in a higher performance unit on the left. So there's a much better R value or U value coming out of the glass for those. Effectively, all the other numbers are the same, and they're both meeting the same step code 3 values. And in these cases, they're both using your conventional 4.5-inch window wall system. So it can be done. The architecture is what's driving the bus, and that's really what I want to communicate today. Is we need to work collectively as a team, and a lot of that starts at upfront design, so that we have a clear path from the get-go, and that can be done with the energy modeler, the envelope consultant, informing the effective R values at the end of the day, and then sorting out the details. So the future, how do we keep our current technologies how are they still viable? Or are we mothballing those, and are we moving to those higher performance systems? Brian touched on this earlier, right? With parametric modeling, we can predict some of these things at the early stages of design, knowing rough geometries and impacts, what have you. The vertical surface area to floor area, or VFAR, that's important, right? Again, it's the articulation of the facade, and obviously keeping it as simple as possible is the easiest way to achieve your thermal targets, which can frustrate people at times when, especially architects, I would think, right? There's a certain expression you're trying to go for, and then the envelope consultant or the energy modeler is saying, no, we need to simplify it, right? Reduce some of the ins and outs to make this work. I asked AI to show me a Canadian window wall with spray foam. This is what I got. I added the teddy for fun. So AI, it can do the trick for some things, and this is one way to generate images. There's others. Brian had showed that. It can do some pretty cool things. Right now, we're still not at the point where an architect comes to us with a design and we can say, oh, let's just throw it into AI and here's what you need to do. We're not quite there yet. So it's just a bit of humor there. Spoiler alert. Okay, with choosing your own adventure energy models in order to meet your TEDI targets, try to anticipate that value engineering. It's going to happen, right? Especially if there's a long drawn out design process, there's going to be some manipulation or changes to either the design or the materials and perhaps methods of installation that may impact how we get there. Try to avoid limiting yourself. So the lesson I learned was by putting spray foam on the back side of the window wall for this particular case study, we limited ourselves with the system that we could go with. And so the developer had to then look around and say, well, what else can we do? Maybe we need to consider offshore window wall as an alternative. In that case, they ended up coming back to a 6-inch wide system, and they're currently in the process of evaluating that for that project. So spray foam arguably still can work, but you definitely are limiting yourself to one manufacturer or maybe two or perhaps three. Explaining the risks. So just understanding, there's an implication of additional testing, of fire. What does that mean for the occupants? And it's just there's a bit of an education piece there. So hopefully this is part of that, and you have a better understanding as to maybe why you don't want to go down that road to begin with. KISS, keep it simple. The simpler the architecture, the easier it is to meet those energy models. Otherwise, you're going to be showing me the money, or maybe not me, but the people supplying these products. You'll be paying for it. And AI can't save you, not yet anyway. So we'll get there, hopefully. All right, I've been meeting Teddy since at least 1992. So thank you very much, and have a good day.
Thank you, Harold. Yeah, no, you shouldn't ask AI anything of the like. Now I will be thinking about a teddy all afternoon and sitting in front of a window, probably warmer than I am right now. The last talk of this afternoon session before the break is Alexandra Mirilenko. He's the general manager at U-Kon Façade Systems. He's going to be talking about parametric architecture, integrating 3D curved aluminum panels with thermally broken systems.
Thank you. We had the first time today here in Zak. Thank you. It's a lot of pleasure to be here. We are like a new company here, and I'm gonna a little bit introduce what we're doing so that you can get like a general concept what
we are doing in general. So the U-Kon facade system, it's engineering company and design. So we design and ventilated facade systems made from aluminum or stainless steel. So with years of the experience in domestic market on the abroad, we developed a lot of solution to attach any type of the cladding that available on the market. Together with like cladding manufacturers, installers, the architect that give us the challenges. So we always try to design the new system, new approach, how to make it solution easier and thermal performance and better like seats fit on the building. We've been in the market since 1997. We have more than 20 pre-engineered solutions, so it's very easy to the architect pick any one that you want. We have a local production facility here in Canada and local stock. And also we have like our own design bureau. So our own design bureau, we help to the architect and developer on the beginning stage on the concept design. So how to better design the building with different cladding systems and how to implement it. Also, we can also provide the service to installers, like shop drawings, training, site supervision, etc. As I said, like we have a lot of different solutions. So like, doesn't work. Okay. Different solution that can you implement like stone, fiber cement panel, ceramic panel, brick, metal panel, etc. Even GFRC panel. All of the subframe system on the market has like all main components that we use in. First of all, it's thermally broken wall brackets that basically connect our cladding to the building, right? And the thermal breaks reducing thermal bridging effect on the building. Another main component is the vertical rails that we needed to accommodate the design what we want, depending on the different condition, seismic, wind loads, dead loads, etc. And some small elements that we needed to attach some cladding. So I decided to start talking a little bit the architectural trends that we have right now. Most of the time, this is what's common, like we can see right now in the architectural design, which brings some challenges that I can explain later. So some like geometry pattern, like a column beams on the building that you can see is like sitting offset from the main structure so far away that is going to be very complicated to design. Another one that we can see, it's large format perforated metal panels, very common, everybody trying to implement. You can implement the perforated metal panels as a main structure of the cladding, or it can be a secondary structure of the cladding. It can be, you can perforate it any pattern, texture, wherever you want. Another type of the system, like trends that I can see, but I have no idea how it's called. Like that sloped panel at every window. Every single right now building probably using it. That create like a depth sloped, because that kind of structure, you can change the different colors, even using the same materials. Also like curved panels. Curved panels getting more and more popular, like wavy structure. You can have like moving buildings, right? So some of that structure you can do with the metal panels very easily. And one of the like kind of solution to do that, it's using like aluminum panels for several reasons. Like it's flexible fabrication. You can bend it, break it, whatever you want. The second thing, it's very light. And the third, I think, is maybe most important, like it's non-combustible, right? So it's very important for like structure building outside so that we can prevent all the fires. In our portfolio, we have a system that uses like hooks, we call like hooks, and the integrated like sliding bar that attach the metal panel inside of that system. It provides a lot of flexibility, and I can give you like some different look. For example, let's say that perforated metal panels. It can be bent, perforated, etc., any shape. But the problem is, it's structure. So when you start perforated the panels, it loses the structure itself. So you need to reinforce the panel. So that solution can be installed behind. So all this panel reinforced from the inside. So you cannot see that reinforcement, but it's doing like structural thing. Another thing you can do like using the same solution, but using three-dimensional panels, like bend it any shape you want. It can be integrated and like added as a part of the building separately or like design the entire building using like three-dimensional prism shape of the panel. Also very common, the corrugated panels, right? We like it. Every single building has corrugated. But let's bend them. Let's bend them like that, or like different shapes. So that is gonna be give you another look of the building, right? Or like that's convenient, like traditional cornices. The same thing. You can bend the cornice, any shape, and utilize the same solution that will provide a very flexible design. But all of that, it's create like a lot of challenges. All of that structures, like we're moving outside of the main wall, right? So sometimes it's gonna be like half a meter away from the structure. So, and this creates a lot of stress on the fasteners. Most our building is made from what, like concrete slabs, right? And the steel stud. The steel stud, they try to make it cheaper, like easier, 20 gauge, 18 gauge. So can you imagine that if you're gonna start extend it out, there's gonna be a lot of stress of the anchors, screws, etc. So there's no way that you're gonna be attaching that structure to the steel stud. So now you have to think, okay, like we need like HSS, we need the concrete, what we're gonna do, it's driving cost up, but this should be like something better solution, right? So we have to find something. And we have it. So the solution that we use it a lot, it's we call like a slab-to-slab system. So basically, they have a lot of benefits. So we attach the bracket directly to the slab. We have a different size of the bracket and shapes. That system has a lot of benefits. First of all, like reducing the thermal bridging effect. So it's only 2 brackets per floor, not like a lot of on the steel studs. The second one, we use a reliable connection that we attach and everything to the concrete. Just imagine, like right now, if you're gonna install like anything to the steel stud, it's 1 millimeter steel holding the entire cladding for what, 50 years? Just think about it. And then also, because of that flexibility, you can accommodate any layout you want. So let's just want to be quickly show you some examples. This is simple building, looks like. But as we say, like, you know, like we can find like all the interesting details inside. That curved like panel, triangle, they kind of created like something like very unique shape of the building right away. And looks simple, right? But let's say we need to implement 200 millimeter of insulation. So what happened? On the lowest point, we have offset of the metal panel about like a 400 millimeter. But on the longer points, it's about like 700 millimeter offset on the main structure. What we're gonna do? So to install that, so we need to make sure that we have like less penetration on the insulation. And then one of the most common solution in this case that we can see, people using HSS structures, like welding, fabricated. That HSS structure has a lot of disadvantages. First of all, it's weight. The second one, you need the separate fabricator who is going to be perform, and also has to know what to do. And another one, if you do an HSS, you need to do like a lot of like, after that, when you welded the structure, you have to like pre-paint, make sure that it's corrosion resistance, and every single time when you're gonna attach everything to the structure, you need to make sure that you sealed all the holes. With the solution that we have, like a slab to slab, in this case, we installed the bracket every 4 meters away, and we installed everywhere where we need it. So we, I don't know how it works. So we put like a bracket close to the main structure on the pin, and also on the side, so where it needed to secure the panel in place. Also, because it's very large offset, when we design like that building, we have to think about the seismic, because the seismic the building starts shaking, so you have to integrate a lot of additional like horizontal bracing to reduce that horizontal shakes. And this is very common, the solution that we always use in the
structure like that. The same if you want to do like opposite angle inside. And we can do like the same thing. I just want to also add a couple more because when I start thinking about this presentation, then we came across that a lot of projects right now, we get in a lot of old building existing in Canada that built in 60s and 70s, right? Now we also have like challenging to retrofit. I just want to like show you something like a couple of pictures, like one of the job in Toronto where we also using like metal panels and with retrofit. So where you cannot install the metal panels, like you cannot touch the existing brick because it's falling apart, and you cannot, but at the same time you need to make it very energy efficient. So we use like also the same slab to slab system where we install in the wall brackets about like 32 inches apart horizontally and every floor. So in this case, installer can install like properly all the subframe system without interrupted the old structure. And maybe the last one as an example of how we can design that and implement the system. So for example, we have a project where the architect wanted to make the wall bigger. So, and he was planning to use a traditional method using like a wood, steel stud, and something like that on top of the concrete wall. We said, why are you doing that? You're just using that material that's gonna be like corrode or over the years, like it's like gonna be dismantled, and how you can be doing that? We said like we have like a wall brackets that can be extended like 24 inches, and we can build it up this wall directly to the good brick concrete structure and fix all that metal panels like that. It's project in Surrey. And this is basically the main subframe system that is going to be like 16 inches offset from the wall. And even we build like parapet using like a thermally broken to create like a structure. So that's it, because I'll try to make it fast because I know that you guys are already tired. It will be a long day. So if you have any question, like I can answer. No? It's good. Yes? Any type of the finish you can do, like PVDF, I guess. We are not producing the aluminum panels. We are kind of created a subframe system. If we have a two style of the brackets, like one of that is stainless steel that we use for like passive house buildings, and we have also like aluminum brackets as well. Yes. Yes. So again, like we do like a fire test. We believe like we have to do like every floor also like a fire block using like insulation with like metal structure behind, so that there's no like chimney effect inside of the wall, because you have that big gap if you design like a beefy structure of the architectural elements on the wall anyway. But you can do it like with like using the lighter materials, more flexible, that installer can adjust it, or you can use like HSS. Yeah. And we have like some details how you can implement that fire stopping on the, let's say, every floor around the windows, because basically all the fires happen from the inside of the building and transfer it up in between the floors. Yeah. Thank you. Thanks.
But we have about 30 minutes of networking. And I would like to call back the presenter of the session that just finished, so we can take a photo and give you your plaques.
Is Brian Hubbs in the house? Any speakers who haven't come up yet, who have already been on, please come up to the stage. Thank you.
And as a user, you are instantly immersed in a true 3D environment that creates an incredible sense of scale and depth. Avalon is a collaborative working tool, offering a joint experience between architect, contractors, investors, engineers, fabricators, and Rayner's experts. Virtual reality is set to play an important role at all stages of the architectural process, from evaluating design options and showcasing proposals to detecting construction issues before breaking ground on site. Avalon allows you to explore your projects inside your usual design software, from initial sketches through detailed technical models and realistic scenes. Discover Avalon, the space where future projects become a reality.
So I'm inviting everybody back in. Take your seat. It's the last stretch of the day. So you need to kind of gather your energy, be awake, and listen to the next presentation because it's going to be very interesting. Please take your seat. So next, we have two presenters from HCMA. Alexandra, Kenyon, and Maeve Counihan are going to be talking about the Thomas Hout Aquatic and Community Center, a holistic approach to sustainability. So I invite them on the stage.
How are our mics? Good? Okay. Hello. Maybe let's move slightly this way. Good afternoon. Thank you all for being here. Maeve and I are really pleased to be here with you. It only took a little bit of persuasion by the team to get us up on stage, but we're here and we're excited about it. So we're looking forward to speaking with you about a project that we've recently completed. Before we get going, I like to acknowledge the lands that we're gathered on. We talk about this regularly, but of course these are the unceded territories of the Musqueam, Squamish, and Tsleil-Waututh people who have stewarded these lands for time immemorial. And I'd also like to recognize the Kakite Nation, whose land the project that we'll be speaking about today is situated. Through this project, we've had the opportunity to collaborate with an artist, a Squamish Nation artist named James Harry, and that's led to tons of learnings for us. One of them that I'll share is that we as humans are not separate from the land, we're part of it, and that applies to our work as well. I think that's especially pertinent to architectural work and planning work, and so just leave you with that kind of learning from Indigenous communities today. I'm Ali Kenyon. I'm an associate principal at HCMA, and this is my colleague Maeve Counihan, architect. We are very privileged to work in community and recreation projects. And the work that we do is really at the intersection of community and the built environment. So yes, we're architects, but we're working on projects that are across the kind of spectrum of what that means. We're working across 4 offices in Canada, some bigger, some smaller, but doing work across the country and then a little bit into international places as well. When we're doing this work for communities, we are constantly asking ourselves, who are we designing for? Who is this project for? And that's a little bit different, of course, from designing, for a single family home or for a single business owner. We are designing for a community that is multivaried, multi-layered, and inherently complex. And so, we're thinking about this in lots of different ways, but one of the ways that we try to capture this, and maybe you can make the video play? No? Anyways, we've been doing a series of videos with a local filmmaker called Inder Nirwan, who has basically gone back to many of our existing buildings, many of the buildings that we've been involved in the design for, and captured stories of kind of resilience and the thriving kind of qualities of those places. So they're stories, and it's too bad that it's not playing, but they're stories of people who have experienced loss or who have developed friendships that have become really, really important in their lives. And those friendships have come out of programs in the buildings that we've designed. So this is really one way that we go back into the places that we've worked on, into the communities that we've been involved with, to understand who it is that we're designing for. So we'll talk about the Thomas Out Aquatic and Community Centre, which is a brand new facility out in New Westminster. We've been working as HCMA, we've been working on this project for about 8 years, maybe almost 9. So it might not surprise you to see that there's this extensive list of credits. This is just the architectural team in our office across that time span. Of course, we're also collaborating with many of you in the room, actually, engineers and building envelope professionals and builders. But what I want to say here is that the architecture that we do is really a team sport. We are firm believers in collaboration and being able to work with diverse teams who have different points of view, different lived experience, different disciplines and expertise, and that's really a kind of foundational aspect to our work.
Thank you, Ali. So pools have historically been some of the most energy-intensive building typologies. They're typically dictated by really rigid constraints and requirements. This has sometimes led to spaces that prioritize utility over the user experience. The previous Canada Games pool in New Westminster was one such building, which this building was really beloved and really well used and a really great asset to the community. But architecturally, it did err on the side of function. So when we started thinking about the redesign or the design of the replacement facility, we really wanted to work with a more diverse set of performance requirements to give an overall more holistic user experience. So what do we mean by holistic? For us, a holistic building is one that balances the environmental performance with the social performance. It's a design that's dictated first and foremost by the needs of the community, and it aims to remove all barriers to access. We believe that this results in an elevated experience for all members of the community, but it doesn't compromise on the programmatic functionality that the Canada Games pool had. The Thomas Out Aquatic and Community Centre is the first completed aquatic centre in Canada to achieve the Zero Carbon Building Design Standard. It's an all-electric building, it's Rick Hansen Foundation Gold certified, and it's pursuing LEED Gold. But more than that, the site's quickly becoming kind of a centre in the community. The building's made a civic statement, but it's not ignored the natural environment or the human scale experience.
The city of New Westminster is a relatively small city on the banks of the Fraser River, which have been, a cultural and economic life source for thousands of years. And it's a small city with, I would say, super high aspirations. It punches above its weight in a lot of ways. So I really want to credit the city of New Westminster for their vision on this project. It's been significant. The site that we were working on is at the uppermost kind of headwaters of the Glenbrook Ravine, which is identified there in green. And that site was paved over in the 1960s as part of a civil infrastructure project to put a new sewer line down the middle of the ravine. And so that became a real driver for us, this idea that the ravine was erased on this site and how that relates to colonialism. That became a real driver for us. How could this idea of kind of replacing what was lost as a gift back to the community become really generative? The site is extremely constrained with 2 existing buildings, the Canada Games Pool and the Centennial Community Centre on the site, dashed in grey there, that needed to remain operational while the building was being constructed. The red dashed line represents this sewer line that's cutting diagonally across the site that we couldn't load or build within 3 meters of. The scale of the building is quite massive, almost a block long, cutting diagonally across. And so that really behooved us to search for ways to reduce the scale, how to make the building approachable and humanized and feel like it's part of the landscape. So we studied this in a lot of different ways, with Fastenep, our structural engineer, with Metro Van, trying to understand the relationship with that sewer line underground. And you can really see through these kind of massing studies, the site specificity of the project. Like, this would never be built anywhere else. It is sitting in a puzzle piece of a remaining site and really studying how to be reduced in size. Through environmental, through energy modeling and daylighting studies, we found that there was a real advantage to rotating the building on the site. The grid in New Westminster is at a 45-degree angle. If you've ever worked out there, you kind of understand what that means for site orientation. But by rotating the building on the site, we oriented almost all of the windows north or south, which had real benefits from an energy perspective as well as from a user experience perspective. The roof itself is varied. So each roof form that you see in the diagram there is responding to specific programmatic needs underneath it. And then it's being unified by a kind of singular facial line that breaks at one key point, which is the primary entrance, the primary lobby space. The plan is oriented around a central lobby space that's accessed either from a north plaza or from a south plaza. And then that lobby space that Maeve will talk about in a little bit more detail in a few slides is a place that provides you access to either the community center or the aquatic center. The second floor contains fitness programs as well as administrative offices.
We often think about high-performance buildings purely in terms of the data that they output, but unless those energy savings and environmental performance is brought back to the personal, then it's too removed from the user experience. On the other hand, buildings that we consider to be highly experiential are often thought of only in terms of their dramatic architectural environments, and they can deprioritize the environmental performance. But we're wondering, why can't these two coexist or even reinforce each other? The central lobby at Thomas Out serves as the main arrival experience. It's envisioned as the social heart of the community, and we really needed it to be very warm and welcoming and inviting. It's the most special space in the facility. We looked for different opportunities to create delight here in a way that's different to other parts of the building. The roof is made of heavy glulam beams, and it supports a skylight that runs the length of the lobby that illuminates the space and draws people in. There's a sculptural spiral stairs anchoring the space and providing an opportunity for play below its soffit. At either end, there's large accordion glass doors, and they connect the lobby to the plazas on the north and south. Swimming's a unique human experience. It's typically the closest we get to being unclothed in public. This heightens our senses and our reactions to wind and temperature and light. An aesthetically cold space will often feel cold, but by introducing some warm organic materials like this CLT roof, you can dramatically change people's physiological comfort. The glazing approach here allows for the full impact of that CLT roof. It also connects swimmers to the outdoors and to the parklands beyond, as well as connecting them to place through the use of local materials. In order to maximize that indoor-outdoor approach, it was important to us that the roof was seen to extend beyond the building envelope. And in order to achieve that, we needed to introduce a thermal break above the glazing header. Wood is an organic and resilient material that actually works really well in a pool environment. The wood here is treated for indoor and outdoor climates, but it's flexible enough to breathe with the fluctuations of those temperatures. Like DIALOG and the Hive, we also worked with Kalashnikov. They're a vertically integrated a mass timber producer. They're located in the Kootenays, and that helped to reduce our embodied carbon. While we can thermally break the structure, the glazing needs to be able to deal with two varying temperatures for the majority of the year. And in this case, how we achieved these large expanses of glass was by washing the glazing with air coming from diffusers in the ceiling, but also upwards from plenums that we cast into the concrete slab. Ali spoke about orientating the building in a north-south direction, and while the leisure pool is flooded with warm south light, clear stories in the 50-metre lap pool provide a more diffused north light for the swimmers and the lifeguards in there. The glazing at the clear stories is triple glazed, so we didn't need to wash that with air. There's access catwalks at every single clear story. And not only did those allow us a place to mount indirect lighting, but they also provide a space for maintenance staff to clean the glass, maintain the lights, and clean out the gutters. The catwalks are accessed through roof-level doors that come through from a mechanical space onto every clear story. In any mixed-use aquatic facility, there's going to be two building envelopes. And the first is going to be your typical building envelope between indoor and outdoor, but a second separation is required to keep the corrosive pool air away from the dry areas. In this location, there's a membrane at the ceiling level, and that forms part of that second separation, and it separates the corrosion and the chlorinated air in the lap pool from the structural steel framing supporting the roof above. I should also say that in this space, along the right of that image, you can see a glass wall. That is a thermal separation, and that's separating the lap pool from the leisure pool, and that allows them to operate at different temperatures. The black metal panel ceiling here provides contrast for the swimmers and heightens their experience of the wood above. It emphasizes the light and the texture and the depth of the wood material in comparison to the metal panel. We like to think that it feels like massive wood panels floating above the pool or a Venetian blind of massive scale.
So beyond thermal comfort and daylighting that Maeve's talked about in a lot of detail, this project has also had really high aspirations for water and air quality. That comes from public engagement, where we hear, like, time and time again, can we have a pool with no chlorine? And the answer is no. Local regulation requires chlorine, and that as a disinfection method. But we really dug into that, pushed into that on this project, and worked with a Scandinavian pool filtration and disinfection system. So this is the first installation in North America of this filtration type. And it does a whole bunch of things that we won't go into in too much detail, but the big idea is to remove particles earlier in the disinfection process, so those don't get into the rest of the system, they don't get into the air, which causes all kinds of breathing and irritation problems. So, you know, this highly technical thing that is delivering energy and improved, water has a real impact on the user experience itself. And anyone who's either been, in a lifeguarding kind of position or spends a lot of time in a pool knows what that feels like. So we're really proud of that innovation. So many strategies on the kind of environmental performance side of things that we think have a real impact on the way that users experience the pool. But it also really drove part of the city's kind of higher level planning. So while we're working on the project around DD stage, the city of New Westminster declared a climate emergency and started to articulate their own goals for a carbon and greenhouse gas reduction. So 2030 at 45% is their first goal. And we quite quickly realized that the Canada Games pool was the largest emitter in their whole portfolio. So that's the project that we were replacing. So 22% of their corporate emissions were coming from that one building. So the Thomas Out Aquatic and Community Centre is listed on the bottom here. It's more than twice the size of the Canada Games pool, uses less than half the energy, and emits a fraction of the GHGs. Through the design of the project, we also implemented a photovoltaic array on the rooftop, which produces about 5% of the annual operating energy, effectively, reducing, eliminating that bit of GHG that comes from our hydroelectric grid here in BC. So effectively, by taking the Canada Games pool offline and replacing it with an aquatic centre that's near zero or zero, they've gone about halfway to their 2030 goal with this singular project. So that's a real point of pride for the City of New Westminster, and depending on your interest level in sustainability, that's a real point of pride for the residents as well. So what does holistic sustainability feel like? it feels like a lovely building. It feels like a nice place to be. And depending on the community members' interest, their point of view, their lived experience, it will resonate with them differently. Some members of the community are so passionate about the elevated experience, how it feels like an equinox, but it's a community center. Others are so proud of the fact that it has achieved these environmental performance standards that are quite exceptional for the building type that it is. And others, they know nothing about it. They're just enjoying the place that is newly come to them and wowing at the fact that the landscapes are thriving in a Jurassic Park kind of way. But we are really proud of it, and the accolades that come all feel good after you've been working on a project for a really long time, but the ones that feel the best are the ones that come directly from the community. So this letter recently from a community member, a letter to their local newspaper talking about how the building had raised the bar and how we had really listened in community engagement because this, and this, those feel really good. When we know that the community has really embraced the project that we've been working on and thinking about them so hard for such a long time. So we're really proud of it. We hope that you'll go out there and check it out. It's not that far. And for anyone who was hoping that we were going to talk about the white precast panel on the outside, we don't have time for that. You can come talk to us later. Thank you for your time. Guess we can leave us there. Okay. Where's the mic?
Well, you almost took me off guard. I was going to listen to you a little while longer. It's a very interesting project. Next, are we bringing the chairs in and everything this time around? So I'm not going to introduce the panel and just stand there and wait. And by the way, I should have found a joke to tell because I needed one again. But I didn't. Sorry. Oh, okay. Let's see in the room how many architects we have. By a show of a hand. Okay. Engineers? Way less. Authorities having jurisdiction. It would have been good to listen to the panel this morning. But who am I forgetting? Oh, the products. We know we have like manufacturers outside. And how many of you are in the room now? Or everybody's tending their desk outside. Eh? Okay, it's coming in. I'll get out of the way. And that is the last panel before the day is over. So we're almost there. They seem cozy, but I always think that sitting on a chair like this in front of everybody is kind of odd. Sorry, guys. So we're missing one chair, 2 chairs. So we have a bit of a larger panel for this second panel. We have 4 panelists, and the moderator will be Zak Marasse. He's a partner and president of Glass 3 Enterprise. And since we're still waiting for some chairs to be installed, I'm going to introduce the name of the panelists as well. We will have Joel Schwartz, principal at JRS Engineering. We have Rodel Sebastian, project manager at Elliston. James Sergeev, CEO principal at Cyber Façade Group. And Mike Worm, director construction at Celtic Development. And they're going to be talking to us about best practices for overseas procurement of materials and systems. Please come on stage, guys.
I guess I'll sit there, I guess. Thank you for staying, those of you who are still here. We're separated. An interesting topic, probably half the room opposed, half the room for, and some in the middle. We have a great panel throughout the supply chain. We have development, engineering, facade, and project management. So we'll jump right into it, and for all this production, the guys better do a good job. It was spoke many times today about some options on why overseas procurement is happening. But Mike, I'm going to ask you, in your experience and what you're dealing with today, why is it becoming more prevalent?
Hello, can you all hear me? Yeah. Well, Harold hit the nail right on the head when he had his AVE comments up there. It's always expect value engineering, and as we've all experienced over the last 5 years with the cost increases and the inflation that's going on, and just the overall costs associated, the increasing costs associated with bringing a successful project to the market, really people have to look at all portions of your supply chain across the project and through all divisions to see where you can look to save a few dollars. And on a large project, we're not talking about a small, on a construction project with, let's say, $130, $140 million budget, the savings on a window system from overseas are quite considerable.
Quite considerable being a nickel, a dime?
Lots of dimes. Yeah, no, lots of dimes. And it's in the instance of our most recent one, we saved approximately, I would say, around approximately 20%.
So how does that tie into, from your perspective, and I'll bring Joel into the conversation, are we thinking about this at the beginning and all the way through the schedule and the time lapse that goes through? So if you're considering going overseas, what exactly goes through that frame of mind?
On our most recent project, it was something that was directed right at the very outset of the project. Our ownership took a strong view that something that we wanted to do. Construction materials are now being manufactured across the planet, and looking at the packaging in the garbage bin of a construction project, you're going to have products from all over the planet. And even here in Vancouver, I started 32 years ago, and the very few of the products are coming from Vancouver. A lot of them are coming from the States. A lot of them are coming from Eastern Canada, Europe, and now, especially with our position on the Pacific Rim, there's all sorts of things coming from Asia. So we initially identified that as something we would want to do earlier in the outset of the project.
I'm just going to ask you a question. In your experience today versus, let's say, 5 years ago, do you feel that there's a switch in the industry, whereas before supplier-driven overseas versus now development-driven going overseas?
I think a lot of it has been developer-driven at this point in time. It's certainly on a lot of the more sort of the more noteworthy projects, some of the bigger projects you've seen, that's certainly been the direction of the developer.
And Joel, in this situation, how are you controlling QA, QC, or the key items that are important to you if you're in a project that is going overseas?
Well, I wouldn't say we're controlling it, but it's one of the first things we put forward. It's the first question is how is quality being addressed? What are the standards of the system? What testing has been done? How familiar is the supplier, the people who are producing it, delivering it, with the local requirements? There's a wide range of answers. Some are much less familiar than they really need to be, but we ask the questions up front. So to your earlier question on timing, the earliest opportunity is critical because in many cases, the systems that are being delivered, I'm going to say, are bespoke. They're not like, they may be mass-produced systems, but they tend to have new dies, new extrusions for a lot of the products. So you can't rely on past performance, past products or projects, sorry. So you have to really start the whole testing evaluation system every time from scratch. So if it happens too late, if it starts too late, you're really under the gun to get all those boxes checked.
And what's the receptiveness of that in actuality throughout the projects? Like, do you find that it is happening at the beginning in the conversation, or is it kind of, we're getting there over time?
I would say over the last years, over the last 10 years, 20 years, it's gotten a lot better. The receptiveness, again, I think there's a greater awareness. I think they're were some past problems that the industry learned from and became aware of. And I think in general, there's a heightened state of awareness. So people are more receptive. But that is the challenge. People want to believe it's going to be a good system. I want to believe it's going to be a good system. But you still have to verify it. You have to go through the steps. And the images up on the board, I think those were the ones we went through, Mike. Yeah. So that was the performance mock-up overseas. And even just agreeing on all of the details that would actually go into the performance mock-up before we even got to the testing took weeks, months to get to.
So there's a few slides here regarding the QA/QC, and perhaps you and Mike can walk us through what you designed and went through to feel comfortable moving forward. Want to start?
Sure. This is a photograph of the physical mock-up testing in Doha, Qatar. They're testing here for, this is a Canadian standards test, and for this particular test to work, it has to be done with an 85-inch fan. And so just the procurement of an 85-inch fan was a bit of it was quite a process. But yeah, no, on the right-hand side there, you can see the window system that's being built, and they essentially they'll seal the window system. They'll seal a two-story mock-up of the window system and basically submit it to atmospheric pressures, high pressure, low pressure, and then blast water at it with this fan that it's it's 85 inches. When when this fan went on, the entire building that this mock-up was attached to started to shake. I don't know if we can see the videos on here, but the videos that we took of this were really quite something. It's so this is as I said, this is one of the tests that we had to do there, and that was a real experience. I think that Joel's touched upon a really good point, is you really need to identify all of the tests that you need to go through to get your certification. We've been meeting with the contractor weekly, for a year and a half. I think we're up to meeting number almost meeting number 80 now. So it's been a long process.
You mentioned Qatar, and I think most people, especially in Vancouver, you say overseas, they're thinking other places. What was the purpose for going to the Middle East?
This particular manufacturer is very well known in the Middle East. We were introduced by our owner, who knows some of the people behind who were in the ownership of this particular company. It's technologically, some of the things that these guys are doing and some of the buildings in the Middle East and around the world are really head and shoulders above what we think of a standard, as just a standard window system. They've come up with a way. They did the windows at the National Bank at Qatar, and it's four towers, two 70-story towers, and two 50-story towers, and they've devised a means by which they cold form the glass and essentially bend it into they take a flat pane of glass or triple glazed pieces and snap them into a bent frame to get the building twist. It's really a remarkable thing to see in person, because you just can't really figure it out until they explain to you what it is. But the technology that these guys have available is really remarkable, and I'm looking forward to seeing some of these elements make it into the British Columbia, into the Lower Mainland here, because it's really quite something to see what they've done here. We'd like to think that we're a very leading edge place, but compared to the night line or the night sky in there, it's really I think we've got a long ways to go.
James, your business has rapidly grown in the last several years. Cost has been brought up as a factor. Would you feel there's anything else that has contributed to your growth?
Yeah, I guess I can start with a phrase that one of my best friends is saying all the time, and that is, you don't get what you expect, you get what you inspect. So that essentially means that controlling the process of the job entirely is extremely important to the project.
Can you expand a little bit on what that process is and looks like, and not all of its intricacies, but some of them?
Well, Joel started with the mock-up and the bespoke systems, having new dies and stuff like that. Agree with that. Testing is important, but just as important, selecting the proper lab that has a fan and doesn't need to procure it, has all the right certifications, and the right people, running the test. Just as important to have representation of project consultants in the lab to validate and see through.
And when, from your perspective, how early on in the project does this need to happen before product would get on site?
A year. I would say a year. Once the testing is done, there's always a learning experience in a test. So there's always something that goes wrong, something that needs to be improved. So allowing the time to develop the changes and potentially, do small in situ testing, to validate whatever changes are made, that time needs to be allowed and needs to be accounted for.
Rodel, that ties into you. You get the privilege and luxury of keeping everything on schedule and ensuring that the architectural designs that we saw this morning actually come to life as you're managing Oak Ridge. How do you feel this all ties together in reality of the on-the-day job?
I think everyone touched base on this. Excuse me. That time is our friend and our enemy. We need as much time to deal with these bespoke systems, right? Whether it's getting the manufacturer, the supplier, all their dies to manufacture and run a PMU, check all their ASTM testing or do equivalent testing overseas. We need that time, and that time, a year plus is the way, it should be if we're looking at overseas.
And what happens to that time when one or two areas do not get provided the sufficient time needed? How does that affect the end result?
I think we all know how it affects the end result. The goal with overseas is getting panels for when structure or any other structure will be ready. Taking it back to the very beginning again, right? There's lots of checklists along the way that need to be completed and checked off, whether it's testing and PMU, and God forbid the PMU test fail, what that means. So it's having all that time up front to run through that and all our contingencies.
So it was touched on earlier in a previous panel and segment that there are city challenges, there are permitting challenges, there are costs associated. How does that factor into giving enough time across the board while, and Mike, maybe you want to answer this, while maintaining the cost association to finish on budget?
Mike?
Well, again, it's pre-planning. It's the whole thing, and making sure that you've allocated enough time. You've hopefully had enough lead time to get the thing there, and ensuring that you don't have any hiccups when windows certainly do arrive. One of the things we did was we made sure that we had a supply and install contract as well, because we're familiar with we're familiar. We've heard some stories about the times when you get an overseas window system that's just basically a supply only, and the things ship over here, then you have to go through an entire new evolution process for the installers to try and wrap their minds around it. So this particular system was taken from an American system that they had sort of worked with the installer here to streamline for the lower mainland market, and the installer who helped design the system is also going to be installing the system. So hopefully we'll be able to achieve some of the the savings in that time savings that way.
Since it's the last panel of the day and everybody needs to be kept engaged, we might as well talk about some of those challenges that present or struggles that have happened from procuring product overseas and bringing them to site in good order and in the building. I'm sure we have some stories. James, you may have a few that we could discuss.
Yeah, for sure. a few. Well, one of my favorite stories, or least favorite stories in this case, is a project that was done overseas. Everything was, the process was followed, everything was done. And when the product showed up, considering it was 2 towers, the product showed up by elevations, not by floor. So I think we can all imagine what that does, right, Gary?
So in situations when challenges arise of this nature, how would you fix it?
Once the challenge arises, it just cost, right? It's labor, and it's extremely detrimental to the project and to the client, supplier relationship and everything else, schedule, finances. So the best approach is to control the process from end to end and to make sure that the supplier performs as designed, as planned. And that's essentially it.
You make it sound so easy.
Yeah.
It sounds like it's all to be educational, and the more education provided, the better, and the more communication, the better. But when situations go wrong, and we're all in the construction business, things do go wrong, how do those conversations yield towards the next one going back overseas, or potentially having a discussion where someone perhaps could be snake bit?
Well, I think, when something like that happens, this is essentially the end of the relationship with that particular supplier, right? And the question of going back to overseas, you can take those lessons, you can learn from them, you can have the foresight that you need to advance your next project, or you can step on the same shovel again.
So without giving us the details of why you've chosen who you've chosen, James, your business is unique compared to some in the room. Why have you gone the route that you have in your business model?
Control. We control our own systems. We control our own design. We have an entire QC team present at the places that we fabricate. Every frame gets inspected by our personnel and then gets shipped over here. After experiencing this with other suppliers, I learned that that's the only way.
Rhoda, how do you manage the amount of not just window wall or curtain wall, we're talking entire facade. How do you deal with all of the challenges of the product arriving in a timely fashion with the constraints of limited space?
I don't get to give a horror story?
Oh, you can give as many as you want.
Yeah. No, so, the goal is to get the material here. Whether or not there's space on site, that's part of the discussion for procurement, overseas procurement. What happens if material comes early? Do we have a warehouse, a local storage for that, right? And I'm sure in your industry and yours as well, James, that you've encountered demurrage.
Yep.
Right? And that's one thing that needs to be discussed. And overseas procurement and shipping, you could have a whole session on that, because how you set up the shipping terms and contracts, who's dealing with what, whose liability, who's responsible. That is a full day session on its own.
It sounds like there's a horror story there that perhaps we could just peel apart out of.
It's through hard learning, yes. But, on this topic, one thing we overlook is the packing and the shipping, as James mentioned. And sometimes you may forget to have that conversation, or you might not have enough time to have that conversation. If that conversation isn't had, you might end up with a container full of panels for one elevation only.
That's my horror story.
Was there any, amongst the group and all the situations, were there any horror stories dealing with the shipping crisis during COVID?
Absolutely.
Yes.
And how was that affected, or did that inhibit, Mike's schedule of sorts?
James, you or me?
Go ahead. I'll catch up.
Well, I think, with COVID and the whole blocking of the canal, it changed the course of how we were going to ship, right? Prices skyrocketed. Our timelines or our durations for shipping doubled, if not tripled. And we took those numbers into estimates, and it worked out for the better, where eventually everything came down. But there was a period there for about a year where something major like that, the blocking of the canal, had interrupted things for about a year.
Yep. Essentially, through proper planning, you can overcome, right? Cost, on the other hand, is definitely a big risk in overseas procurement. So planning for it, shipping the material ahead of time is extremely important. When the shipping costs go up 3-4 times, let's say, like they have in the past, that creates a ginormous impact onto the cost of the project, cost to the client, cost to the supplier as well. And without proper planning, everybody suffers.
It's a similar sentiment in every which way, and it sounds like throughout these difficulties and challenges, though there's always a little bit of a rainbow at the other side. How has that improved your business model moving forward after dealing with those challenges?
Became more agile, able to turn the company and change direction extremely quickly without compromising the quality of the schedule. Obviously, some financial losses have to be accounted for during the budgeting process, and in order to protect your client from such, providing insight to the client on advantages of shipping early and what that does and how that potentially offsets the cost of, another force majeure that may happen.
Mike, we spoke a little earlier outside, and you rattled off half dozen, 20 projects that you guys have underway or in the pipe or in the future. And how many of them would you and your ownership group consider taking some or all product overseas in one shape or another?
We're looking at overseas procurement for every aspect. We've analyzed their entire, every division to see what can be done and where we can achieve any savings that we can. As we discussed the economic pressures upon developers right now, and certainly residential developers who are trying to make their performance work. It's just we have to do it. We're really the market is pressing us. The market is pressuring us to do that, and that what we'll need to do is you need to have the ability to basically, as these gentlemen have talked about, get the material here early, make provisions for storing it, make provisions for potentially double handling it, and that way, it's. I very early in my career learned another, an adage that you'd rather be looking at it than for it. So making sure that you have the material there when you need it is really the key. But it's again, and again, living here in Vancouver, it's before 20 years ago, before the overseas procurement was done, there's just as many horror stories for just for window systems. There's just as many horror stories that exist for window systems that are being shipped here from Toronto that exist from window systems that are being shipped here from overseas or some of the other from overseas or Europe or Asia. So getting things to Vancouver has always been a challenge, be it because you've got the border, the mountains, and the ocean.
All the horror stories aside, the positive side of procuring from overseas and not just cost. We saw some beautiful renderings today and designs and architectural schematics. I would be led to believe that some of these unique designs are being led into the fact perhaps that there are some greater capabilities other places in the world. Joel, would you?
Yeah, I mean, I would agree with that. That's my experience when I said the bespoke systems is, my experience with a lot of the, North American local suppliers is, any color as long as it's black, take your pick. And whenever we were looking overseas, it was like, what do you want it to look like? We can, make the new extrusion and make a die and have it out in like next week. And when we'd actually go and visit those facilities, they would have dies all over the place. Like just, you wanted it, you could think it, they could make the die and pull a new extrusion. The willingness to do it, they were set up to do that. It's just how they thought. So I would, I don't focus too much on the creativity side of it, the aesthetic side of it. It's my interests are more on the performance end of it, but it really the same thing. You wanted a little change to improve performance, no problem. They could do that and do it quickly.
And Rodell, we had talked about that a little bit earlier outside as well. And what's your feeling and experience on the flexibility of sorts?
Yeah, I echo Joel there. There's a willingness and capability there compared to local suppliers sometimes, not always. And then not only that, there's the speed at which they can do things, right? Because there's so many more suppliers, so many more die cutters, it happens much quicker over there. I echo Joel 100% there.
James is nodding.
Me
yes.
three. Yeah, I mean, a lot of the testing we've done overseas, we were actually able to extrude new gaskets in 24 to 48 hours and have them re-implemented and continue with the testing, which is obviously a huge advantage.
So from everyone's experience, the capacity you feel is greater, which would lead to obviously some flexibility in time in production, as well as, for example, if something was to be adjusted, do we feel that there's more flexibility in shortening that time frame for production as opposed to potentially a very long lead time?
Uncomparable, honestly. Another advantage is access to materials, implementations, things like stone into the curtain wall, for example, which is becoming more and more popular on the buildings. Access to metal finishes, different materials entirely, is all there, is all available at much lower cost than it would cost in North America.
And certainly with the push towards modular construction, there's a lot of modular elements that people are looking at right now. The modular systems that are being employed worldwide are a lot sort of more complex in Europe and some of the stuff that's being built in Asia than we have here now. That's another thing that's, we're looking at as well, to incorporate that into our buildings to try and, you're just basically moving some of the construction time off the site.
Yeah, at the end of the day, you're just moving time to a different sector of the project.
Exactly.
I would add that knife also cuts both ways. There's a lot of flexibility and things can change quickly, but sometimes things change and nobody's expecting them to change. So I don't want to say cat and mouse, but sometimes, something wasn't available, so we made a new gasket, but nobody was aware they were making a new gasket, or suddenly an extrusion changed a profile that wasn't what was discussed, reviewed, tested, approved, etc. And so the flexibility is great, but be aware things can change unexpectedly, and that can really throw a wrench into the works.
Well, I think that would tie into the communication
and control.
And to James's point, having QA QC on the ground, right? I mean, at the end of the day, working on a different time zone can create its complexities.
Correct.
James, there's a few slides here of some of the projects that you have done. Would you care to give us a skip ahead? Who's got the controller? No? See, last of the day, someone forgot the controller. That's okay.
I know. Here's some more testing, ladies and gentlemen.
Yeah, that's the big structure behind the one you see on the angle there. That's the PMU for the Lusail Towers. That's the Bank of Qatar. It's an amazing building. That's the world's largest anodizing system. They can anodize pieces of aluminum, I think, up to 24 feet. This particular machinery basically measures glass for imperfections at a molecular level. It's quite you can see the incredible stuff that these guys have.
Okay, well, this is one of ours. The project is located in New Westminster. The name of it is Pier West. 2 towers, 58 and 47 stories, roughly. Window wall product, more or less typical window wall that we see here. Larger thermal break, great performance, lift and slide doors. The entire project was fabricated during COVID in South Korea, and it is now basically complete. Well, South Korea again, except that beautiful project on what is it, left for everyone. So when we won the project, there was a lot of elements in the job that made us really scratch our heads, i.e. stainless steel bead blasted inlays at all the slab bands. Lighted soffits with a very complex structure that needed to go in and out of the facade. Had to implement the LEDs into the channels. Initially, they were in the metal panel, which is generally very counterproductive for a building, as it does leak anytime you make a penetration through a horizontal surface. So we put it on the outside of the window. The podium was designed in 3D entirely, and the material for the podium came from Italy, China, Germany, Turkey, and South Korea as well. This is a West Bank project located in Horseshoe Bay, West Vancouver. Extremely complex project, a truly bespoke approach, because we had to take a curtain wall and design it into a punch window.
No small task.
No. On the left there is a horror story. But it's done, therefore looks beautiful. This project over here is Pendrell, once again for West Bank. I think this was part of Brian's presentation, where this is a curtain wall that had to be applied into a building with staggered balconies. So one of the very important steps to take in using an overseas procurement is to pick the right system for the right building. Not every system can do what you want it to do. It doesn't all start with a look, right? Yeah, Joyce, also South Korea. Fairly simple project, albeit beautiful. Punch windows and lift and slide sliding doors. Dallas Sky, I want to say it's a horror story, but it's more like a Cinderella. It was extremely tough, extremely complex. The project was actually supplied by a company out of South Korea in partnership with Shuko, and we were charged with design and installation.
It sounds like as much as there are horror stories, there are, to your point, Cinderella stories, and overseas procurement is probably somewhere in the middle at this moment in time throughout the course of construction. So we're a little bit early, and I'm sure everybody is ready to have a drink. Unless there's a question or two, we'll end the segment. Go ahead.
In the huge stack of risk involved in a long timeline delivering these kinds of systems, foreign procurement, you've got changes in raw material costs, changes in shipping costs, unpredictability in shipping, changes in capital markets. What are the hedges available to you to eliminate those risks?
A strong contract is really the best way to describe that. It's all, a lot of it is, so much of it is risk allocation, and you just make it clear in your contract who's responsible for each.
So no financial.
There's nothing we've done. We just make sure that we have a very strong contract.
From the supply side, you can look at currency hedges, but it creates difficulties on the length.
Shipping, unfortunately, is just an exposure and it's risk. You can hedge raw materials, but I think we're also a little bit being too optimistic about local versus overseas supply these days, because I believe that everyone's supply chain is pretty wide these days. So when the shipping goes through the roof or aluminum, escalates, I believe that everybody is now affected. Truly.
Any other questions? Otto?
That's a very good question. There's the development process is essentially getting a budget through a series of gates, and unfortunately the at a very cynical level, the 20% savings that you may have encountered at the first or second gate, you have to, again, it's what this gentleman asked about the risk, what you can do to mitigate the risk, but that's I don't want to say, well, that's I work for a developer and so it's all my responsibility, but it's coming out of someone else's budget is the very sort of cynical response. But you're right. But to be honest, I've been working residential construction development for, as I said, for 32 years now, and the situations where what you've described, where you've got a tower that's topped out waiting for windows, there's just as many experiences I've had with Canadian window suppliers than there has been with overseas. I've never been involved with an overseas one where that's happened, but I've certainly been involved in 2 or 3 ones with a Canadian window manufacturer over the years. So I think it's the risk is there, regardless of where you're getting your windows from. And I think that now, as was alluded to, the supply chain, the supply chain issues are so global, and everyone, if everyone feels these pains, if there's the Suez Canal getting blocked, I'd forgotten completely about that.
Yeah, we're now onto the Red Sea.
Yeah, we're now onto the now we're down into the Red. It's just gone to a little further south. It's but yeah, it's really a challenge, but something you just have to take a gamble on. It's certainly, yeah. I mean, the company that we're buying for the windows from is a Canadian company. The company that ultimately the windows are coming from is a Canadian company. The installers are a Canadian company.
Like I said, half the room for, half against, some in the middle. It's good. One more, yes, of course.
Can I?
Go ahead, yeah.
So first of all, system design to allow for extra deflection and extra movement of the building. Number 2, the measurement, the site measurement was only available with one company. I'm not going to name it, but anytime windows were coming from Toronto, there was no site measurement. It was always shop drawings.
That's very strong.
We do. Yeah. We fixed everything here.
Sorry,
we always
Rodel,
have extra parts, extra materials on site, ready to do whatever it needs to be done to remodify a frame and continue with installation.
Rodel, sorry, you were saying?
He's exactly right, and that's where the strong installer comes in, right? They are the ones that will eventually install that system, so they will be intimate with it. They will know how to correct it, right? And that is one thing you want when you have a split supply install, a strong installer to back that up.
There was a sub-question.
I think that
we
can take those
okay,
outside.
sure.
That's the separation between the end of this and perhaps the beginning of the drinking. Well, thank you all for this interesting panel. And I wanted to remind everybody that needs to sign for the AIBC AIA credits. The sheets have changed places. They're at the back over there on the table. And for AIBC, you need to sign for every session. So make sure you sign the 4 sheets. And then I will leave. Oh, you're all set.
So, thank you all for attending today's event. I think a round of applause for Sophie. She was excellent for hosting today's event. As I said this morning, we've recorded today's event, so you can watch the recording of today's event at the YouTube link we provide. And until we meet next time around, I hope you enjoyed today, and I see you outside for drinks. And the AIBC one is where the outside buffet was, not inside this hall. So outside where the second buffet was, that's where we've kept the AIBC and AIA signing off sheets. Until we meet next time, thank you all. Can I have from Rainers on stage, we'll do the mementos, and then we'll meet you all outside for a drink. Thank you all.